Okay, hello everyone. My name is Adam Królewski. I am here with my colleague Eva Mika.
Hi.
We are Scrum Masters at KMD and your hosts for KMD Tech Summit 2022. We are very happy to welcome all of our guests at the office and all of our viewers at the stream. Should you have any concerns, questions, please don't hesitate to go to the reception or to us. We'll be very happy to help you. Yeah, and with that said, let's go to the agenda.
Yeah, so we have a lot of excited stuff planned for today and a lot of great speakers. So firstly, we will hear some keynotes. Then we will have a lunch break, and the keynotes will be performing here on the stage. So as you can see right now, nothing will change. And then after lunch, there will be changes. So the room will be splitted for 2 different tracks. So please keep your attention to the details that will be on the doors, so you will know which room to choose to hear your speakers and the speeches that you would like to see today. And after those 2 tracks, around 4 p.m., we will meet here all together again after a short break, and we will hear the closing speech. And right now, please give a warm welcome to our colleague, who will tell you a little bit about KMD and
yeah, a warm welcome to our Managing Director at KMD Poland and Vice President at KMD, Dariusz Kubacki.
Thank you very much. We've been waiting for this day for a long time. This is the 2nd edition of KMD Tech Summit, a really great and important event for us in KMD Poland, but also for the whole KMD group. The whole day of very interesting and inspiring presentations, case studies, and different types of discussions. I hope you all will enjoy. It will be about technology, it will be about agility, it will be about artificial intelligence, but most importantly, it will be about the future. And let me start maybe with a few words about KMD for those of you who don't know, because we have also a lot of external guests. So KMD is the biggest Danish IT company and probably the oldest Danish IT company. This year we celebrated 50 years of existence in the society, and that is really existence in the society because if you look into different ranks, then you will find Denmark to be the most digitalized economy in the world, and I think we may say that KMD made it, or at least contributed significantly to that achievement. And now being owned by NEC, a global Japanese company, we create quite a nice mixture of Danish, Polish, Japanese think, and our ambition, aspiration is to move with the digitalization and technology outside Scandinavia, even maybe outside Europe. And here in Poland, we've been established back in 2015, and since then we have more than 600 experts and IT or technology passionate people who are ready and definitely contributing to the big things which KMD is doing. And KMD is doing in many sectors. We are very famous of public sector and public sector digitalization, but also finance, banking, energy and utility, and some other sectors. So that's the important role we play. And on behalf of all the organizers, I would like to welcome all of you who are here with us in the room, but also those who sit in front of their laptops, being with us online to this event. We have great speakers, Aleksandra Przegalińska, Łukasz Pyrzyk, Kacper Nosarzewski, Natosha Bart, but also great colleagues from this office who will also lead some discussions and presentations during the day-to-day and within the tracks. So I really hope you will enjoy. I think you will have a great day with KMD people, but again with technology being focused on the future. Thank you, and wishing you really a good day once again.
Thank you, Dariusz.
Okay, so
now it's time
as
for...
we are as
Sure.
we are still waiting for our first keynote speaker, we will have a little bit change in the agenda. So we will start from our CDO
this will be a speech about KMD tech and innovation trends. We'll take a look at the horizon and see what do we want to get involved with in the near future.
Our speaker has over 20 years of experience in creating different software and working with different software companies. Right now, she is the CTO of KMD and a Senior Vice President of KMD Group. Please give a warm welcome to Natasha Bart.
Hi, everyone. Hi. Okay, so I know there's a lot more people online than there are physically, so hello to all of you. But I'm also glad that there are people here physically. When Corona hit and I had to do a university lecture the first time to Zoom and there's no physical audience, that was the most challenging experience ever. So I'm at least happy for the mix, but also really happy about the fact that we can now reach a lot more people and share ideas with a much wider audience because we know how to work in this hybrid world. So look at society using technology to adapt. So today I will talk about some tech and innovation trends that I and my colleagues in KMD CTO office really believe are key to the next few years. I'll try to cover, I think, a bit of background of how we came to these conclusions and the trends at a high level. I won't dive so much into the specific technologies, but I can say that we in KMD Group in the CTO office will like to do a lot more kind of following communication about specific technologies and trends in more detail in the coming times. So first, yes, it does work. So just a little bit about me. I don't have a link to LinkedIn or anything on here, but you're welcome to add me on LinkedIn. My name is quite unique, so you'll find me if you want. But the reason why this one is here is to talk a little bit about my background, because I think that shapes a lot of how I think about technology and the way that it impacts the world. So of course, right now, I'm very, very happy and proud to be part of the KMD group and part of KMD's top management team. And I think my role there, of course, is to think about technology strategy, especially where do we believe the world is going and how do we prepare ourselves for that? But also this understanding of technology and how it needs to also impact business strategy, which of course is also quite important. And I've been at KMD for 2.5 years now. And before KMD, I spent almost 10 years in the video game industry. So I worked for a company called Unity. When I joined it, it was a startup. It's not that anymore. But that was quite a different industry, right? So, and Unity was a very innovative, market-leading, like actually a very, very market-disrupting company for the industry that it was part of, right? So it was a very different type of company than KMD is. KMD, you know, we have half a century of history behind us, and it's because of the work that we have done that, as Derek mentioned, you know, is Denmark has the most digitalized public sector in the world. So these are quite different experiences. And before Unity, I've worked in a few places, but I actually worked for a while for a company that made scientific research equipment. And so I did a lot of embedded software development there. And as part of that, I worked with NASA. So KMD is actually also not my first experience working in these very highly regulated sectors, right? So these are all very, very different experiences. And the reason why I mention all of this is because I've come to very much a conclusion that the coolest thing about technology is that you have the ability to impact the world by the way that you use it. But also that I believe that companies should exist for a reason. They should exist to solve problems in the world or to make the world better. And that we need to understand from a technological perspective, how is our use of technology like achieving that purpose? And my education, I don't have a business education. I have a technical education, and my career started as a developer, right? So I totally understand the fascination with the technology itself and understanding how it works and how to use it, right? But I think from a maturity perspective, and if you want to have the biggest impact that you can on the world, it's important to understand, first and foremost, how actually can you use the technology to achieve like the purpose that you want, right? So this kind of, you could say it's a customer-centric, it's a human-centric, it's a market-centric approach to understanding technology and what's happening in the world is really, really important. And I think whenever you think about a company like the KMD group as well, our biggest asset is actually our domain knowledge, this history that we have in understanding the markets, the world that we work in, and understanding our customers, right? So it's important to understand technology in that context. So I'll start out by putting up a picture of what we in the KMD CTO office call the KMD Technology and Innovation Map. And I want to spend a bit of time talking about kind of how we came to these conclusions, because it's very much in line with what I talked about in terms of my own personal philosophy, right? I mentioned that I didn't go to business school. Luckily, I'm happy to have people in my team who did. That can also bring this very market-centric view also on how we should drive both technology exploration, but also an innovation strategy to KMD and our customers. So we actually started by first wanting to understand what is the technology landscape in a KMD context. So what we have is a mapping of technologies based on both maturity level. So you could say in a KMD context, the technologies are more mature, more well understood, the closer they are to the center of the circle. And then the further out, they become a bit more conceptual, so they're maybe less mature, especially from in a KMD context. So we worked very hard to understand technologies from two perspectives. One being how well does the KMD group understand this technology? What is our experience with it? What is our maturity level? But also what is the understanding of this technology from a customer and market perspective? And that's extremely relevant because we work in a number of industries that are very, very highly regulated. So most things in pretty much all solution areas in KMD you can think of kind of fall into digital government, so working with the digitalization of municipalities or central government, or within kind of climate and energy and utility, or within FSI, digital banking, right? These are all very highly regulated industries. And although there's a lot of technological development happening in them, in a lot of areas, there's also very slow moving whenever it comes to adopting new technologies. So it's important that we don't understand technology from a pure technological standpoint, but that we understand it also from the perspective of our customers and how they see that technology, and most importantly, how ready are they to adopt it in a solution that we deliver them, or we deliver to them. So the CTO office led a very long and quite in-depth process of understanding actually a lot of work with a number of different business specialists across the entire group that work in these different sectors. And then also, of course, the technology leaders across the group as well that have experience with specific technologies and solutions in these different sectors. And there was a long process to understand what are the kind of the common patterns and what are the common insights that we came with. And the purpose was to try to understand what do we think is happening in the world with the customers that we deliver to that we think will impact how we should think about and focus and prioritize our work with technology for the next period of time. And so through all of that, we came up with 5 trends that I'll talk a little bit more about one by one. But I think it's important to understand that this customer and user-centric understanding of technology is the reason why we would take a technology and put it perhaps in a different maturity level than you would see if you took the same technology and looked at where it was on the Gartner hype cycle, for example. The 5 trends, of course, that we come up with are the multi-cloud future. That's one that I focus on right now with a very high sense of urgency. I'll talk a bit more about that towards the end. Open standards, user empowerment, data spaces, and enhanced decision support. Yeah? So if we spend a little bit of time on the first trend, open standards. So from a kind of a definition perspective, open standards are standards made available to the general public. And you can say that they tend to be developed or at least approved, regulated, and maintained by some kind of collaborative or consensus-driven process. There's often organizations that are established to govern them, for example. And the reason why I think they're important is because they basically are a way to facilitate communication, the exchange of data, and cooperation between different software systems. I think they're important from a technological standpoint because they can allow us to, you could say, future-proof solutions so that we can build upon them rather than have to re-platform them constantly. And then that's also quite important from, you could say, a business future-proofing perspective as well. So, I mean, driving openness in the implementation of our solutions, I see that as something that needs to be part of our day-to-day decision-making whenever we work in development organizations across KMD and in general. And this means really trying to develop, build, and architect our solutions in a way that we can build on top of them, that we can reuse, we can replace components, And whenever this can be done by following officially established open standards, then obviously I think that that's the better, because it establishes that our solutions are built in a way that they can be expanded within a context that's not only our own. So overall, it's a way to, I would say, kind of increase, of course, the ease of internal collaboration, but also improve maintenance burden, and is also a way to drive openness, towards your customers and towards your users as well. Create something that they can actually collaborate with you. People who know me know that I'm also actually quite a big fan of open source. I have a very, very strong Linux background. I have experience establishing open source projects and contributing to a number of them. I think that this is actually something as well that companies, even companies that make proprietary software solutions, need to understand and also embrace, because the core value add that you deliver as an organization, and it's very much true, I think, for KMD, is how to use technology and create solutions with the domain knowledge that you have in the context of your customers. So that means that you shouldn't be afraid, I think, of open source. And it's also something, I think, that as Europeans we have to be prepared for as well, because there's a strong trend within the European government and pushing this agenda as well, right? So it's one of those things where I think you can sort of be proactive and actually help drive the agenda, or you could be forced to follow along. And I think it's always much better to be in the first category. So from a technical perspective, what would I say personally that I believe that open standards really mean from a more architectural standpoint? So I think it's about modularization of solutions, shifting towards modular component architecture. I'm a big fan of, I was a big fan of a microservice architecture before we kind of got into the modern microservice theater that we have now. Is maybe a little bit too far, but I think in general, modular component architecture is really important, so that you can actually replace and modernize components of a solution without needing to replatform the entire thing. Then I think open source is a really important element of it as well. Of course, most companies use open source components in one way or another. It's pretty hard not to. I think you should also be willing as well to contribute and even publish open source components as part of your development life cycle. And then I think, on the other side of that's key to scalability of your solutions. It's key to reusability of your solutions, future-proofing your solutions in your business. And then I think also whenever you work with openness in this way, it's also a way to be very open in collaboration with your customers. So, from an innovation perspective, this is a way to create the possibility to innovate, I think, much faster, much more openly together with your customers, and actually have much faster, a much shorter life cycle of actually trying out new proof of concepts to see if that actually works in a particular technical domain. So I think in general, open standards is something that should govern the technical decisions that we take day to day. In the CTO office, we have a particular interest in the FireWare technology, which is a big focus area also for our parent company, NEC. And one of the reasons why I think that this is interesting is because that it's actually a means to deliver both on an open standards agenda, depending on what kind of data you put into it, and also the data spaces agenda. But I think it's the way that we can use technology to connect people even across society, collaborating between companies and companies and customers is a really powerful way to drive kind of the next generation of the digitalization of the society that we work in. I mentioned in general open source. It's very dear to my heart. If you have no experience with it, just look up the Open Source Initiative. There's all kinds of things that you can find out there. So it's just, I wouldn't say that's a product placement, but it's something to get you thinking. To think a bit about user empowerment. So user empowerment, this is the next trend. So this is really about giving users power and control of their environments, right? I think in the context of the solutions that we deliver in KMD, it's especially about allowing our customers and our users to configure and customize their solutions as much as possible, preferably without having heavy technical knowledge, because let's face it, most of our customers don't have heavy technical knowledge. And it's about exploration and understanding of how to interact with software and technology systems in different and more innovative ways. And this is, I think, especially important from an accessibility angle. Three interesting things here, right? So when you think about user empowerment, one of the things that's happening in the world right now, we definitely see it, of course, in Denmark, is that we have what we call a growing elder population. So we're in this kind of weird transition stage, you could say, where we have a very large, so a disproportionately large part of the population is aging, and it's not an inherently digital population. So it's not a, the generation that I'm from is kind of the last generation that kind of distinctly remembers before the digital age, and we saw through the transition, but I've lived a huge proportion of my life in that world, right? But we have this growing elder population that is not an inherently digital population, but needs to live in this digital world, right? I think we take a lot of things for granted about what people have and how they understand how to interact with solutions and with technology in general. We see this, for example, in Denmark, where we have a national identification system, and we have just switched over to the next generation of this, and it has, there has been an assumption that everyone has a smartphone, and that's a fairly safe but not completely safe assumption. And the oldest population in Denmark has actually been the one that have struggled a lot with this transition, right? Because it's not something that we have, admittedly, as a society, that we have probably thought enough about. But we need to be aware that, life expectancy is increasing, and this population is here and will be for some time, but also that technology changes so fast, It's hard for me to think about the fact that my kids, they will never know a world before an iPhone. They will never know a world before a smartphone, right? And just think, how will it be in 10 years and 20 years, right? So we always need to consider the fact that the digital age changes so fast now, right? That there's quite a range when you consider how long people live today that we need to be able to cater for. And there's also a huge impact as well in terms of the globalization of society. So, of course, the internet changed everything about how we communicate with one another and the exposure that we have to other cultures and languages, but also just in terms of accessibility, from being able to cater to people with different cultural backgrounds, but especially language, I think is a key thing as well. And then I think both from a customer expectations perspective, in terms of how we think about empowering our customers to be able to configure their solutions. They want to be able to do more themselves. They don't want to have to come back to us or to any other software vendor and have us do all of the work for configuring and customizing solutions as they change. And I think from a business perspective as well, when you work in the industries that we do, where you need to deliver very large solutions and there's a high customer implementation cost, it's also good business to think about user empowerment in the context of allowing users to actually configure solutions themselves. Yeah. The next trend we'll talk a bit about is the data spaces trend. So data spaces are an abstraction in data management that aim to overcome some of these problems that are traditionally encountered in data integration systems. So the aim here, right, is to try to reduce the effort that's required to set up a data integration system by relying on existing matching and mapping of data generation techniques and to improve the system as it is used. So the idea is that you basically create a standardization around how you store, how you share, how you expose data, but you actually implement how you do this as it's needed, right? So you could think of this actually as sort of the context of open standards, but in the context of data. But given the amount of data that we have in the world, and especially the digitalization of society, and the amount of data that's stored just in general, if you look in the energy and utility sector, for example, we face a very different world than we did in the past, where from meter perspective, you know, it used to be that in order to pay your utility bill, there was somebody that came out to your house once a month and wrote down, okay, this is what the meter says. Now, you know, now we have data that's being stored automatically, like every 15 minutes. How do we handle and actually share and store and use this data? And we have it just all over the place as well with the Internet of Things, and we have sensors, and we have you know, the possibility of digital twins and smart cities. You know, we need to have a common approach to how we manage this, and we actually have this as a focus in the European context, right? So there is, of course, a European strategy for data, and this is a focus that the European Union has on creating a common European data space, a single market for data, and they have a few different industries where they have a particular focus and expectations around on where this should happen. And the idea here is that the common European data spaces need to bring together the relevant data infrastructures and governance frameworks in order to facilitate data pooling and sharing across European countries. And you know, it's meant to deploy data sharing tools and services for this purpose, and allow us to actually federate energy efficient and trustworthy cloud capabilities as well. So if you're like very interested in the evolution of how we do cloud computing in an open European concept, the European strategy for data is actually a very relevant thing there. This is also, you know, expected to kind of include data governance structures. So this connects how we govern data in a European context to European legislation. And in general, you know, this is a means to actually improve the availability, the quality, and the interoperability of data between different, you know, within a given country, but also across the entire European Union. So this is another thing where I think this is an agenda that you either have to be part of, or you would be made to be part of it at some point. And just like the open source thing, I think it's much better to proactively be part of it rather than be made to be part of it. And this is a particularly interesting and exciting one from my personal perspective, because you know, in KMD we have the advantage due to our positioning in the Danish market, and also given how much digitalization we have in the Danish society, to actually be a driver on the open data agenda in the Danish public sector. And I think it set an example for the rest of Europe. And the way that we have already, you know, the first parts of this within a Danish context, I think, you know, we're very well positioned as a company because of our size and our history to take a proactive approach to this dialogue. You know, and if we're very smart about how we do this, then I think, you know, we enable a lot of things. We enable faster and easier innovation in a data-based context. This, you know, we can actually find opportunities to enable AI and machine learning in a number of solution areas that we already work in. And this is all just more like value addition, right? To using technology to make better solutions and create more of a positive difference in the world. So, you know, you could talk about the context of a Danish data space and what role do we play in that. You can also talk about the context of just a KMD data space and even how do we internally learn how to lean into that in a much more efficient way than we have in the past, using all of the learnings that we have now. Yes. We'll talk a bit about enhanced decision support, the next trend. Now let's check where I'm doing. Okay, I'm okay on time. So enhanced decision support, you could say this is basically, you could say it's about AI and machine learning, but I think in general, you need to think of it in the context of like, this is about how we use and develop technology to allow our users and society in general to make better decisions, right? So in a KMD context, this for us is heavily about how do we use AI and machine learning into our solutions. And I find this very, very interesting from a strategic perspective because there are all kinds of opportunities you can use technology to help make more fair, efficient, and more accurate decisions. So a lot of people are, you know, have been kind of afraid in a number of ways about AI and machine learning and what does it mean and do I trust a computer to make decisions about X, Y, Z. And then, of course, that has pushed towards a lot of dialogues around, okay, but what about white box AI? How do we make sure that AI is explainable so that we can understand it and we understand how it comes to the conclusion that it does? And I think all of that is really, really good. And I think also it's important to understand the conversation that's being had here also at the European level because, you know, there are regulations that are coming around how we can and cannot use AI in software solutions. And especially whenever the decision, you could say that the decision that is being made is something that has a significant potential impact on people's lives, of course, then there's a higher risk if it's not implemented correctly. But I think all of that's actually fine and very fair, but I think it's important to understand and think, and much more exciting to think about the opportunities that are created through this, right? We have the ability to actually secure that people are being treated fairly, that a decision that is being made about you, opportunities that you're being given, is not based on the mood of the caseworker that you have handling your case, but on a number, or at least is guided by a number of objective factors. I think whenever you think about, you know, the sort of historical inequalities that we have seen in society, I mean, I'm really, really excited about the ability that we can actually have to impact how people are treated in a much more positive and much more fair way through this. And there's just a number of different, you know, no matter which kind of technological domain you work in, there are opportunities here, right? So if you work in the financial sector, you can think about one of the things on the map is anomaly detection. Well, that means a number of different things, but in the financial sector, you can think of that in the context of fraud detection. Automated case handling, I mentioned, for fair case handling and decisions. Then if you think about energy and utility, being actually able to lean into, I don't know if we can, I guess we can't solve the climate crisis. Probably the ship has sailed on that, but we can at least try to be as proactive as we can about correcting course. And I think technology and using technology to drive that is a key opportunity that we have as creators of these systems. And then I think it's important to think about that, you know, when we're talking about AI and machine learning and enhanced decision support, the human aspect of this is really, really important, right? And I think that it's also kind of the counterpart to what many people are afraid of whenever they think about AI and AI-based decisions, right? That there will be some robot that's deciding something about them, and they can't, they don't understand like how they're being treated. They don't feel like they're being treated like a person. They feel like, there's some automated decision that is just being made about them, and they're not being treated like a human. And we need to make sure that we keep the human aspect at the core of this as we figure out how to lead into and drive this technological trend. So I think that's also why it's important to understand that we're pretty far away, I think, from purely automated decision-making processes. That's just how it is, right? But it's about using automation to guide decisions that at the end of the day are still ultimately human decisions. So that's why it's also enhanced decision support, not automated decision-making. This is very, very important, I think, both for us to be able to morally do the right thing, so implementing AI and machine learning in a way that we actually are having a positive impact on the users and the world around us. Also, it's necessary, I think, for us to be able to respond correctly to the European regulations that require that we can show that, yeah, but these AI systems are not making biased decisions, and that we are treating people fairly, etc. All right. Then the last trend, and I put this up here just to start talking about the multi-cloud future. So this one, I choose to end with this one because I actually think, given the audience of this conference, this one is probably the most controversial, because this, in my mind, is hand-to-hand with cloud agnosticity, which for people who are really excited about cloud technologies is often, not always, but often something that they're not a fan of. But if we just think about the concept of like the multi-cloud future, so what does that mean? Some people, they equate multi-cloud future with cloud agnosticity. I believe that one, if you're being responsible, kind of implies the other. However, they're not hand-to-hand. So you can say, I've heard people say, I don't believe in multi-cloud. Well, that's kind of like saying you don't believe in gravity. Like this is the reality that we live in. So just to give some key examples, right? So we have public cloud. In KMD, of course, we're very big into Asia. We're very proud of being a first mover into a public cloud with a lot of our public sector solutions, but most people know the big three, the other ones being Amazon and Google. You have private cloud. So there are kind of private cloud vendors. Take examples that we use or look into, Hetzner and Base Farm. But private cloud, you can also think of that as on-prem. So if you work in sectors that we do, you still have some customers that want to run solutions actually in their own on their own servers in their own basement. That's kind of the concept of private cloud. Hybrid cloud, of course, having components in both, or a way to utilize private cloud together with public cloud. These exist, so you can't say that you don't believe in multi-cloud, because this is the world that we live in. What you could say is that you don't believe in cloud agnosticity. But I have a couple of reasons that I think is relevant for talking about why you should, or at least it should be a part of your technical decision-making process, and what the trade-offs are. So there are two. One, I will say, is I put GDPR on here because it's something that everyone knows. Although I will go out on a limb and say that GDPR legislation, I think, is one of the most miscommonly understood things that we have as a common dialogue in society today, and also surprisingly misunderstood by very technical people, actually. But there are a lot of regulations here that we're still trying to understand what they actually mean in a technical context. But it's not only about GDPR and data privacy, right? It's also about all of the other regulatory legislation that we have that governs, what you need to understand about the cloud vendors that you use, what they can and cannot do, what are they doing with the data Are you owning the data? Is your customer owning the data? Where is it going? Who has access to it? This is all stuff that you have a responsibility to understand if you're developing and delivering a solution. And we live still in quite a gray zone, and I think we will for quite a long period of time, because we don't understand very clearly what a lot of these regulations mean in a technical context. So to give an example, you know, there's a fairly big difference in terms of actual risk in the scenario of, you know, you running a solution in a cloud where that data is at rest in a data center in, I don't know, Canada or Australia or something, and is being maintained by support workers there, and the data itself is not protected by any kind of encryption or anything like that. Like, that's one extreme scenario, right, that you probably wouldn't do, but that's like one extreme scenario. And then think of the example that there is data that is at rest within the European Union that is actually encrypted with a key that only the customer has access to, yet in a crisis scenario, a support person from, you know, New Zealand could access a server that data is, you know, at rest. You know, these are actually very extreme, different scenarios from a true risk perspective. But whenever you try to translate what the technical, you know, what the legislation says into a technical context, where do you fall? You know, there's a lot of interpretation that we're still trying to figure out what it means. And we will only truly understand that, I think, in the coming years, and probably the next several years, and there will always need to be basically clarifying court cases that will have to be handled by the European courts that will lead to new conclusions that will guide us. So the point is that you're building cloud solutions on a target that is moving. And so whenever you work in a world where you don't know what will happen in the coming years, but you know that your solution will need to live for a number of years, you need to prepare yourself for, how will you deal with the scenario of changing interpretation of legislation, or even changing legislation. I mean, everyone working here in Europe, right? We know when GDPR came into play. We know that TRIMS 2 came, for example, and caused a huge new dialogue because the privacy shield between the European Union and the United States, where most of the big three, you know, public cloud vendors are all based out of the U.S., that was found invalid. That has forced all of the big cloud vendors to answer a lot of questions about how they handle data, but also forced all of us as creators and providers of cloud solutions to have dialogues with our partners on how do we react to this, and how do we secure that we're best protecting the integrity of the data of our users and our customers at the end of the day. And now, of course, we have a new framework that is coming in place, and we expect an adequacy decision fairly soon. So this is just one iteration, however, right? And then this will continue happening over the coming years. So you can also, in certain industries, for example, in like digital banking, European banking regulations require that you at least can document what is your exit strategy from your current provider, right? It's about being responsible, and it's about future-proofing both your solutions and also your business. So way back to the beginning, right? I talked about that smart use of technology and smart development and solution delivery is about understanding how can I kind of future-proof to be able to adapt my solutions to the world that I live in. I think actually, not necessarily being purely cloud agnostic. I mean, there's nothing that's completely black and white, but you need to always understand at any given point in time what is the impact that I have of making this particular decision. How would it impact my ability to change from one cloud provider to another, or if I have the same solution I want to deliver to different users that have different expectations about how I'm delivering that to them. So we have, of course, in KMD, a number of solutions where we might prefer to have it in public cloud, but we have certain customers that might expect something different, right? So from a development and maintenance and delivery perspective, we need to be able to handle that as well. So it starts by talking about a bit about regulations, but it's much more about, I think, being able to adapt to this changing world. The other thing that I want to talk a bit about is that all cloud workloads are not created equal. So it's also kind of a bit funny anecdote for me. When I came to KMD, right, I came from, as I said in the beginning, from being in the game industry in a very innovative kind of market-leading company to a company that was in these very highly regulated and in many cases very slow-moving sectors, right? So I came to KMD and people were talking I came to KMD in 2020 and people are talking about cloud being new, and it took me a while I was like, guys, it's 10 years old. What are we talking about cloud being new, right? But even and then it was because I realized, okay, yeah, but it is actually new in the context of what we work in. But even now, we have a lot of experience actually with cloud solutions, how we build them, how we run them, and how to optimize them. And we can understand as well that from a maintenance perspective, and especially from a cost and compute perspective, they're not all created equal. So this is also, I think, why sort of the multi-cloud world we live in is actually an opportunity, because if you want to also run a good business and have the best, be able to best manage your compute cost, then lean into this, right? There's no reason. One good example, for example, is that you might want to deliver a solution that uses a lot of AI and machine learning in a public cloud because that gives you the best, delivery, like maintenance. It gives you the best, like you can do all of your DevOps stuff. Like it's the best from a maintenance perspective, from a delivery perspective. You can deliver the best quality, the best SLAs. But you find that perhaps doing all of the data processing to actually train and develop the models is extremely expensive in public cloud because it's pure compute, right? But we live in a hybrid, or in a multi-cloud world, right? So why not train your models on a private cloud somewhere where it's very, very cheap, and then actually deliver the customer solution in a public cloud where the user experience and also the maintenance and delivery experience for you is the best. So see it, I think, as an opportunity. So the kind of key conclusion on this one, and as I said, I ended with this one because I think this is the one that is a bit controversial in some people's mind. But I really believe that future-proofing your product and your business means embracing cloud-agnostic tooling and DevOps practices. That's the key takeaway. And you can say that you don't believe in multi-cloud. I think I've kind of pointed out that that's like saying that you don't believe in gravity, but like all of the other things, it's your choice and how much you decide to lean into this or not. So that was just a tour that I've tried to take you through each one of the key technology trends that we've identified in our map here. We have also just published our map on the KMD website. I believe that it's live today or very soon, where you can actually go in and look at each one of the technologies in more detail. I needed to try to keep it also high level to fit within the amount of time, so I didn't have time to dive into a number of these particular technologies, but I will say I mentioned that we in the CTO office have a lot of focus and actually doing work with fireware technology. We're very interested in digital twins. Actually, we have been a driver with some of our businesses to actually start creating new business and new solutions with some of the municipalities in Denmark on this. I'm personally also very, very interested, of course, I mentioned in the multi-cloud future in general and how to prepare as an organization for that, how to leverage that as an opportunity. And then I'm also actually personally very interested in quantum computing in the context of security. So there's a lot of like people who are very excited about quantum computing in general and how to commercialize it. I actually think that the first thing that we need to be prepared for is how to secure that solutions are quantum secure. So that's just a little bit of insight into what I find interesting. And I hope I was able to give at least a high-level tour around the map, and I hope that you will take a look at it on KMD's website later, look into some more of the technologies, and as I said, we in the CTO office expect to publish more communication and follow-ups on a number of these different trends and even some of the technologies that we're working with. So yes, that is it, and I thank you all for sitting through like almost an hour of me talking about this. So, yeah, thank you, and I believe we have the next coming.
Thank you very much. And right now, I can invite you to a 5 minutes break. And shortly after this break, you can grab some coffee over there, maybe some snacks. And in 5 minutes, we'll come gather here again to see our next speaker. Okay, do we have everyone? No, not yet. Okay. So welcome again after a short break. We heard a lot of interesting stuff about the future of KMD and the future of technology in general from Natosha. And right now, we will hear even more about the future. Taking into the account that we are surrounded by books and movies about the future, and especially in science fiction genre, then we might wonder what will actually happen in the upcoming years, especially that technology is changing very fast. And right now, we will have the opportunity to get a better glimpse at what is the most probable outcome that we might see in the future.
She is associate professor at Koźmiński University. She earned her PhD in philosophy of artificial intelligence at Warsaw University, philosopher, researcher, and a scientist. Aleksandra Przegalińska.
Thank you so much. All right, we had a minor change in the agenda, but I think actually it worked for the better because then I had the opportunity to listen to Natosha, and I think there will be quite a few references to what she was addressing in her speech. Okay, I should be moving this way, I guess. So, yeah, I would like to talk to you about the upcoming years. You can think about it also as the upcoming decade with AI, but obviously with the whole ecosystem of other emerging technologies as well. From a perspective of a scholar who really cannot place themselves anywhere specifically, me and my team, we work at the intersection of language processing, so really more core stuff when you think about tech, and also the future of work, to some degree also anthropology, so it's a mix of everything. And I wanted to show you our research work, but also, let's say, somehow address the upcoming trends when it comes to tech. So I've been working in the field for quite a while, also popularizing artificial intelligence here in Poland and also beyond. I did my PhD in philosophy, and at that time I was very passionate about the Turing test as well, not only a mental exercise, but perhaps something that people could try and solve. And obviously today we have interesting events in the space of language processing, text processing, image processing as well, that might be somehow challenging the paradigm of the Turing test, I think. And I formed a team at Koźmiński where we are all newcomers to technology. So all of us started programming at some point in our lives, but that was not something that we studied. We were sort of DIY that way. And we all come from mathematics, from statistics, cognitive science, philosophy, and sort of build a team that is very interested in the future of artificial intelligence as a concept. And more recently, sort of the team and myself, we got very interested in the intersection of work and artificial intelligence from many different perspectives, you could say, because obviously we do talk quite a lot about, how artificial intelligence is going to impact the world of work. I am the vice rector of Koźmiński University. It's a business school, so obviously we think about that quite a lot. But I think the way we think about it is very normative in the sense that we are trying to look for opportunities and say that artificial intelligence can be very good help or assistive technology for the world of work in many different professions. And not necessarily do we have to convey the message that it's taking over jobs. Maybe it's taking over some tasks that are more routines, and in that way we would want to get rid of them. But I have to tell you that actually, we were always very passionate about human-machine interaction and building bots, testing bots, optimizing bots that can work in different environments, have good conversations with humans, not dumb conversations with humans, and be context aware. And sort of my colleague, Dariusz, with whom I wrote this book, Collaborative Society, we published it with MIT Press 2 years ago, actually in March 2020, when COVID hit Europe. And the book was about future of collaboration, future of work. He is an avid Wikipedian. He's always been involved in Wikipedia Foundation. He's been on the board and very passionate about about open knowledge sharing, open source as well. Certain aspects, I think, of hacking ethics that are very beneficial and in many ways very interesting. He said, all right, let's write about the future of collaboration. The first couple of chapters were about remote work, which was unfortunate in the context of COVID because it was like a weird intersection at that time. But the rest of the book was about the future of collaboration, including collaboration with, let's say, artificial intelligence, right, as a possible partner at work. And then I sort of pushed further, and at this point today, I'm sort of very interested in consequences of implementing artificial intelligence. This is sort of my newest child, wrote together with an economist. We were thinking about the universal basic income as a sort of interesting concept, very thought-provoking, very controversial, I would say, that tells us about the future of no work, in fact, or us becoming the unnecessariat, right, to some extent, which can be good and can be very bad. So we were trying to think about the, possible pros and cons of universal basic income. I can share with you that it's definitely not an optimal future from my perspective, and sort of happy to discuss more here on social media, wherever people are arguing about it. But most certainly, sort of, I am interested in a work as a whole, right? So not only sort of your work, my work, which is more tech-oriented, but I'm thinking about also nurses and how they could potentially use artificial intelligence. Obviously, the whole space of managerial work, but also something that we used to call blue-collar, white-collar work. And that blue-collar work, I don't think has enough support when it comes to technologies. It's not taken care of enough, right? And they do need support, and they need collaborative technologies that could work effectively with them. So this is something that has led me to a project that I'm currently working on, and I'll tell you more about it at the end. And maybe I'll ask you to crash test a bot that we have created, if you feel like it. What we are trying to do today is we're collaborating with Harvard University together with the Labor and Work-Life Program, which is a program that actually established the first labor unions in Harvard. But it's in economics department, in fact, and they are very interested in modeling the future of work, and obviously so are we, so I got hired there, and for the next 3 years we're going to work on our collaborative AI project, and I'll show you some snippets or parts of it. But before we get there, maybe a couple of words about where we are from my perspective. So I understand, and I know that you are very tech savvy as an audience, which is always great. This type of audience, right, obviously to interact with. But just a couple of things that I think are interesting from my perspective are the following. We have a whole ecosystem of different emerging technologies that we are implementing. Some of them have found very profound implementations, and some of them have not quite yet, right? So artificial intelligence seems to be on the good track. When you think about healthcare, logistics, right, different sectors, there's a possibility to implement AI for optimization purposes, for predictive purposes, and that seems to be very promising. When it comes to blockchain as another very interesting technology, well, yeah, a very cool technology, could possibly bring on non-fraudulent election protocols in democratic countries. Very big potential, right, for managing interactions and exchanges between people in a transparent way, but we do know it mostly from crypto, which is very volatile. So we'll see about this technology. It's certainly a very interesting one, and it also interacts with AI in many interesting ways. Another one would be IoT, or something that we could now call even the AIoT, right? So artificial intelligence and the Internet of Things. For me, a particularly, I would say, interesting space. As a team, we've been working using wearable technologies and different types of sensors for a while already for different types of experiments. Some of them are a bit creepy. Obviously, hooking electrodes to humans is always a big thing, but then again, a great potential for sort of in terms of affective computing and understanding how the affect flows, how the human behaves in certain environments. So for the sake of science, it's certainly very interesting. But beyond that, very interesting implementations, right? When you think about truly resolving some problems that we face even in the cities, like traffic jam, right? You need real-time data. And very often in AI, we rely on historical data with bigger or smaller delay, right? So that data can be very well curated, very, very clean, but then again, it's not informative about what's going on right here, right now. Not to mention TinyML, right? That you can really implement in factories with great success and then see whether a device would probably break or not, whether, the production line works well, and if we can see any distortions to that in any near future. So definitely sensors together with AI, the predictive power of artificial intelligence together with real-time data, that is a big deal, and we will see more of that, I think, in the coming years. Now, another thing is virtual reality and mixed reality and all these options of, say, augmented reality as well. Here, interesting possible intersections with artificial intelligence again. I guess if Meta really pushes for the metaverse, which I don't know whether it will happen because the investors seem to be more skeptical about it or increasingly skeptical about it. But let's say that, okay, we have one version of the metaverse, which is industrial metaverse with digital twins. You are using it for, again, managing, optimizing production lines or performing hospital surgeries, right, in a global manner, right, where you have different teams working on the digital twin of a certain, I don't know, like a liver or heart or another type of operation of that kind. That can be very interesting. But then again, on the other hand, you have the consumer metaverse that Meta is certainly pushing for today. And I can well imagine that artificial intelligence in that world is your guide, in fact, right? So it is something that tosses the experiences to you, right? Or tells you actually what to visit, what to do, where to do it, and what not. Not a big fan, particularly recently when I have heard that Meta is going to build a world of wars and uprisings for children in Poland, where they can immersively experience the war. I have a child, and I think my child is not going to participate in that, especially if there is no psychologist on board. But yeah, I mean, this is something that is on the horizon. We have to somehow account for that. So certainly this intersection is there too. And why am I talking about intersections? Well, mostly really to tell you that the ecosystem seems to be more robust in the sense that all those technologies are developing their own trajectories, but they also have interesting intersections with one another, right? And that is a fairly new phenomenon that the tech already captures as a community, but I think other parts of the business world, organizations, institutions, not quite yet, right? And I think this is on the horizon as the next phase, if you will, of digital transformation. Very interesting, very exciting, right? And AI is sort of right there, right, at the core. And obviously it has different, when you think about it, it has different paces of development too, right? So obviously, when you think about artificial intelligence, there are many ways to account for the discipline in terms of which sub-disciplines are there, what it involves, huge, I don't know, discussions about what counts as machine learning or is still statistics, where is that boundary? It's a bit blurry, I would say. And then you have sort of certain algorithms that are not questioned in terms of them being part of AI, that would be deep learning. But in fact, you have a discipline which is now developing, as I said, at different paces, right? So you have parts of AI that are going forward very fast, and I would say computer vision is there, certainly, right? It's the accuracy level is very satisfying, and the implementation rate is pretty good, and there are many sectors that are already definitely either looking into it and or have established themselves already as those that use it. I'm even thinking about radiologists as of today, even in some hospitals in Poland. We can see how, that profession is really benefiting from computer vision, but there are many others. We do have, certain attempts at cognitive computing, so affective computing being part of it, right? Modeling human reasoning, modeling human perception, understanding that. It's very complex, but definitely doable. We have old school machine learning, right? All these regressions, classifications, whatnot, that have been used in many different areas for a while already, even before they were called machine learning, in fact. And then we have deep learning neural networks, extremely exciting, voice recognition, image generation, text generation. All these aspects are very, very sort of interesting, and that is happening. And then we have the discipline where I sit with my team, which is language processing. And in fact, obviously, it's also in all those other ones, right? Because in language processing, we are using more classical machine learning algorithms, we are using deep learning, but sort of, I think it has been made as a distinctive part, like a separate one in terms of AI, like computer vision, because these two are really progressing rapidly, right? You have a lot happening here. You have new algorithms, you have plenty of data accessible, and the growth is very big, right? For language processing, we've been observing that for the past year. And in fact, I found out yesterday only, maybe you knew a couple of days before, that you see the increase of transformers, which are language generators. In fact, we will mention them later on in the presentation. And some companies have built business models around that, right? How to sell people tokens so that they can process something. And Meta, yesterday or 2 days ago, announced that they would be making a huge multi-billion parameter model available for free, right? So there's a race of transformers. All those big companies are setting their own transformers, huge language models, and they're trying to build an ecosystem with other people building applications on top of that, right? And mostly it's not been for free so far, or there have been a wait list, for instance, where you had to apply and wait for a given amount of time to be able to join, and now Meta has made that big step. Maybe they're a bit ashamed of the metaverse and they're trying to cover that. I don't know. That's my take. Yeah, but anyhow, like it feels like artificial intelligence, with all the progress that we have noted so far, is quite an interesting technology at this core of the, of the transformation for many different reasons, really, right? First of all, it's a technology that is quite mature already in many ways. We have plethora of different algorithms for problem solving. Some are more specialized, some are less. It's definitely a technology that is bringing on a lot of, also drawing a lot of attention, we could say, right? It's a technology that for many people is very exciting, for yet others it's very scary. It's the one that is closest to us. Frankly speaking, we don't have another technology where there are attempts made to model how we perceive reality, because we are the reference ultimately for artificial intelligence. It sort of speaks, it listens to you, right? It sort of perceives reality through vision, and it communicates, or right, some aspects of it can communicate, like bots. So it's a technology that is really exciting and I think challenging in many ways because of that, right? And it's the one that is most talked about, I think, these days, although, well, blockchain, for all the right reasons, is obviously a very debated technology too. What we are not seeing quite yet when it comes to artificial intelligence, and if we go back to those slides before, it's quite funny that when you look at all these classifications about which disciplines of AI are progressing rapidly and which ones are not, robots are not here, right? Robotics. And I'm not talking about automated systems, I'm talking about AI-enabled systems. We also call them embodied, right? Embodied robotics. We don't have many examples of that, really, when you think about it. We just have a couple where those robots are in fact using deep learning, reinforcement learning for management of the interaction with the world, right? And receiving stimuli from the world. Very difficult discipline. Most people who are in the software space would not want to build something like that and maintain it later on. Very costly. So obviously there are a couple of examples like Boston Dynamics or even Roomba the robot. Well, not so bad, right? Ultimately, quite an interesting implementation of some machine learning algorithms, including vision now. But this is a space that's not been moving forward all that much, right? Having that said, when I think about the horizon of the future, sort of my take, and you can disagree, is that when it comes to robotics, it's probably going to be this big competitive advantage for the future, right? So today we are competing with data, you could say, geopolitically speaking, who has more data kind of wins the AI race and other races too, right? Or maybe like not who has more, but better quality data, access to better quality data. But in the future, probably we will try to think about different types of algorithms as something that builds advantage, right? So algorithms that are uniquely good, right? For instance, in managing a robot in a physical space, right? So something that is actually present, computing, machine learning on physical spaces is something that is going to be very relevant, I think, for the future. And some people already know about it and I guess feel it. Although still it's very cumbersome to build a good robot that would move around. And again, something very recent, I don't know if you've been following that thread of reality. I know Elon is now present elsewhere and he has other things to do. That is for sure. But a year ago, he has promised that he would create a Tesla bot. And for me, that is interesting, right? I just want to know, how that would unfold. And he said, well, 52 kilos, moving very slowly, following you right from home, taking your groceries. That was the goal for Optimus or Tesla bot, in other words. And there was a presentation like 2 weeks ago of the Tesla bot because, well, Elon committed last year that he would show it. And they have shown it. And it was like nowhere close to Roomba, the vacuum cleaner, right? So it's really poorly done. And I think the problem is that really, you have the ambition and there is this temptation there are those temptations, right, in the world of technology that you want to push a bit further. And I think a humanoid robot is one of those temptations. Really, when you think about it. There are many people in the tech space who really want to create something that is human-like for all possible and very complex reasons. Obviously, we are very reactive to human face, human shape, right? We've been doing a lot of research in that space, and we know to what extent we are triggered by something that is not human, but then again has human voice, right? Something that perhaps to some extent looks like a human, has mimics, gestures, whatnot. Well, not so much. But then again, I think the attempt was to create a system with many modules, right? In fact, that can do many things at the same time, because that is a crucial thing to do, right? With robotics, that is the hard stuff, including also battery life and other components. But essentially, it's very difficult to create something that does many things simultaneously, like we do. And it's not essentially purely computational, right? You have to interact with environment that is very noisy. So that has failed, it feels, at least for now. But Elon's intuition, I think, is right? The future belongs to physical architectures that are AI-enabled, and it's certainly going to be something that many countries, many companies will be looking into, right? China already knows that the world is saturated with data anyway. Some will have less, some will have more, but probably it's not going to be something that will build your advantages in the future. But robots can, and physical systems can as well, right? So we'll see about that. Today, I would say that AI robotics is not a big part of AI, but it might be, right, in the future. Let's look at some other trends, perhaps, that are to some extent interesting. Well, one thing that is kind of clear is that we have enough complexity of models and enough data to produce good results in AI. That is something we can say. And you can think about different spaces, right? Here, example of image generation, a very nice, very cool deepfake, I would say. Nicely done, sort of, obviously, most of the people can easily recognize that we're not talking about a rendering of a real human face here, but nonetheless, the delivery is good, right? So we are seeing certain perfection, I would say, in some areas, like computer vision and language processing. That's one thing. The other thing is obviously something we mentioned before, that AI is pouring itself into other disciplines, right? This AIoT is a great example of that, where you have a mesh, in fact, right? And the boundary between these two technologies is not so clear anymore. And that is interesting too, and I think that will be increasing as well. Yet another thing that is very interesting, I would say, but probably, you know, for the geeky crowd, something that you observe, you know, being very sort of aware of how programming looks like from the inside, right? But this is something that's happening, and certainly very thought-provoking, and that's no code, right? Or low code, but both, in fact, are sort of very interesting. This is on the rise and has been for the past year or so, maybe 2 years. I remember when we were teaching, I have a program in artificial intelligence and business at Kosminski University, and usually we have we are trying to not to make any prerequisites, so the students who are joining the program don't have to program. Some of them do, but some of them don't. And those who don't, they have to start their adventure somewhere. So I remember we were starting off, I know you have some Azure presentations later on, we were starting off with Machine Learning Studio in Azure. Now I think it's transferred into something else, but it was very easy to create a, let's say, income prediction model with a drag and drop sort of interface, very simple, right? Where essentially all parts of building a model, a predictive model, were very easily explained and very visual. And that was a start to something that we are observing right now in all the other spaces, right? And when you think about image generation with artificial intelligence, text generation with artificial intelligence, you have extremely friendly interfaces. Interfaces that, to me, resemble social media. Frankly speaking, when I think about it, I'll show you some examples. This is like using the Instagram, in fact, but there's just like a huge machine learning model in the backbone, right? So that, I think, is very interesting. It has many different consequences, right? Including automation of code development, at least to some extent, where we would be moving more to the area of architecture, it feels. But for the majority of people, this is, you could say, in a way, good news, or something that democratizes this technology. Well, obviously, with all negative consequences, like, you know, misusing artificial intelligence, for instance, for many different goals. Deep faking people and putting them into a porn movie, right? That is very easy to do today for essentially anybody, right? And that is something that no code has also added. Deep faking President Zelensky, right? And then showing him off as a person who surrenders. That has been happening in March this year. We've seen that. Just that deepfakes were very poorly done. That's the thing. And thankfully, even human eye could recognize that that was like something was wrong with that. It was also inconsistent with everything he's been writing on Telegram. But let's assume a situation in which the deepfake is very well done and he's silent. I don't know what would happen, right? I mean, so there are definitely, you know, some questions and challenges, but this no-code thing is very big. It's shifting our landscape. So the landscape of people who really work in machine learning, landscape in IT, I think to a large extent as well. But for other people, like your typical pharmacist or somebody who runs a bookstore, this is like interesting news, right? I mean, they can benefit from AI in a different way. And to just say that, you know, it's obviously something that really resembles Instagram. I'll show a couple of examples. But one more thing that I'd like to say, and I think DALL-E, which obviously probably you have played with and you know, my daughter is a very big fan, I guess because of the surprise that she gets every time, right? While she's prompting something, she never knows essentially what she's going to get. Because she's not fine-tuning it. She's just prompting. But this very thing, that we are moving from coding to prompting, is interesting, right? So, I mean, for all the people who are external to our environment, to the tech environment, they will be prompting in the future. They will not learn how to program, most certainly. They will have books of prompts, and they will know how to prompt artificial intelligence to do what it needs to do for them, even writing a piece of code, right? So here the prompt was hairy soup, and I think the results were interesting. I was asking DALL-E for some depictions of people, and you have to remember that obviously these models like DALL-E, GPT-3, all the transformers are very sensitive to your style, right? This is something that is very distinctive of them, that the way you prompt them is going to really impact what you're going to get. And if your prompt is very sort of narrow and cryptic, you will not get anything spectacular. But if you write a full sentence and you use specific type of language, then you will get definitely something completely different. These models also learn how you speak, right? If you, for instance, use them as a bot, they will at some point start talking like you, right? Or use the same. Just try to use, on a bot like this one, on a transformer-based bot, try to use urban slang or hip-hop language for, I don't know, an hour. You'll see, right? I mean, you'll get quite interesting results over there. Although GPT-3 is not allowing to have that lengthy conversations with the bot, right, because of tokens. But it's definitely a doable option. We can think about it. So here's a coder, already some diversity. GDPR, that was mentioned here before, impacts the way these faces look like, by the way, right? That's why the guy over there is like, right? The faces are blurred and whatnot. That's privacy, sort of. So we are not getting like full rendering of the faces, but we're getting some depiction of who a coder is according to DALL-E and who a scientist is according to DALL-E. I see that the idea of a mad scientist is still definitely out there, right? As a scientist is a mad person. And so we see some of that, I think. But again, some interesting representation right here. So it feels like this model is already curated to kind of show reality in its complexity. In science, by the way, we almost have 50% of people, so as women among the people who are working in the discipline, so this representation is a bit of a misrepresentation, but it's fine. But you also get weird surprises, right? Black box, right? What can I say? I have no idea why. I really don't. I mean, this is not in my head what sticks as a nerd, right? But hey, maybe somebody can explain that. Explainability is important in artificial intelligence. Here we have none, but it's interesting, right? It's still probably if I just tried a different prompt, I could get something that, to my understanding, resembles a nerd. But I'll just leave it there. It is sort of a big thing, definitely. All these accessible but huge models, right, that are doing things for you. I do have friends in graphic design who are already freaked out because of DALL-E. They are, because they think all the stock production, everything they did, like mood boards for companies and that stuff, that it will be done without them. There is a big fraction of graphic designers who feel that way, but then there is another group that says, oh, that's going to be an extension of my workshop. I will use this, right? And I will not only prompt it, I will learn to fine-tune it, and then I'll get results that I want, not the nerd, right? But something that really would respond to what I would want from that. And you must have heard of, another very cool example of how, in fact, transformers are shaking the creative space. If you look back, like, I don't know, even 5 years ago or 7 years ago, there was a book and it was called The Rise of Robots by Martin Ford. And that book was about how, AI takes over, essentially, and automated systems take over. We are left jobless. That's supposed to happen by 2023, so brace yourselves because it's, soon. So the book was like, a bit nonsensical. But then there was that claim that, the jobs that will be left are jobs where you take care of other people, essentially, and creative jobs, and the rest of, and DJs. And the rest of us, well, not in a good position, right? Whereas I think what we are seeing for the past 2 years is actually the opposite process, right? When it comes to certain meticulous jobs, also heavily regulated jobs in the financial sector, in the accounting sector, legal work, right? Over there you have many algorithmic processes. You could try to automate them, but then there is a responsibility matter and the matter of, somebody signing that, right? Putting their signature and saying, yes, I mean, this is something I've performed. This is something I am responsible for. That goes back to Natosha's presentation before, right? I mean, you have to manage somehow the decision-making process. It cannot be fully automated. I'm not sure if we want it, but also we are legally unprepared for that. We have just a completely different system. However, in the creative space, the situation is slightly different, right? When you think about graphic design, composing of music, when you think about, to some extent, text generation, marketers and other types of jobs, here we have all these models that are doing a very interesting work, right? And there is a valid question to what extent they can take over many of these tasks, right? And those two fractions where you have people who say, all right, I'm saying yes to it, and I'm going to use something like Midjourney, right? For my work. And the group that rejects it, well, these are very polarized. Midjourney obviously has won the competition. I'm sure you've heard of it. When was it? Like 2 months ago, perhaps. I think the reaction to it was fascinating in a way, because the reaction to it was like, somebody has decided to include it in that competition. This was, a piece of art that was added to this competition. So somebody must have thought in the framework, oh, AI is going to compete with humans. Yay, that's so sci-fi-like. Let's do it. I think for the majority of people, this is really bad news, right? I mean, competition is not something, this is Terminator style. We should be moving into a different direction, really. But okay, somebody has done it. The prestigious prize was won by the system. By whom? Who enjoys winning that prize is the question, right? Does Midjourney celebrate every day? No. So it's a very valid point, right? Who contributed? Is it some sort of collective intelligence, right, that generated all these different styles that meshed into what we are seeing here, right? So human contribution plus the image generation on the side of AI. We really don't know. We are really facing certain blurry boundaries here that we are not capable of fathoming, I think, quite yet. It's fascinating, but it is scary too. And the accessibility is yet another component to that, right? And we see it in many different spaces. Obviously, we see it in our space. GitHub Copilot would be a very cool example, right? Where you can have artificial intelligence work together with you. The interface doesn't have to be friendly for this particular group, but it's certainly a collaboration. Right? It kind of works with you. It's one of the best examples of collaborating artificial intelligence that I've seen so far. Really, no better example than this, right? And we see it as something visible. So quite often, I think about the phase of artificial intelligence that we are in. And I'm always kind of changing my perspective on that. Are we in the summer? Are we in the winter? Are we in the space between, right? Where are we when it comes to artificial intelligence? Well, winter is probably not happening, right? Not anytime soon. But are we sort of in the summer? Are we in the spring of artificial intelligence? Is it on the rise or is it already here, right? Tough to say, I would say. Most probably somewhere at the beginning of the summer, which will be very long and maybe very stormy too, because, well, some turbulence is also on the way. But I do remember that I read even last year that artificial intelligence is sort of over, right? That it's a technology that unfulfilled its promise. It's not bringing revenues. It's very capricious, right, for business. And businesses are ultimately evaluating the technology more than the tech crowd, and sort of that it's that it's on the brink of something that is ending its own hype. Transformers have certainly changed that to a large extent. This accessibility component has changed that. So I would say, right, I mean, I'm gonna leave it open, but I would say probably closer to the warmer part of the year. Other interesting things that are happening when it comes to artificial intelligence, well, maybe more specifically, machine learning, deep learning is obviously, how do we want to use it, right? And where do we want to use it? And I think COVID has been an interesting moment here because, well, some people said, all right, it's so cool that you have new segmentation thanks to artificial intelligence. It's also great that you can make more money on advertising, but how about we use this powerful technology for something else, something that we would all benefit from, also as citizens. And certainly there is a lot of discussion about, climate change and the way artificial intelligence should be present in that space, or climate crisis. You do have systems that are very promising for drought prediction, for instance, for people in agriculture, so that they understand the patterns of seasonality in a very granular way. With a friendly interface, obviously, has to happen, but that is happening. The other thing is carbon offsetting, but I am not sure if it's not greenwashing. Sometimes when I think about it, right, you organize a conference and then you have to plant a set of trees somewhere to give back. That seems to be fine as a concept, but the way it's implemented to me is still very vague. How do we choose where and how do we pay back, right? I mean, is it an arbitrary decision or is it somehow modeled? And artificial intelligence is entering that space as well, right? To kind of tell you exactly if you want to pay back, how to pay back. Well, that has to be a very multi-parameter model, but I can understand how that could work, right? So certainly a lot of interesting initiatives in that area too, as well as, you know, in other ones. I don't know, obviously the whole space of new therapies, new sort of a drug invention, right? And all that stuff, where modeling, mathematical modeling, but also predictive modeling seems to be feeding really this process. And yet another area is obviously public health. Right? So when you think about it, public health is another very interesting sector where I think when you think about artificial intelligence as being more or less controversial, this is probably the least controversial aspect of artificial intelligence, right? When it comes to recommendation systems, you know, ultimately leads to sales, which is fine. I think, you know, managing the public sector, also very non-controversial. In many ways, I would say a very, very safe, sort of, in a way, we could say beneficial type of artificial intelligence. We could think about it that way. But there are plenty of areas where we have our doubts. And I think public health is probably the one where we have least doubts, and we would want to see more or welcome more implementations. It is true that we've seen just some, and the appetite is for more. Here, probably an example, you know, Blue Dot, right, Canadian system for detection of diseases that can spread easily, spreadable diseases. Very useful for Zika, very useful for dengue, right? It has proven itself as a valid system, although it's a language processing system, right? So it's not really taking into account any numerical data, image data from, you know, hospitals of patients and whatnot. It's just something that detects a spreadable disease through social media and other types of you know, records online in 65 different languages and dialects, including Mandarin. And I think the interesting part of that system, something that still fascinates me, is that, you know, early or weak signal detection. So we often think about artificial intelligence as something that uncovers facts that are already there, but we just cannot see them, right? And this has flagged that there was something spreadable happening in Wuhan in 2019 in November, which is interesting, right? Before the World Health Organization said anything about it, right? So I do remember Donald J. Trump, who seems to be coming back on Twitter and elsewhere as well, that he said at some point that he knew about COVID. And I do think, or I do know, because the company has shared, that them as a Canadian startup, they have been serving two governments, Canada and the United States. So very, very probable that in fact it was the truth, that he was informed that there was a phenomenon detected. And then again, that did not translate into good modeling of how the spread would unfold further on, right? So in different countries, in different locations. This is something that we could not, or like, you know, the field could not deliver on that. But the weak signal detection, the early signal detection, that was certainly there. And I think this is very interesting. I would want to see more examples of that kind, right? But that, you know, this whole aspect of artificial intelligence and sustainability is very messy, right? It's a very messy area with many different critiques, you know, the carbon offsetting and this being like dubious is just one. There are more. There is also like the question about the cost of artificial intelligence incubation. If you have a model that has been trained for 6 years and has 175 billion parameters, and that would be GPT-3. And there are bigger ones, apparently. AI21 Labs. We'll see about the one that has been developed by Meta. Amazon has created more recently another one. So huge models, right? For instance, for image generation, right? For the hairy soup prompt, right? And that there is a question, right? So what do we want to do further, right, with that? Do we want to incubate more huge models, and how do we want to use them? Probably there will be some valid reasons to do so, but there will also be like, you know, weird reasons, or like, you know, unnecessary perhaps, you know, to sort of like, I'm not judgmental that way, but maybe reasons that where you could ask yourself a question, was it worth it in a way? So this discussion is very, very interesting, I would say, because it's a discussion, in fact, about sort of data policies and data management as well, right? So some people now are saying, all right, maybe we don't have to build bigger models. Maybe we just have to think about other ways of achieving the same results, right? And then the echo cost of that technology is going to be lowered. In fact, myself, I've participated in a conversation with a representative of Google Brain and yet another person where she said that she believes that all scientific articles that have been published where we have used, let's say, machine learning to perform any type of, computations, or where we have used it to create, a tool or test something like conversational bot, should have their carbon footprint established, right? So we should add a label that says how much we have used, right? So what is the echo cost of doing that particular research work? Interesting, right? Interesting concept, because scientists were never called out on that, businesses, but scientists right? I mean, obviously we are using less, that is true, but then again, we are using some. And there is this big question about, I think, data right now and how to handle it all, also in the context of sustainability. And I do think that we are seeing now this very interesting sort of debate regarding what is data that brings value, what is data that really adds to your decision or becomes a decision support system for you, allows for data-driven decision-making, and what is just a huge data stack that is like out there, and huge data volume that is like sort of, full of messy data, or like data that is essentially, if you just added dimensionality reduction to it, most of it would be just peripheral to your problem, right? You wouldn't need it. So I think we are trying to now, or sort of the AI world is also thinking a lot about data quality in a way, right? So what data makes sense, but also, for instance, in the case of transformers, we are now seeing that they are already so fed with data that you don't need that many more examples to make them do something good, right? You just need some. So in fact, it's sort of almost like shrinking the model, right? From the data perspective, you are narrowing it, and then you are expecting good results, which I think is pretty interesting news, right? Obviously, fine-tuning is a different process, but like if you just want to teach, let's say, a model like we did for our bot about how to perform competitive analysis, you are just showing, 20, 30 records, not more than that. And you are getting something that is roughly really a structure of a competitive analysis, right? So that means that this flood of data can be somehow narrowed. And I think, but the data has to be good. Right? The data, on the other hand, has to be of very good quality with metadata, kind of really representative of what's supposed to, embody in a way. And then we have, next to sustainability, we have all these interesting questions regarding, to me, sort of interesting, regarding ethics and the future. I have the impression that my students are sometimes a bit overburdened, even like with the responsibility, right? If you build a model, oh my gosh, you are building something that ultimately is going, well, if it shows products to people, right, what to buy, well, that is a responsibility, but like, not comparable with the one when you are building, a loan checker, right? Something that is supposed to predict whether a person gets a loan in a bank, or something that is somehow helping in diagnosis, right? So this is like, I think that responsibility is big and it's already getting noticed. I'm not saying that data scientists are unaware of it, because I think they are very aware of it right now, but sometimes they are just like, they don't know, they're clueless about what to do with that, how to be diligent about the conduct, right, the protocol. So this is something where they need support of other groups as well. And we are facing here many different challenges, right? Some of them are unsolvable. Let's think about the moral machine test, that evil, nasty thing, right? 13 scenarios, you're always killing someone. I think what this test conducted by MIT for possible hypothetical autonomous vehicles of the future was just a proof. And it was done by 5 million people worldwide. So that's a big group, right? And the hope was maybe we can think about or learn about universal ethics for these cars. Well, we have not learned anything about universal ethics for these cars. We have just learned that this is not a way to model decision-making for autonomous vehicles. It's just the experiment was failed. The team said, we are closing the experiment. You can still click and kill people, but it's on you. It's on you. We are not adding it to any database anymore. We are closing this experiment. We are not doing it. We have technological readiness to deploy autonomous vehicles everywhere, in all countries possibly, but we're not going to do it because we are just not ready, right? I mean, and nobody wants to bear the responsibility. The automotive sector is pushing back. They're saying, if you want a car like that, you have to submit the test each and every time. And you will be the one making the decision about who will be dead. And then you have lawyers saying, oh, this is against the Geneva Convention to have a prediction machine making decisions about whom to kill based on age, for instance, right? I mean, we are not going to do that. Sorry. I mean, we disagree. And so, in fact, I'm not saying that this test has contributed to that, because you have autonomous cars in some spaces, right? In California and a couple of others. But in fact, in many places you don't. And I remember that Uber 5 years ago was sponsoring articles that said that by, again, 2023, interesting date, we will have no cars in the city centers anymore. Just a car as a service, autonomous cars driving around, you hopping in, hopping out, everything's great. No, that has not happened, right? Instead, what we have right now is extensive research in support for decision-making of a human driver, right? So collaborative driving, in fact. We are not reaching the 5th degree of autonomousness in those cars anymore, and nobody is trying to anymore. At this point, we're saying, all right, let's give the driver extra pair of ears and eyes and like something that helps. Even assessment of whether a driver next to you is a notorious driver or not. This is something that this team that has been doing the test is now focusing on, right? So very interesting how we are checking the boundaries of decision-making with AI and maybe pushing back a bit, making a step backwards, making 2 steps forward. Interesting game, I would say, but tricky too and tough. And then obviously in Europe, like Natasha was saying, we're gonna have this interesting but very messy to me regulation. I don't still get it, you know, how it's going to work. I've seen the draft, I have read it. It's supposed to be implemented next year, right? And we are looking at artificial intelligence according to this regulation called the AI Act from the perspective of risk, in fact, right? Mostly risk. And we're saying, all right, all your weather predictions, all that stuff, recommendations of yogurts for people, whatever, that is minimal risk, we're fine. But then some people are saying, all right, there are aspects of this of these implementations that are more like questionable. So some of them would fall under the limited risk. And here, for me, interesting example, obviously conversational systems that call people. Right? You have a telemarketing bot calling people. It has to always introduce themselves as a bot. No confusion. That is the main thing, right? So you're seeing a generated image or a video on Instagram elsewhere. If it's generated by AI, it has to be labeled. We'll see with the execution. I have no idea whether that's going to work, but the regulator wants transparency. So they want to say, if you are using artificial intelligence to interact with people, you just have to make sure that people know that they are interacting with an AI system. Well, yeah, that is the proposal. Now, we have also high risk, and here we have particularly the banking sector, I think is the most favorite sector of the regulator here. It's mentioned all the time. The medical sector was here too, but not anymore so, because in medical sector, do you want to sacrifice good image recognition for diagnosis just for the sake of having maximal explainability? You probably don't. You just want people to be safe. You see that these systems are just better in this particular thing than most of the humans. So you're saying, all right, I mean, I don't have full explainability. It's a bit of a black box, but it just works, right? It has proven sequentially to work, right? 99%, of proper detection. We are going to trust this system. But in the banking sector, it's a different story, right? You're not getting a loan, you are getting rejected, you want the answer why, right? If you have a non-explainable model, they are not using the word explainable even, they're using transparent, which is a different thing, but they're saying you have no transparency of decision, okay, then you cannot use it, right? Or you need transparency. What I am afraid of, though, with this regulation is that they are talking about some sort of national departments of explainability, and I am worried. This is some sort of weird bureaucratic structure potentially, right? Who's going to check? I mean, who is going to work in the National Bureau of Explainability? I have no idea. But if these people are out there, I'm just afraid that it's going to be a bit of a mess over there. But like Natasha said, if you want to increase explainability, scientifically speaking, it's a very interesting task. And also in terms of building new products and innovation, Apple has always been, Apple is always trying to be about transparency, right? Fighting Google and whatnot. They have those little game of theirs. And it's like interesting because they're saying, okay, transparency is a key to customer trust, for instance, right? You can build better things, people will trust you more. So I know that we can look at it from this perspective. I'm just afraid of the mess and the National Bureau of Explainability in Poland specifically. But maybe it's going to be great. And then you have unacceptable risk, right? So everything that is revolving around something that we would ban, essentially, in Europe, something that we don't want in Europe. So here you have systems that are detecting human faces in public spaces, for instance, or a system that could potentially lead to something like citizen scoring, a la China, the way you would have it there. Right here, we sort of decided, like, I guess, the regulator decided that we disagree to that. And also subliminal recommendation, tricky term, right? But something that where you are giving a recommendation on what to do or what to buy, but you're not saying that you're giving a recommendation. Again, Cambridge Analytica style, right? So this is something, but again, this regulation is as of now. I'm thinking in 2 years' time, we will have new challenges in artificial intelligence. How will this regulation react to that? I have no idea, right? I mean, if there is some sort of AI plus biological, I don't know, genetically modified thing like a xenobot or something like something artificial intelligence life that it's moving on its own, this regulation cannot capture it, right? But it's an attempt, and it's certainly the first attempt, and I think that's worthwhile in a way. And it tackles things like algorithmic bias, right? And also, to some extent, transparency, too. All right, and the final thing that I wanted to talk to you about is obviously, everything that happens in the space of conversational artificial intelligence, because we have quite a lot here, right? We've had systems that were sort of more simple a couple of years ago, right? But they were storytellers, right? The first systems that were able to generate like a whole set of phrasing in a certain structure. Debater from IBM was one of them, right? Talking to humans about controversial issues, responding to human argumentation that was lengthy, point by point, right? First example of really nice NLP architecture that manages dialogue with humans, right? And talks, not only respond to short queries, but actually talks. And now we have GPT-3, obviously huge model with all those different parameters that is capable of so many different things. And obviously, there are open source versions of it like GPT-J, that is great. Not as good as GPT-3, but still good that we have the effort, at least. I am all in for the open source. And we have, some other models too. We have BERT by Google, we have T5, we now have AI21 Labs. These transformers are more present, that is true. And they also have more functionalities. That is a novelty, I think, in artificial intelligence. And the novelty is that you can have one model doing many things. Composing music, generating images, generating text at the same time, right? We always kind of thought that you have an algorithm that is good at some tasks that are related, closely related, for transfer learning purposes as well. Now we are seeing that you can have with a transformer things that are doing many different things from different angles. There's also a Chinese transformer, Wudao. I don't know if you've heard about it. Probably, they said it's bigger than all the other ones, so we'll see. And DeepMind has established their own transformer, Gopher. They are bragging about how verified it is, how non-trollable it is. No trolls can access because it's so well fed with like high quality data. You're not going to do it, right? You're not going to make it say like some sort of weird stuff. And our research work is really somehow embedded in all those transformers. I told you that we are very bound to physiology of humans. When we are doing any experiments where you have interaction with the bot, we want to see to what extent we can use different types of psychometric measures or like physiological measures, sweating and others, to see whether that interaction is comfortable, for instance, to you. Because we can ask people can tell us, make their declarations. But the other thing is to use sensors, wearable technologies for that purpose. And we are really, I mean, sort of present in that space here. We were doing some other research work with wearable technologies, perhaps less relevant here. But we are quite serious about it, right? I mean, we have different types of portable EEGs, and we're trying to understand the patterns of interaction from many different layers, right, and many different perspectives. And what we have done, in fact, more recently in this is this work on automation of work and the future of work. And we are conducting a set of experiments actually with marketers. So creative profession, but like not creative in the sense that, like, you know, as a painter would be, like a different type of creation. But what we have done is, in fact, we have built first a very simple bot, but later on a bot that is based on GPT-3 that is supposed to become a support for marketers. And we are intentionally sort of not allowing the system to do everything, right? You cannot delegate all possible tasks on it. If you are a salesperson or a marketer, in fact, you couldn't anyway, because technically they are just not ready yet to do these types of tasks, and maybe they won't be for a long time ahead. But at this point today, we also want to see to what extent it's really possible to collaborate with in other professions with AI in the way that people work with Copilot, with GitHub Copilot, right? Because that, as I said, is a great example of collaboration. So we have built this virtual assistant. Don't mind it's just like, you know, it's just a depiction that it's like a no-code for people. It's very, very easy to use, very simple. And in fact, we've done a pilot project where they were experienced marketers, and they had a simulation of a problem that they face at work. And that was to launch a product campaign. And we're thinking about a job from the perspective of many tasks. I think this is something that is very present in IT, but in other professions, not so much. Because in IT, you have very good segmentation of tasks. What's to do, right? What's to be reported. And like these are very interesting sort of loops that you are making, and those tasks are clearly defined. Whereas in many other professions, it's very, very blurry. You know, when have I ended this? When have I started this? So we were trying to make an effort and understand how do these tasks look like, right? They have tasks, and then on top of that, you have subtasks, and then subtasks of these tasks, right? But for a marketer, that could be potentially, right, market analysis, competitors analysis, advertising and outline, budgeting, and some others, right? And we were trying to say, all right, your bot is going to feed into this, and that, but not into all of these things. It's going to be quite good at that. Also, it flags how confident it is with its own result, which is to us a pattern of transparency too, right? So it tells you, I'm not going to be very good at this and that, but I'm going to do this and that for you better. And so what we have done is we allowed a group of, first of all, 20, and at this point, 120 marketers to use this bot in a simulation, right, that was resembling their real work. And we've got very promising results, right? And the results were 40% increase in effectiveness of work, but 60% increase in job satisfaction, which to me is a better parameter. They were essentially happier because some routines were taken away and they focused, and self-assessment of output, how well the job was done, and they are proficient at what they're doing, so they can assess themselves in an honest way, was much higher here, right? So we're scaling it now to United States. We are going to perform another set of experiments over there. And now I'm not sure if this QR code works, because just before the experiment, the presentation, I checked it and I wasn't happy. But what I can do is I can send you you can tell me right now. Sometimes it doesn't work on Safari too. But like, if it doesn't work at this point, it's on Streamlit, the bot right now. So like UX-wise, not too cool. But its name is Coulson, as you can see. And the other thing that we could do is send you a presentation where this is going to work for sure, right? So, and then you can test it. The bot is very good at a couple of things. It can perform competitive analysis for your company even, do sort of a shorter version of a SWOT analysis, very good at creating segmentations and personas for different products, quite good at harvesting CVs. This is the part that we are most proud of. It was the hardest one. drafting emails, but also generating ads from product descriptions on different social media and generating product names, right? So what we are going to do with this bot is, as I said, test it, and we hope to see that this type of collaborative AI can bring more value to you. And we have made this experiment even harder recently because we are going to compare human plus bot versus human plus human. So before we have compared humans against human plus bot. And it was easy, right? Because obviously it's speeding up the process and everything. But human-human and human-bot, that's going to be very interesting, I think, and tricky. And I don't know, I mean, I think both outcomes are fine. If it turns out that human plus human is a better team, then yay, humans, we are winning with artificial intelligence. If AI wins, then haha, that's good too. So, I mean, it's a smart experiment that way. But no, we are very interested in bots that feed into tasks, right? And that can be helpful and that are not taking away from you stuff that you essentially like to do, but just take the stuff that you are disliking, because or the people in this experiment will be declaring whether they want to be the bot, like they want the bot involved, they want it to be turned on or not. And they are selecting where they want to use it. If they just want to use it here and here, fine by us. You don't have to, right? I mean, so yeah, 3 long years ahead of us with the bot, but with that, I want to thank you. I'm not sure, I think I went over the time, but yeah, if you feel like having questions, maybe during the break, a couple. Thank you so much.
Thank you very much, Aleksandra. This was a great expedition into the world of artificial intelligence. A lot of questions, a lot of perspective, views. Thank you so much.
Thank you.
And right now, last but not least speaker before the lunch break. So please keep your stomachs ready and let's hear what he has to say, because it will be another exciting speech. And I don't know if you know already who I'm talking about. You might actually know him from different conferences, even recently. He was speaking on another conference last week. And according to LinkedIn, usually he talks about .NET, .NET Core, Azure. And today he will be talking about OpenTelemetry and distributed tracing. Yeah, I didn't want it to misspell that. Okay, so.
Speaker and developer specializing in backend application performance, co-founder of .NETOS, .NET technical lead at Sonova, Microsoft MVP. Please give a warm welcome to Łukasz Pyrzyk. Oh, sorry for that. It looks like we are going to a break.
Yeah, we got a little bit ahead of ourselves. Yeah. So 5 minutes break, like before, and then we will meet for our next speaker.
False start. Sorry. So it is time to introduce our next speaker. He's a developer specializing in backend and application performance, co-founder of .NET Tech Lead at Sonova, Microsoft MVP. Please give a warm welcome to Łukasz Pyrzyk.
So, hello everyone. I guess you can hear me now. So, I came to you with a topic about OpenTelemetry. As you already heard some words about me, I came from Wrocław, and I'm co-founder of .NETos. You may know this company because we organize .NET conferences and we do a few online trainings. And I'm also Microsoft MVP, and I work remotely from Wrocław to a Swiss company called Sonova. The funny fact is that almost 3 years ago, I was standing there because we had a .NETos meeting in the KMD office. So it's my second time in this place, so it's very nice to see you again. But now, let's focus on the OpenTelemetry. This topic might be a little bit boring for you. Sorry, it's about observability, debugging, logging, etc. So I will try to make it as more fun for you as it possible. So we will have a live demo. I hope it will work. So when it comes to agenda, I would like to tell you about the pillars of the observability, about the OpenTelemetry history, because it's quite interesting, and because of the legacy articles that you may find on the internet, sometimes it is difficult to start with. Then we will jump into a little bit of theory. We will learn about the traces, trace context, traces, spans, trace tree. But these terms will allow you to understand how OpenTelemetry works under the hood. And then finally, we will see the live demo. So when it comes to observability, in, I hope, modern world, you work with modern situations and modern applications. So probably you are familiar with the idea of microservices. So probably on the production environment, you have like several applications that are constantly communicating with each other. It is not so common to develop a single application, like a single monolith that does everything. Because of that, we should expect for failure, because many situations can happen on the microservices environment. For example, we may experience a timeout. And when we have a logging functionality, logging needs to communicate with the database, and a single query to database may fail because the database may experience a timeout or maybe another problems. Also, working in the cloud brings new problems. For example, if you run on the Kubernetes cluster, maybe at this moment Kubernetes is introducing a new node and it is deallocating a previous node, so our request may fail on that level. Also, we may end up in the situation when we run our application on Azure, we rent a virtual machine, and on the same physical machine, our lousy neighbor is trying to run some CPU-intensive application. And because of that, our application will perform slower, because somebody else is using our physical core that should be partially assigned to us. Because of that, with this modern architecture, we should expect the failure and prepare for it. For this reason, observability is becoming more and more popular. By the pillars of observability, I mean 3 main topics. The first topic is logs. I guess you are familiar with logs, the most simple pillar. Even the simplest log is a simple output to the console. But then we also have metrics. Metrics are less popular, but they are extremely helpful. And finally, we have traces and tracing. So let's start with the simplest one, logs. They can be structured or unstructured. So the simplest log is like a single entry on the text file. It can end with a new line. But more structured log may be serialized into JSON. Maybe within the JSON properties, you will have some kind of structural data, and because of that, your logs might be more powerful. However, logs are becoming more and more popular in our application, and because of that, we are using them too often. By too often, I mean that we are trying to use them for everything. The scenario from my previous company, somebody wanted to calculate amount of requests per second, so he started to aggregate logs, where each log was saying that the request has started. It does its work. You can calculate the amount of things that is happening in your application, but logs are not suited for that situation. Logs are easy to generate, so we do them a lot, but for other cases, we have other pillars of observability. The second pillar is metrics, or a metric. It is usually a numerical value that is collected from the app, and it can be used to determine specific behavior of the application. For example, a metric can represent a single numerical value in specific timestamp of our application. It may say that at this moment, like 1 hour ago, our CPU usage was this kind of percent, like 10%. Metric can also explain different things. For example, number of requests per second. What is nice about metrics is that they can represent overall system performance because they are easy to aggregate. Because metrics are assigned to the numerical values, it is much easier to aggregate them. Because imagine that you have a query on the Kibana, it's much easier or also more performant for you to do a query like show me requests where CPU usage is higher than 90%. You have numerical value, so the query is quite easy to aggregate. Because of that, metrics are also lighter. They don't have this full line of text, so you can store them for a longer period. It is quite often that you can store metrics, for example, for half of the year or even the whole year, where usually logs have smaller retention, where you need to delete logs after 1 month or 3 months or something because you are getting simply out of space. And then the third pillar, the traces. Traces are the most interesting for me, and they are the main topic of this presentation. Traces and that single trace can be used to analyze the entire life cycle of our requests or our business processing flow. It might sound quite difficult to understand, but actually it's quite easy. For example, imagine a situation when you are a developer at Amazon and you would like to understand what is happening when somebody clicks login. Or maybe you are Elon Musk who bought Twitter and you would like to understand what is happening when somebody clicks tweet. If you want to do this manually, probably you would have to go over 200 microservices, find some kind of correlation ID, then try to find other logs with the same correlation ID, somehow or aggregate them. But maybe in one of the applications, the correlation ID is lost, so you will never find this kind of information. And investigation in such environment is becoming more and more difficult. Traces are solutions for that because a single trace represents the whole processing unit. For example, let's go back to Twitter and tweet button. The underlying Twitter application can generate a trace, and this whole trace should contain all information that is happening in our microservices. So imagine that you have a one log where on the children you have information that when clicking tweet, you communicate it to this database, you communicate it to this microservice, you send this comment to the service bus, and you got response in 9 seconds. Everything in one place, everything correlated automatically with great timings. And basically, these are traces. They are quite new, and they are extremely handy. It sounds like it's a lot of work to do, and of course, you can generate these traces manually. However, it could be cumbersome and quite buggy. So because of that, there are many libraries and extensions to .NET and other platforms that can automatically capture these things for you. So imagine that you add a magical DLL to the Twitter application, and with that, you have the whole trace automatically. All network traces are SQL queries basically automatically generated for you. It looks nice. So let's take a look on this example. So on this demo, we can see that we have a, let's say, enterprise solution. The enterprise solution has 5 layers. So we have a first layer, second layer, etc. On the first layer, we may have some kind of API gateway. Under the hood, we have load balancer. Then we have on the third layer some kind of applications that we run that operates the HTTP traffic. Maybe on layer number 4, we have our SQL database. And additionally, on the layer number 5, we have additional storage, which is created dedicatedly to store some kind of additional data, like Azure table, for example. Imagine now that everything in this solution scales. So you have like 200 instances of this application on each layer. Debugging a problem in this environment might be quite difficult. Imagine that you received a request from support that somebody failed to log in. Please find out, because it was Elon. And what now? You would have to go through a lot of logs, a lot of microservices, a lot of traces just to find out what happened. Maybe the request failed on layer number 3. But to find out this, you need to spend a lot of time. And the traces and distributed tracing is idea that you should be able to go over the whole business flow, what was the creating a tweet, automatically. And we can do this using the OpenTelemetry. to start with OpenTelemetry, unfortunately, we need to understand some history behind this. Because of some old articles and old decisions, you may end up into that end. So in 2016, there was a project called Open Tracing released to the market. It was a, let's say, standardized API for tracing and information for developers how they can orchestrate their traces. And this whole project was shipped under the Cloud Native Computing Foundation and was developed internally by Uber. And then Uber decided to publish this project as open source. It sounds quite nice, and it was kind of helpful. A lot of people started to use Open Tracing even without official support in .NET, for example. But then in January 2018, Google did the same. They open-sourced a project called OpenCensus, which was an internal tool for gathering metrics and traces from Google services. So as you can see, in short period of time, we received 2 different applications, 2 different kind of protocols and set of libraries that could be used to perform distributed tracing and collecting the traces. Because of that, both solutions were open sourced, they decided to have a meeting. And in March 2019, there was a meeting of a committee from Google and committee from Open Tracing, where they decided to do a merge. Instead of supporting 2 projects in parallel, they decided to create a third project that would be a successor of that. And the name was selected to be OpenTelemetry. So if you're ever going to find out an article or library that claims to be Open Tracing, it's already legacy. If it claims to support OpenCensus, it's also already legacy, and you should migrate to OpenTelemetry and don't watch this YouTube tutorial or article. It's no longer needed. With this merge, the community decided to do kind of few decisions. And they decided that this project will be totally new. They won't offer any bridge to support OpenCensus together with Open Tracing. They wanted to ship the new product from the scratch. However, they also decided that it will be a not complete superset of all possible functionalities from both products. They decided to bring the crucial functionalities that will allow developers to fulfill like 99.9% of typical usage. But they decided to avoid like bringing functionality that is used only by 0.5% of the developers because it's not suited well. And it was decided that OpenTelemetry won't be just for tracing. They wanted to have a full support for metrics and logs as well. The whole project was also published under Cloud Native Computing Foundation, and it's also open sourced. If you may feel that OpenTelemetry is somehow popular in .NET environment, it's not only in .NET environment, because at this moment we have supported these many platforms. So is any of you working on a different platform, like a platform which is not listed here? Great. That means that you can use OpenTelemetry right now, and some of the libraries are stable, some of the libraries are quite unstable. By stable, I mean that the committee didn't say that it is stable, and you may still find some kind of beta or alpha subtitle near the library version. If it still doesn't convince you that it is stable enough to invest time in it, just take a look on this graph. It looks terrible, I know. However, this is a graph from, I think it's from Grafana, and this is a graph that shows open source commitment to Cloud Native Computing Foundation project. So it shows how many commits there were made, how many pull requests, how many comments, how many reviews, etc. And on the top right corner, you can see a fancy name called Kubernetes. And there is a small number there saying that in last month, it was 56,000 of contributions to the Kubernetes project in total. However, the row below it is OpenTelemetry with result of 22,000. So OpenTelemetry is like the second project in Cloud Native Computing Foundation when it comes to popularity between the developers. So except of Kubernetes, OpenTelemetry is really, really high. It's even higher than gRPC. This graph is taken like 2 months ago, so at this moment it might be a little bit changed, but you can click on the bottom and see how it goes under hood. So if you know the history and the naming and who is behind this and we know where we can use it, unfortunately, we need to learn some terms because OpenTelemetry brings few new terms that we need to understand. So the first term is context. Like in typical business application, you always find some class type named context. It might be like service bus service bus context or business context, somewhere this context will be. For example, you may also find ASP.NET Web context in ASP.NET Core application. And OpenTelemetry is no different. We have a context, however, this context is replaceable because this context is abstract. And at this moment, we have few implementations. The most important one, and let's say the most popular one, is W3C trace context, which is standardized by the W3C community. However, until OpenTelemetry times, we had like open tracing, and they also had different context. For example, you may find B3. Then, of course, since we have context, we have also a class is called tracer. And the tracer is like a class that is used to grab a context. Then the most interesting term for you is span. Span is like a single processing unit, like a specific event that happened in your system. In the previous example, I gave you the idea of clicking tweet on the application. So imagine that by clicking tweet, you communicate with single HTTP endpoint. This communication is a span. Then this API calls database. This call to database is a different span. So each communication between the applications or even each business event in the app can be a separated span. What is important of span is that it kind of deterministically says what was the duration of the span with what attributes. So we can enrich span with attributes like kind. So we may say that somebody was a producer of a message or a consumer of the message. We may give extra key value pair of attributes. So we may say that this business processing unit started for user ID of this, and his role is organization was CEO because it was Elon Musk. Then we also have some kind of links and other metadata. But please remember that span represents a single event in our system that we want to monitor. It contains timing of that event and some additional metadata. Then we have a sampler that defines how often we will grab these spans, because maybe we would like to run OpenTelemetry, but we would like to avoid situation when it's killing our production environment. Maybe we are handling like millions of hundreds of requests per second, and we don't want some slowness, so we can configure sampler to capture only 1% of our traffic. Then we have, of course, span processors, which is no longer relevant, and we have exporters. OpenTelemetry is written in a way where you can capture data and export it to many providers. For example, if your company invests a lot in Azure, you may be familiar with application insights. And the whole data that OpenTelemetry will grab for you can be exported to application insights. There are many open source projects like Zipkin that I'm going to use on this demonstration that can be also used to see data produced by OpenTelemetry. And also, as any good presentation, we need to have some data structures and graphs. So this is a trace tree. It might look difficult, but really it's like really simple structure. So on the top of the trace tree, we have a root, something that started the tree. And in this case, we have a HTTP client. HTTP client is a span, and any block that you can see on this graph is a span. Each span, as I said before, can have attributes. So in this span, the one on the top, we have 3 attributes. And basically, any of the spans here is enriched with 3 attributes that are on the right. So the first attribute is called trace ID. So this is the ID of the whole processing unit. This is the ID of our trace for clicking tweet. And this ID is constant, always. Because of that, we may say that these all spans belong to the single trace. So we have trace ID equal 100, and is 100 for all other spans. Then we have span ID. As the name suggests, this is a unique identifier of this specific event that happened. So if HTTP client sent some traffic, it generated an event, and ID of this event is 200. And this is unique ID for this specific block, for this specific span. Then we have a third property or attribute called parent span ID, which is in this example none or null. As the name suggests, it's a link to a father, because in OpenTelemetry, we create a graph of requests happening in our system, because we would like to understand what was the timings and what communicated to what. We need to have a way to go to the father to create this chain of calls. So in this example, HTTP client has no span of parent because it's the root one. Then we go to the bottom. Our HTTP client calls service A. For service A, trace ID is the same, but this time it has a different span ID because it's a unique span. and the parent span ID points to the father. So parent span ID equals 200 because that was the span ID of the father. And we can go to the bottom, we can go to the service B, to the service DE. What is also worth to emphasize here that, for example, service B can create as many span as it wants. So imagine a situation when you send a request goes to service B, and service B communicates with database, with service bus, and maybe it communicates with other API. And with this kind of structure of spans and tree, you can generate the trace. This is how this works under the hood. To understand how this can be written, we need to learn two more, let's say, definitions. So I already mentioned W3 trace context. This is one of the implementation of the trace context standardized by W3C. And you may actually find this even in your already deployed application, because maybe like your client is already using OpenTelemetry and you don't know it. To discover this, you need to check your HTTP headers, because this context is propagated using HTTP headers. And if you ever find out a HTTP header called trace parent and then some magical string, it means that somebody is using OpenTelemetry, and this magical line is a trace context that contains information about the trace ID and the parent span ID. If you see this line magical, I assure you it is. However, it contains 4 sections, and we can try to understand these 4 sections. So the trace context starts with version. As any good protocol starts with a byte or 2 bytes of version. At this moment, the version is always 00. Then we have a section for trace ID. So basically, from our example from the graph, this is 100. Instead of this GUID value, this is the ID of the whole trace. So this is the ID of us clicking a tweet. Then we have parent ID, which is like a shortcut for parent span ID. So this is the ID of the span that was our parent. So by sending this, we may propagate what was the trace and who is our parent. So we can create a graph. Then we have additional trace flags that are used to customize the protocol. So this is about HTTP communication, but I mentioned that we may have different ways of communicating, for example, through messaging. So OpenTelemetry also supports messaging functionalities. For example, it can automatically generate spans about sending a message to service bus, reading a message from service bus. And because span can contain extra key value pairs, we can enrich a specific span with some additional helpful information. So we can enrich our span to say that it was a message sent to Kafka system, then it was to destination of specific queue name, and then the message ID was this. So with this additional metadata, we can easily go through our messaging system, see what kind of queues are used quite heavily, what was the message ID, etc. And the idea behind propagating the trace context is quite familiar for the messaging, because this time to each service bus message, there is a custom property added, and the property is called diagnostic ID, and basically the structure is almost the same. So in this time, we are sending this magical line over service bus message properties, and the reader can read these messages, this header, serialize it, and continue processing of the span. And I promise that was all when it comes to theory. I'm an engineer, so I wanted to avoid giving you even more theory, so I prepared a small demonstration. And when it comes to demonstration, I wanted to just emphasize a few words. It's all open source. It's on my GitHub profile, and it's as fancy that yesterday I upgraded it to .NET 7. So it's top-notch technology there. The demonstration is based on a very simple idea. I built a distributed Fibonacci calculator. It totally doesn't make sense, but it's a perfect example how we can use OpenTelemetry to send some messages, see some traffic, and add custom values to the spans. So the solution is written in .NET, and it contains 3 different applications. The first application is Fibonacci.webService. This is a very simple ASP.NET Core application that contains or supports 3 different endpoints. The first endpoint offers a get functionality. So if you give a number, it returns a correct Fibonacci sequence value for you. Then it contains also a second most important endpoint for posting our requests. So we send information that we would like to calculate Fibonacci for 15. And in response, it returns accepted by saying that the result for Fibonacci calculation will be available later, and the whole magical processing will happen in the background sent by the worker. Of course, we can delete specific result, And you can use Visual Studio Code and HTTP client extension to send the request automatically with a simple shortcut, so you can run the whole demonstration on your own in like 2 minutes. Also, we have Fibonacci.worker. This is a very simple worker pattern application written in .NET that reads a message from the service bus. So it reads the Fibonacci calculation request, runs the calculation, and stores information in the database. And of course, like in every business application, we have a project called shared for shared items. To increase the amount of data that OpenTelemetry is gonna present for us, I decided to add few dependencies to the project. So if you'd like to start this locally, you need to add few Azure services. The first service is, as I mentioned before, service bus. So we need to configure a service bus endpoint and update connection string. It is used to send this request from API to the worker. Then we have a table storage. Table storage is like a repository for the Fibonacci value and number for the end and number of the Fibonacci sequence. And then, unfortunately, I decided that it is not enough. So I added a SQL table and entity framework, which is totally irrelevant. It brings no business value. It is not needed at all. But I just wanted to give you a sneak peek how you can use OpenTelemetry to capture calls to the SQL server and even preview what was the SQL statement that was sent from application to the entity framework, to the database through entity framework. So now let me jump back to my screen. Okay, so now you see my notes and okay, so I'm using Windows Terminal, like 2 splitted panels, because I want to start 2 different applications. To run this project in the background, I also started a Zipkin container. Zipkin is like an application that will be used to gather OpenTelemetry data and present it to us in some kind of small but fancy way. So let me list files in the repository. It might not be so easy, but I'm in the root. So let me go to the source folder. And let's go to the web service. So now I'm in the web API application, and I can simply type .NET run. It should spin up my web API application. As you can see, some entity framework migration run in the background, and application is ready to perform. And then I can go to my worker. And for the same, I'm typing .NET run. And my .NET worker should start soon. OK, the application has started. So now let's go to Visual Studio Code. Let me zoom in a little bit. So in the repository, you may find a file called request.http. And with a small extension to Visual Studio Code, you can send HTTP request with a single line of code. So here I created a variable of 31. And I would like to send a request to our API to get a request for 31. So I can click Ctrl-Alt-R. And I have a new pop-up window on the right that says the request was 200 OK. And this is the Fibonacci value, because it means that for this given value, I already calculated the Fibonacci sequence. So let's try with something different, maybe 27. Not found. So for 27, we don't have any Fibonacci sequence. So I can use a second endpoint to send a calculation request to our API. And let's wait for processing. And now the pop-up window says 202 accepted. And the location is on the /27. So our request was accepted. It will be processed in the background, and we can read the results later. So let's check what happened in the application. So on the left panel, we can see that there was a request to the controller. The request took like 2 seconds. It's calculated Fibonacci value for 27. It was calculated, and it was stored in the database. So these are kind of logs. These kind of logs, imagine that you can see on your Kibana or in a logged file. But what happened under the hood? So to do this, let's open Zipkin. So this is the empty Zipkin portal. Under the hood, I run a processing application. So let's try to click Run Query. So now in the response, I see that OpenTelemetry sent 6 different traces to the Zipkin portal. So let's sort them by time. So let's start with a get operation. Okay, so it would be, okay, I guess it's already deleted. So let's focus on the post operation. So this is the trace that explains that there was a call to Fibonacci.web service. It was 2 minutes ago. There is a number 9 on the right, and it says that it contains 9 spans, and the overall trace took more than 1 second. So if we click show, we have a better understanding what was happening for our server, for our request. So this is like a graph. Here on the bottom, I see the properties. So I can see that it was a localhost server, and the endpoint was a get, and the root was n, and the request ended in 200. Okay, so the whole request took 1 second. But what was happening under the hood? It was a first request to my application, so my database repository had to warm up. So at the beginning, it called table client creative not exists, and this call was made by the Azure SDK to check if the table already exists, and it took half of the second. Probably with the next request, we won't see this warm-up line because it will be already warm-up. As you can see, this span was automatically generated from Azure. Then even we can go deeper because service bus called create. Then the table client. Then under the hood, it was a call, HTTP call, to request, and then finally it was another request that was happening to the table core Windows Azure Net and to my Azure storage account. So since at this moment our table already existed, we can scroll this and go to the table client get entity. So on this graph, we can see that later on, after some specific period of time, there's another span called get entity. So basically, I wanted to read result from my database, and it took more than 160 milliseconds. And even with that, we can go deeper and deeper and deeper to see even internal times of the Azure table client. Okay, so we know how the get request looks like. So let's find the post one. Probably this one. Yes. So I mentioned that the post request from the command line, I read that it took more than 2 seconds. And it's correct. Here I have a trace for the post request. You can see that the overall time was 2.2 seconds. And under the hood, at the beginning, it called database Windows Net. So as I mentioned at the beginning, I added SQL Server Entity Framework. So it started with saving my IP address to the SQL Server database. Then we have additional second span called message. So it created a message with kind producer. So with this kind of filtering and application insights or any, let's say, more advanced tool, we could find out who is creating messages, who is reading them, who is processing them. And as you can see, creating a message is like a matter of almost 2 milliseconds. And then the slowest thing, like the bottleneck of my application problem, was service bus sender.send. It took 1.5 seconds. Why? Probably because of the warm-up. It was the first connection to service bus that I made after starting the application, so it took some extra time. So as you can see OpenTelemetry to find the bottlenecks and problems like performance problems in your application just by looking on the graph. I didn't have to go any logs, analyze them, correlate which request started where. Everything is done automatically. And now you may wonder what happened later, because here I have requests on the web API, so what happened to the worker? So let's go to the worker. And here we have three lines for the worker, and it might be strange. Why we have 3? And this part is tricky. So it was also difficult for me to understand. However, guys from Microsoft explained this to me. So in ideal world, we may say that for us, trace is like starting request, sending command, and reading that comment and processing that comment is for us still the same trace. It's the same business processing logic for us. However, with messaging, it's kind of difficult to do this. Why? Because service bus reads messages on a special dedicated thread, and it can read like 200 messages at once, and then processing messages is up to you. So it would be quite difficult to correlate processing messages with receiving the message with sending the message. So because of that, the guys from Microsoft working on the service bus library decided to split traces into few parts. So we have a part for sending the trace, and that's it. Then we have a part for receiving the message from service bus. And then we have a third trace for processing the message. And all of these three traces are correlated to each other because service bus makers were not sure. They were not sure that you always wanna to have the same trace. So instead of that, they are always starting a new trace, but the traces are correlated to each other with something called links. So if you're gonna decide to use more advanced enterprise tool for OpenTelemetry, you will be able to simply click link this trace to the trace original. So by clicking on this, you will be able to go to the trace web API. I know it's difficult, however, that was the decision made, and now they are thinking about going to the default behavior, which is the continuing the trace. So let's go to the Fibonacci.worker process message. This is the trace that happened to process my request. So at the beginning, you can see that the whole processing message took more than 3 seconds, where internally calculating Fibonacci took 2.7 of the second, so quite long. Then we had a call to table client to upsert the entity. Then we had some internal calls made by the Azure SDK. And finally, at the end, we had a call to service bus receiver.complete. So service bus wanted to mark this message as completed, to be removed from service bus, and it took more than half of the second. So even with the worker pattern and messaging, you are still able to understand what was that bottleneck, what is slow in your application, or even how many requests are coming to your queue. Because if we go to the process message, on the tags, we may find information that the namespace is service bus, because it was created from the service bus, but the kind is producer. So if we have a huge corporation, you may easily filter by types of customers, so we can find out what applications are consuming our messages. We may also find information from which queue the message was read, and in this case, I simply call this commands. And of course, we have the library used, and we have a service bus endpoint that was used to communicate these two applications. So this is quite handy. And the nice thing about this kind of tools that aggregate data from OpenTelemetry is that they can detect dependencies. So I can click to Dependencies tab, and maybe it will be fine. Yeah, I know. The UI here is simply the worst. It doesn't scale. But basically, on this graph, you can see simulated traffic between your applications on the specific environment, and a number of dots should somehow equal by statistics to a real traffic. But you can also filter by any application. So for example, I would like to filter by my web service. And here on the left, I have my web service. Yep. And it shows that it uses few services. One of the services is database, so it uses TCP. Sorry, it uses a SQL server. We have amount of calls made to that SQL server. We have a number of calls to the service bus, and we have amount of calls made to the Azure Table Storage, with fancy information how many of these calls failed. Why we have these failures here? It's because service bus, as you remember, has this kind of warm-up mechanism. So during the warm-up mechanism, Azure SDK has this warm-up mechanism. And in the warm-up mechanism, I called create if doesn't exist. So basically, it sends create requests. And if create request fails with conflict, it means that it's created. So that's why we have these failures here visible. So we can even filter out how many failing requests are happening in our backend system. And of course, we can click on different logs here. If we decide to use application insights on Azure, probably we would be able to simply click and go directly to the Azure resource. So it's quite useful for our investigations. We have more like 10 minutes, so I would like to show you some code because it's kind of easy. So the whole magic behind this application is written in a nice extension method. So I created an extension method called @OpenTelemetry. And let me go as an argument, it takes a service name. So here for a web API, I say it's web API. For worker, I say it's worker. In the first line, I'm setting a default ID format. So I'm setting that the trace context should be W3C. Then I'm doing some very bad switch that was suggested by folks from Azure. So basically, some of the service bus and Azure in general SDK, some of the traces and let's say monitoring there is hidden under the feature flag. And to enable this feature flag for storage and other SDKs, you need to say that for this flag, you set a flag to true. And that's all, except of the rest. So on the services collection, I'm simply calling add OpenTelemetry. Then on the given builder, I'm saying that I would like to add few sources of the data, because maybe in my process, like 10 different modules create OpenTelemetry, but I'm not interested in 2 of them. So I said that I would like to add a source from Azure. Then I say that I would like to add source from calculation activity name. So later on, I will show you that you can add your own source and you can generate the spans on your own if you have very specific line of the code, which is kind of very important for you, and you would like to collect the timings of this very special line or even special method and some kind of extra attributes, you do this with extra sources. And then magically, I call add ASP.NET Core instrumentation, and this line automatically captures our incoming request to ASP.NET Core. So everything like any telemetry from requests that arrive to my application will be collected automatically. Then I'm adding entity framework instrumentation. So I would like to capture any calls made by entity framework. And I would like to configure that to grab the whole statement of the SQL query. And I also would like to grab things for the stored procedure, which I don't have in this example. And then I'm also adding information that I would like to capture any outgoing traffic. So I'm saying that I would like to add HTTP client instrumentation. So from this moment, if I decide to call like a Google or Bing from the controller, a call to Google or Bing will automatically appear on the OpenTelemetry. And then I'm kind of close to the end. I'm calling get resource builder. And I'm saying resource builder default create. So I'm creating like a new application in the OpenTelemetry world, and I'm saying that this is the name of the application. For Web API, it will be like Web API. For Worker, it will be Worker. And I would like to give them the namespace Fibonacci because they are kind of correlated to each other. And then I'm enabling Telemetry SDK. And that's almost the end because, as I mentioned before, the last missing piece is our exporters. So I'm adding add zipking exporter. And this automatically configures OpenTelemetry for my both projects. And it automatically sends data to my container running in the background. So the endpoints are quite simple. We have get to check if it's application running. We have a post to calculate. As I said before, we have activities where we capture IP address of the caller and add this to the service bus. Sorry, add this to the SQL server. We store this information. Then we create a new service bus message. And then we send this message to the service bus. And that's basically all internals for the calculate method. The other like get and delete are quite simple. So I think we can focus on the worker because worker is more important. I didn't show you how to use the extension methods, but actually it's quite easy. Just simply call add OpenTelemetry and you give a magical name of the service. Here I just gave the name of the namespace, so it will be Fibonacci.worker. And the worker is a little bit more advanced because it needs to read the data from the service bus. I'm not sure if you all use service bus, if you do it from Azure, if you use the raw client. But in the raw client, you need to do you need to create a message handler or processor manually. So I'm creating new service bus processor based on specific configuration. And then I'm simply attaching to 2 specific events. So I'm attaching to event handler for failing messages and for event handler for normal messages that appear to my system. So when I received new calculation request on the service bus, I simply read the whole body as a string because a body is like a simple integer. We don't need to focus on performance here. Then when I have a number, I call Fibonacci method. So it calculates the Fibonacci sequence for me. And then with the given number, it stores the information about the n and the Fibonacci value for this in the repository. That's all. The most interesting thing is in the Fibonacci method because here I'm starting my own activity. To emphasize that we can start our own spans and our own activities, I told you that we can create our own sources. So here I'm creating my own source, and I'm saying that this span should be called calculating Fibonacci. And from this place, I will have full kind of information about timing of this specific method, and I can add extra properties to this. Yeah, I wanted to give some meaningful thread slip. Yeah, I know, it's not so well, it's not so good at all. And then we have primitive implementation of the Fibonacci algorithm. And when I have n and when I have a number, I'm adding to this created activity custom tag. So I add a value and I add result. So I'm storing information from the Fibonacci calculation within the span that I statically created. So we can come back to the Zipkin and let's try to find this sentence, this span. I think I need to go a little bit longer. Okay, somehow it disappeared. I think we don't have time to search for it. But as you may remember, the calculation of the Fibonacci sequence took more than 3 seconds because I sent like 27, so it slept for more than 2.7 seconds. So let's go back to the presentation because like we have only 4 minutes. Okay. Okay, so you can run this demonstration on your own. Everything is in the repository. But the most interesting question for me was, is it ready for prod? And here, unfortunately, I have a sad story. Because I started my journey with OpenTelemetry almost 2 years ago. And I did this like an experiment for my company. And then my tech lead said, okay, Łukasz, is it ready, mature? Can we use it? And I said, it's almost ready, man, trust me. And we have 2 years later, and I have the same response. It's almost ready, man. Just wait for a couple of months. Why? I said that OpenTelemetry is stable, but it depends. And the definition, like the protocol, the APIs are stable. However, the underlying implementation, the underlying logic is still changing a lot. And the OpenTelemetry committee said that they want to announce the full let's say, mature of the project where all clients will be ready, like .NET client and Java client, etc. And they want to make this project, let's say, slowly contributed. So some of the applications, like the Nugget packages, are stable, but some of them are not. So in this example, to run this demonstration for you, I had to use OpenTelemetry version 1.4. So it means that version 1.0 was already released, and it is true. But version 1.0 depends on other beta packages. So you still need to grab beta packages to your application. So if you still need beta packages, it's better to always grab the latest combination. So I had to inject these beta packages to run the application. And unfortunately, things are changing so frequently and so fast that service bus library also contained a bug. So to make it, let's say, properly presented, I had to install the beta version of the Azure Messaging Service Bus package. At this moment, it's already stable, but Service Bus Library is still not stable when it comes to NuGet naming convention. So the decision is up to you. Its product is kind of mature, the API are stable, but the naming is not so easy to understand, and of course, the naming is not stable. And why it is important? For your home project, yeah, it's stable. For your not so important application in the company, like internal monitoring tool, I think it's also stable. But there are some applications that are business critical. And in my company, we have a policy that we scan releases on the Octopus. And if we find out that any release package contains a reference to a library which is not stable because it has like alpha, beta, gamma in the name, we say that the whole release is marked with beta attribute. Why? Because we want to emphasize developer to focus on the stable libraries and stable versions, not rely on the beta packages. So to answer your question, we don't use it on prod, and I don't recommend it at this moment, maybe in some smaller project. However, for few applications, we enable this on dev and test, just to experiment, play with it, be ready when they become stable, because for us, it will be like updating libraries and making our extension method public in our shared component. And then all applications will be automatically enriched with service bus, with OpenTelemetry. And that would be all from me. I think we have like 45 seconds for the questions. Okay, I think we don't have any questions, or I may be wrong.
So thank you very much. Okay, thank you very much. If, of course, any of you would like to ask some questions, then there will be great opportunity because the lunch break is coming. So thank you
very much. I will
again.
be here for the next few hours. So
that's great. We will definitely keep the conversations going near the tables. So you can join for the lunch over there in the break room, and we will meet again in 45 minutes. And there will be changes because this one big room will be split in two. So if you would like to hear about the Scrum practices in DevOps team, then please join this part of the room. And if you would like to hear about the .NET 6 migration, then this will be the other part of the room over there. So have a nice meal and see you in 45 minutes. Hey, welcome back after the lunch break. I hope you won't get asleep right now because we have a lot of exciting speakers ahead of us. And the first one, I know maybe he doesn't look like it, but he has more than 15 years of experience in IT, and it doesn't mean he started at 5. So please welcome Łukasz Pyrzyk.
Hi everyone, I'm Łukasz, and today I'm going to tell you a story about my teams that I support as a Scrum Master. So I'm going to tell you something about the problems we faced in our daily work and some experiments we took to try to overcome them. Okay, so who we are? We are 3 teams of cloud and DevOps engineers and architects who are focused mainly, but not only, on Azure Cloud. One team is dealing with stuff like cloud security and compliance toward industry standards, and 2 other teams are focused more on more specific customer needs related to cloud infrastructure and everything what is needed to run robust cloud application. In secure environment. Okay, so what is specific to our teams? So it's specific that we do not support a single product. We rather act as shared services for multiple products in KMD. So we are trying to deliver value, let's say, for the entire company. And someone may ask, does this setup fit to Scrum framework? I had the same questions when I joined KMD 1 year ago, and I realized that this stuff is completely different than what I dealt with software development teams. So there was no single application, no single group of stakeholders, many operational tasks around every day. And is it really Scrum environment? So my first impression was that not at all. Maybe they hired a wrong person. Maybe I do not fit to this environment. But then I rethink it and decided to give it a try and check how Scrum practices can work in the world of cloud infrastructure. Okay, so one of the first things we did is to realize that behind all this everyday work, there is still a product. Actually, you can find more than one product in your team, like we did. For example, we found infrastructure as code templates, the product that helps to build a production-grade environment in an automated way. We found set of compliance as code policies, the product that help KMD to reach industry standards like ISO 27001 and be able to prove it in front of auditors. We found cloud financial management toolset, set of scripts and tools which allows us to manage cloud resources more efficiently and save some money. We are also thinking about creating a new product, self-service platform, that will help with common user needs and improve time to market of these products. So, as you can see, we identified many products, but does it mean that we should focus on all of them at once? In my opinion, it's much better to select just one product that you can focus on in terms of developing of new features. Of course, you still can provide some ongoing support to other products, but as far as new features are concerned, I think it's much better to have just a single focus. But which products should be selected for developing of new features? So, which product is the most valuable in promising for our stakeholders? In order to select the most promising product, you should describe your product with answering of set of questions. Which questions? For example, what product it is, who are our consumers, target users of our product, what problems do we try to solve, what are positive changes about this product, what is the unrealized value behind it. do we have any business goals? And if so, how do we know that they are met? So, yeah, what are the current risks and trends? Is it something that are currently influencing our product? And is it possible to create such a product at all? So by answering these questions, you will have much better overview about the potential behind your product, what is really important and valuable for your stakeholders and organization. In order to improve, let's say, this description, I recommend to use product vision templates created by Roman Pichler. You can find them completely for free on romanpichler.com. Such templates can be used to kickstart a new product or even align where you currently are in development of your current product and when do you want to be. So you can use them as inspiration to create also something new, some new template that is better tailored to your needs, or you can use them as they are. Okay, so let's assume that we have selected the most valuable product. We have a product owner in our team who is willing to drive the vision of this product to make it the best on the market. But how this development really looks like of a cloud features. So here I would like to present you how Microsoft is creating and releasing new Azure features. Because I think this is really agile, how they are doing that. So when Microsoft launched a new feature in Azure, first it is released as so-called private preview. In order to use private preview feature, you should be invited by Microsoft by some email like, hey, we created something cool, maybe you want to try it out. Such feature is limited to just invited audience, and there is no SLA and no support from Microsoft. But you can still play around with that and see is it anyhow beneficial. Provide some feedback to Microsoft, and based on this feedback, they can improve the product. After the private preview stage, Microsoft is releasing public preview. Public preview is available for every Azure customer, so everyone can use it. There is still no SLA, but there is limited support from Microsoft. This audience, receivers of these features, can evaluate it, provide some feedback to Microsoft, and based on that, Microsoft is releasing final version, which is called General Available Version, in short, GA, which is just regular Azure feature with SLA and full support included. So you can safely use it for your production application. What's important for us as cloud DevOps engineers teams, that we should sometimes check some feature as early as possible, like in public preview stage, so we can take evaluation of such feature to the sprint with a goal to validate them against our needs. And then when it's GA, when it's production ready, we are ready right away to support other solutions with this feature, so we can react faster on changing market needs. Okay, so this is how Microsoft is developing cloud features, but how we as KMD DevOps team are doing that. So this is an example of how we can approach to some new Azure GA feature, for example, new type of database, which seems to be more cost efficient or better, have better performance. So when we have such a feature and want to try it out, first we are selecting some example customer who is interested in trying it. It can be, for example, from some Danish commune, who is interested in changing this database to the new version. And we are taking to the sprint POC with a sprint goal to evaluate this POC against cost, easy of use, usefulness for our solution. We are also consulting customer for the feedback about the POC. And based on that, if the POC is successful, we are planning the next sprint with the goal to implement this feature on all customer environments. We are starting from pre-production test environments, check how it works, is it stable, and after that, we are deploying this feature on production. So when we have it ready for one selected customer, then we can try to roll it out on all customers, like 50 Danish communes. And in order to do that, we are trying to bundle customers, like let's make it for 5 customers every sprint. Yeah? Such bundle needs some coordination with customers, some service window, and so on. And such bundles allows us to roll out this feature more smoothly and incrementally across all customers who benefit from it. All right, so let's assume that we have some feature which is deployed in production, but how we are measuring this feature in terms of how many users it have, adoption rate, and so on. For this purpose, we are using some metrics. Metrics are used to increase transparency about our products. But what metrics we are using? Of course, we are using velocity, a basic Scrum metric, but it just helps us to be a bit more predictable. Yeah? So we are checking how much we delivered recently, and we are trying to plan similar amount of work. But does it really say something about a value we are delivering? Not really. In order to check the value behind the features we are creating, we are using more product-related metrics. For example, how did a new feature influence all solutions in KMD? How secure these solutions are? Are they more secure? If so, how to prove it? Yeah? What is the adoption rate of a new features in KMD? Are these solution owners, developers really aware that we delivered something new? And if so, where we spend the most effort? Which product was the most expensive? So as you can see, instead of some general process-related metrics that can be helpful, we are much more focused on product-related metrics and checking how what we are doing influence other solutions in the company. All right, but how to create these metrics if they are sometimes very custom and specific to particular product? For this purpose, we are using Power BI. Power BI is a tool from Microsoft for data visualization with strong focus on business intelligence. Why I like this tool and why I do recommend this tool for other Scrum Masters and DevOps engineers? Because you can create by it one-page dashboards that contains the most valuable information for your audience. So you can create a dashboard which is adjusted to your audience needs. So for example, if your audience is more business-oriented, you can expose more business information in this dashboard. If you have the audience which is more technical, you can focus on technical things on this dashboard. So having such dashboard allows you to track many things which are refreshed automatically, like adoption rate of new features, your impact you are making on the other solutions, and increase transparency and awareness in the organization about what you are doing. Of course, in many cases, you can use some out-of-the-box widgets to calculate metrics, like some widgets from Jira, Azure DevOps, and so on. But you are usually constrained with these widgets to how they are designed. And if you want to show something different, sometimes it's hard. What's more, if you want to use some out-of-the-box features, sometimes they are, let's say, more expensive than Power BI because they are involving transferring some data within Azure when you are changed for every gigabyte. And by Power BI, you can connect directly to the source and take just enough amount of data to present your dashboard. Why Power BI? I think that's a great tool also because you are presenting data which is always up to date. and refresh automatically. So if you are showing some information, they are data-driven. So it's hard to undermine such arguments that are data-driven. So you can be also more efficient in discussions with management, because you are showing data which is taken from the source. You can also save a lot of time for reporting and like preparing some reports for management. Once you create such a dashboard, it's available always, and it's always up to date. You can also use some built-in connectors to fetch data from many sources. So for example, one of my team is using Jira, and the second one is using Azure DevOps. And if you want to have a coherent overview what your teams are doing, you can aggregate it in Power BI on the single dashboard. What's more, last week I learned about one new fantastic feature of Power BI, which is web scraping. So for example, if you want to extend your dashboard with a data which is not included in your data source, but it's publicly available on internet, then you can just copy-paste a link to this page, and Power BI automatically web scrap all tables that can be used on your data model. All right, so we have all these metrics, tools to track them, but how to start with Power BI? If you are new to Power BI and you want to play around with that and gain some skills, I can recommend you two great sources of knowledge. The first one is the official course from Microsoft. You can just type in Google Power BI learning path and take the first results. These lessons are free and are really, let's say, well prepared. And if you want to make your Power BI reports a bit more sexy, I recommend to visit a YouTube channel, How to Power BI, and you can find many great lessons which helps you to improve your reports on another level. All right, but when we know that something is done, so for this purpose, we are using definition of done. The first time we discussing a definition of done with my teams was something like, do we really need it? We are doing some different type of work, yeah, that it's hard to find some coherent set of rules that can be useful. But when we take the perspective of products which we are working on, we found some common rules that can be used as DoD. For example, for cloud engineers teams, we can have DoD like, if possible, apply every change by a code. If you have some new feature, add Grafana monitoring to it. When we deploy some new functionality, please update Power BI reports to track adoption rate. And when you finish development, please clean up all cloud resources to do not generate unnecessary costs. So this set of definition of done helps us sometimes to determine whether we are done with our work or not. Sometimes we can argue on things like, should we do everything by code when it takes 1 day and we can do that by hand in 5 minutes? But even if you make another decision, this should be discussed with the team on some daily or other meeting, and we should reach some consensus that this is something that we should do in this and that way, and definition of done are, let's say, some starting point of this discussion. All right, and what other tools and practices from the Agile world I recommend to use for DevOps and cloud engineering teams? So the first thing I recommend is using liberating structures. These are a set of 33 scripts for conducting meetings and conversation. The idea behind liberating structures are to, let's say, decentralize control over meeting to other people and engage them more in creating the next steps. The other tool is Miro or Mural. inclusive collaborating whiteboards. So these tools became more and more popular during pandemic, due to nature of remote work. But I still see that they are not so popular for more technical teams, like DevOps engineer teams. They are more focused on drawing some diagrams in Visio and so on. But these tools are not very well known to them. But I think that's it's a really good way to improve your workshop. Like you can prepare something in advance, send it out to your participants, ask for preparing some initial input. So when you start your workshop, you will start with something. The last tool I recommend is Mentimeter. It's a tool for preparing and conducting interactive presentations. So when you present some data or some information, you can ask your audience for feedback, for answering questions. So you can even adjust agenda of your presentation on the fly, depending of your audience feedback. Apart from all these tools, I think what's the most important in the Agile work is to be open to conduct experiments. Yeah, if you are looking for some big framework which will solve all your problems, you probably do not find any. Yeah, you can find something which can be helpful, but on the other hand can be very complex and time-consuming to adapt. So best you can do is to take 1 or 2 experiments every sprint, validate it every 2 weeks, discuss on the review with your team, was it good or not? Yeah, and improve it or abandon it if it's not useful. Only by making such experiments, you can find your perfect ways of working. Okay, I think this is from me. I hope you enjoyed this presentation and find something useful for you. If you have any questions, I would love to answer them.
Okay, thank you, Łukasz. If there are no questions right now, I'm looking for raised hands. Oh, okay, I can see one. Yeah, please.
You mentioned that you identified a couple of products when you started that product exercise at the beginning, and then you show a couple of templates that help to do this kind of discovery. And you also mentioned that you wanted to end up with a single product. What is that single product?
So in one team, right now, this product is this compliance as code policies. We call this product landing zones. We see the biggest potential on this product due to, be more secure and compliant with, variety of standards. But it doesn't mean that we completely abandoned other products. Yeah, this is our main focus for now. But I believe that once some business goals are met or some milestones are achieved, we can switch to other product, which will be beneficial. Yeah, but for now, the main focus are landing zones because we really believe, and this was proved by our evaluation to the tools I showed, that this will bring the biggest value for the KMD.
Any more questions? 3, 2, 1. Nope. Okay.
Thank you.
So thank you very much. And of course, if you would like to ask some questions later, you can find Łukasz in the break area. And right now, before I will invite you for 10 minutes break, I would like to tell you / remind you that if you didn't take your black bag yet, then you can find them on the chairs. Please grab one. It's for you. It's free. And right now, please join the 10 minutes break, and we will see each other for the next speaker soon. Welcome back after a short break. And right now, ahead of us is a speaker who joined KMD 2 years ago for our internship program called Talent Lab. And 2 years later, she's here as our expert and will be talking about Scrum in distributed teams. Please welcome Monika Pyrzyk.
Hello? Okay. Welcome, everyone. So my name is Monika Pyrzyk, and I will talk today about remote work and Scrum in distributed teams. Eva has already introduced me, but I will only add that I joined KMD 2 years ago during the pandemic, and right from the beginning I was working in distributed team, and this will be a topic for today. Hopefully all of you will find something interesting. For you and your teams, I have 3 goals for this presentation. First one is to emphasize that remote work concerns all of us. Second one is to stress that remote work can work, but we need to provide supportive environment. And third one is highlight that effective teams are built by maximizing team productivity, not individual productivity. So we will talk about how to keep unity and take care of camaraderie within the teams. Yeah, so let's start. Okay. Remote work is a new reality based on research. I have read many research preparing this presentation. Actually, I've gathered some good reference lists, so if someone is interested, I can share it after the presentation. And the trend is obvious that hybrid work and remote work popularity increasing year by year. So that's the fact, we cannot negotiate with it. That's why leaders puzzle over how to make hybrid work work. And that's why many concerns and doubts appeared, among others, can we do Scrum in distributed teams? Because we have in Agile Manifesto this principle that the most effective way of communication is a face-to-face conversation. So we will talk about benefits, challenges, and factors that we need to focus to make it the most effective. Okay, I have already mentioned some terms like remote work, distributed teams, and collocated teams. There is no simple dichotomy between collocated teams and distributed ones. There are many different setups. I think that's important to learn what is your setup that you are working on a daily basis, because all of them have some benefits and risks, so it's important to know them. In KMD, we have teams composed of workers from India, Denmark, Poland. So we are all our communication is remote. One important aspect that we should take care of is to learn other culture. I mean, it will make the communication and whole collaboration much easier when we will know how people are making decisions, how they are defining the role of work in their lives, and what are their values. So that's important when we are working in distributed teams. Okay. Yeah. Remote work is nothing new, but pandemic demanded it from us, and it's definitely more popular now. Why we are enjoying this remote work that much? So first of all, the main popular benefit is that it gave us great flexibility, so work-life balance. We don't have to resign from anything. We can wake up, eat a breakfast with our families, brew a coffee and drink it from our favorite mug, and in a minute later join a business call. Also, we don't need to spend hours commuting to work every day. That's really important. Very often we are always heard that people can focus better when they are working from home because there are less noises and less disturbance that sometimes from the open space we can met. But there are also benefits from the employer perspective. So access to a wider pool of talents. I think this is the benefit and also argument why it will not change, because we cannot just easily decide that, okay, we will hire people only from our city or only from our country because we are missing specialists. Also, my colleague sent me an article with this specific title, that introverts can shine. So as you can see, different people, different perspective. There are also some risks. So the main one is feeling of isolation. So during the pandemic, it was the very popular one, but we were not prepared. We cannot compare this environment to the one that we have now. But it's definitely harder to form new relations when we are working from home. So remote work only also can affect communication and trust. It doesn't need to, because we can take care of it and prepare the teams for it using specific tools and make sure that they have all things that they needed. But we need to be careful about that, because it's definitely harder to build trust and feeling of unity working remotely. Okay. So before we will move to the main question, does the Scrum work in distributed teams? Key takeaways. Remote work is omnipresent and it won't change for now. Remote culture is very important regarding the efficiency, and we need to have it on our mind. And that management has really important task to do, noticing employees' needs and make sure that they are visible for them. Okay, so is collocation a prerequisite for success with Scrum? No, it isn't. So nowhere in the Scrum Guide we have mentioned that we need to have people on site. However, in Agile Manifesto, we have this principle that I have mentioned already, that the most efficient and effective method of conveying information is face-to-face conversation. But the world has changed and we need to adapt. So I think we have replaced it with our videos on, with an eye to verbal and non-verbal communication. There is also this principle that we need to build project around motivated individuals. So making sure that we provide them specific hardware and tools, and then of course focus on the interactions. There's also very nice practice in extreme programming. The name is Sit Together, and that predicts that the more face time you have, the more human and productive the project are. If you have a multi-site project and everything is going well, keep doing what you are doing. But if you have problems, think about ways to sit together more, even if it means traveling. Okay, so we know that this is not a prerequisite. However, we have some factors that we need to focus on to make it more efficient. I'm assuming that all of you have familiarized with Scrum framework, but let's quickly remind few facts that will be needed to understand following slides. So Scrum is a framework for building products in complex environments. So complex environment means that we cannot predict that practices that we have known will work in this particular situation. We have 3 roles: product owner, Scrum Master, developers, accountabilities actually. 3 pillars that help us verify our assumptions, because this is empirical process: transparency, inspection, adaptation, and 5 Scrum values: focus, openness, respect, commitment, and courage. What is the most important in our work? So no matter how we work, at the end of the day, it's all about deliver value to the client. So I found very, I think, nice, in my opinion, a metaphor of a Scrum team. So this stool has 3 legs. Each leg is 1 accountability in Scrum, so developers, product owner, Scrum Master. On the stool, we have 5 books that imitate Scrum values, and this vase at the top present business value, fragile construction. So I think it very nice exemplifies why collaboration is that necessary? Because if we have one leg broken or we are missing a book or two, it may have negative effect on our value delivery. Those values, why are they that much important? Because I think when you have a group of people and they lived by the same values, it's the first step to become a team. Scrum values are lived differently by each Scrum team, and it's hard enough to do even when we are physically in the office, and the complexity of remote work make it even harder. But there is an exercise that you can conduct within your team to ask them how they are considered that those values are modeled physically and in the remote environment. What are the differences? Why is that important? Because we are all guilty of interpretation bias, so open dialogue about our behaviors might be vital to keep healthy and value-delivering team. Good. But what are other factors that makes a group of people a team? So I think the most intuitive one is a common goal, so a sense of mission. In Scrum, we have a product goal as a long-term objective and a sprint goal as a short-term one. So it's very important to communicate them transparent way and make sure that all of us have the same understanding, that we are all on the same page. Clear work requirements. So this is something that is always important, not only in remote work, but it might help us to keep the workflow fluent. So optimizing the amount of uncertainty. So maybe you can consider having more often backlog refinement meetings. Values I have mentioned, and trust, hopefully it will appear when with time, but I think that when people have the same values, it will appear sooner than later. An internal team contract, also very important, not only in remote environment. So this is how we work as a team. I will share with you some exemplary questions that you can conduct during preparation of that internal contract. So how do we contact each other on a daily basis? How do we schedule conversations? How do we indicate our availability? In my team, we have separate channel to inform if we are have a 1 hour break or something. How do we collaborate on design activities? Maybe we can agree on some specific tools. How do we do team meetings? Who facilitate them? So can we, for example, as a team agree that before we will add something to our calendars, we will make sure that this meeting has an agenda and goal, and maybe even indicate a facilitator for this meeting? It might be an example of respect value. What are our bands about what we would like to not have jokes? And how do we handle our boards? So actually how we work as a team. When you mix this one with this exercise about values, you will receive kind of your team playbook. So how we work as this group, specific group. Okay, I also asked my colleagues what are their practices to keep team unified and to take care about this camaraderie. And we all agreed that the main philosophy should be keep it human and remember that beyond the monitor there is a person. So this is an example of their practices. So as you can see, if it's possible, organize on-site team meetings. So we are flying to our coworkers to Denmark. They are visit us in Warsaw. The more practices like online coffee talk, some videos, games via online and stuff like that will make it even more human. One-on-one meetings, of course, videos on, and everything that will keep it human. So that's the main motto, let's say. To conclude this presentation, I would like you to understand that just because people are in the office doesn't mean that they will collaborate effectively. There are some factors that no matter how we work, we need to focus on and make sure that we are thinking about them on the daily basis. So when we will have a team that can rely on each other and support each other, it doesn't matter where they work. And the debates about remote work will never go away, but for knowledge workers, it's actually pretty sure that we will be working with people that are in different locations, even if we will be in the office. So different people, different needs, different styles. We need to be mindful of how we work and making sure that we are providing people what they need to work effectively. Remote work is the future. The future is ours. Hope you enjoy it. Thank you so much.
Thank you, Monika. Do we have any questions? Now's the time. Anyone?
Don't be shy.
No, looks like one-on-one conversation is something that will be maybe more convenient for participants. So please feel free to approach Monika in the break room, in the break area. And right now we will have a 15 minutes break, actually. Yeah? Yeah, even almost 20, because we will see each other 25 past 2 here for the next talk. And for now, I can invite you to the break area. Thank you very much.
Thank you.
Hello again. Welcome back. And right now, I hope you are ready because we will be talking about the Elements project, which is one of the fastest growing projects in KMD. And we will have not one Scrum Master, but 2 Scrum Masters telling us all about it, especially how to scale in a very fast-paced and not become a victim of own success. Please welcome Ania Szybszak and Alicja Frąckiewicz.
Okay, so hello everyone. Thanks for joining us for this speech. My name is Ania and this is Alicia.
Hello.
We will be telling about scaling done in a slightly unconventional way. So we are going to tell you the story of how we scaled the Elements. And before I do, I have to apologize to you because apparently there has been some informal agreement that all of the speakers are wearing black and I was not reading the right channel. So. I'm not going to bore you with our life stories, but I can tell you what are we going to talk about today. So we will give a brief introduction. Of course, we will state some goals for this speech and for this meeting. And we will, of course, tell you a story of Elements. And that's our journey. We will give a short summary, but we really hope for some interesting questions at the end of the speech we have allocated. Yes, I know we can count on you guys on the back seats. So we hope for some discussion or for some interesting or maybe more controversial topics. And the goals for today. So, of course, we are going to talk not only about some opportunities that we took, but also a lot of challenges and things that went wrong on the way. I hope this will be interesting. We will show you the path that we followed. And just a small remark, it's been 3 years since we started, so it's a long journey. And of course, we won't be able to tell you about everything that happened in the meantime. But we will try to pick the most juicy snippets from this novel and present them to you. Hope you like them. And our main point, I think, is to actually try to convince you guys that it is possible and it can be valuable to actually grow your own organic scaled project without really adapting any ready-made frameworks or some detailed descriptions of how you should do things. So we grew our own, and that's what we are going to talk about.
Okay, you can thinking what KMD Elements is. KMD Elements is a cloud solution to handle with complex data validation and advanced formula-based settlements on time series for companies operating in energy market. And when we started, we were only 3 teams set up, and now we have more than 100 people in our product. So you can imagine what kind of journey we had. The first chapter, because we have a chapter, it's about the lack of trust. When I joined to KMD Elements in 2019, as I said, we had only 3 teams, and the third one was really new because it was created 3 months earlier. And we have also 3 persons in a product owner's role. And these product owners were acting as a PO's body. So they were present on every meetings, every Scrum events in all 3 teams. And they were not invited into the daily meetings because the teams didn't want to invite them. And my first observation was that we have a huge lack of trust on both sides, in business and in development. The sign of this lack of trust was that sometimes POs were asking me if someone is at work because the name of this person wasn't be assigned to any specific task on the board. So it was an assumption that this person is absent this day. what we did, we started from the make all these things transparent. We made all these things transparent because it's the first step to change something. You need to start talking about these things which you want to change. And we started talk about the lack of trust. We started talking about the splitting POs between the teams, but at this moment in our history, they weren't be able to. They didn't want to split it between the teams. They tried to acting with all teams as a PO's body, as I mentioned. We had a common meeting called Nexus, and it wasn't connected with the Nexus framework. It was a meeting which was a creme de la creme of our daily meetings. It was like status dedicated to POs. And we didn't talk on this meeting about our challenges, about our issues. We were not transparent in our communication. And the first step to change this situation was to start talking about it, and we did it. The POs were ready to split it between the teams with creation of 4 teams, because it was impossible for them on the physical level to be a part, take a part in every meeting in this bigger setup. So it was a crucial moment in our history when we started to have a dedicated PO to the Scrum team, because we started to create some relation with them. We started to talk about our issues. It was a crucial moment for our setup. And what next? We started to try convince our teams to invite POs to the daily meetings. I know that they are not required, but it was a sign of the next level of trust to invite them, and we convinced our teams for some little experiment for 2 months. And the result of this experiment was that they are needed on these meetings, and they had a moment when they had a chance to collect all this information that they needed, and they stopped to try control our setup, because they finally started to feel that they are a part of our Scrum teams. So the level of our trust from this moment was starting to increasing. You can see on this slide what kind of synchronization point we had at this moment. And further you will have a possibility to see how it changed during the time. What is important, this situation was before pandemic. We started to work together in physical on-site world.
Okay, so I'm going to take over from here, and here's our next chapter. So this is exactly where COVID hit. You're going to love it. Because what happened is that suddenly, instead of 3 teams, we were 6 teams, 3 Scrum Masters, and a situation in which we cannot actually be physically present in the office. So if we had any communication issues before, this is exactly when they all became very visible and very painful, to be honest. So we really had to learn our lessons fast in order to establish certain alignment and communication channels, and this was also our focus. So the trust thing started before, of course, but in such a situation in which you have to recruit people remotely, you have to work with people remotely, suddenly, you have to really bet everything on building trust and an environment full of trust. So how we approached that? We focused on fostering open discussions on different occasions, different fields, different meetings, because obviously it was difficult to speak to others in so-called meantime, because there was no meantime, there were no kitchen meetings, there were no desks standing together, and we were not used to it. And to be honest, we were not really so well prepared to start on this journey. I don't know if anyone was, actually, but we had to do what we could. And Yeah, it became a real challenge to actually synchronize on daily basis, because while we were still present at the office, teams would often come and visit each other plannings and other meetings, and they could immediately exchange information whenever there was something unclear or they needed to discuss some dependency and so on. But here, well, there are no other meetings, so we have to sync somehow. So how this thing changed? First of all, we had to invest in a completely different tool to do some workshops and visualize stuff. So we decided to experiment with Mural, and this was also the very first time that we were using a virtual whiteboard to facilitate our meetings. I will show you the magnificent results in a moment. And what is also important, the Nexus meeting, which was, as Alicia said previously, a place to actually give a status of your sprint to the product owners, became a space for sharing information with other developers on what's actually going on in the sprints, so that everybody was on the same page. And well, the review, what's interesting, and where the title of this great, I will remind you of the title for a second. Nothing to present. Where does nothing to present come from? It actually comes from our review, because well, being so enthusiastic about having a great remote review on Teams, we thought it's a great idea to actually have all the teams present, or at least say something on this meeting, regardless of the fact if they actually have something to present or to demo. So some of our reviews at that time actually consisted of a number of people stepping up on Teams, switching their camera on and saying, "Hi, it's team XYZ, nothing to present, thank you." So we tried to learn on it because, well, this is a lesson, and you just gotta take it for what it is and try to act on it. So in the future, as you will see on the next slides, we actually managed to get out of this trap and improve and adjust our process to our needs. But the important lesson here is, I think that on the journey to a bigger scale of organization, you will encounter a lot of traps, and you will encounter a lot of funny or silly or sometimes embarrassing situations, and it is the nature of the process of discovery. So there's nothing wrong with it, and you just have to remember to learn, not only feel embarrassed. And yeah, there was also one new meeting that we introduced, was the alignment, because guess what? When you are working in a setup that is basically in two different countries, in Denmark and in Poland in our case, it is really not so easy to let people casually chat over the emerging issues or some current topics. So we really had to create a separate meeting for that, for us to be able to talk to the management out there and to communicate about some current progress, some important topics, try to get some decisions done or not, depends on the case. But yeah, we were trying. So this was yet another experiment. And if you were wondering about our first magnificent uses of Mural, there was also a lesson here. If you want people to start using a completely new tool out of a sudden, give them some instructions first. Because what we ended up with were some random boards with a completely uncomparable schemes of what people put there. Of course, each of these pictures that you see here is a plan for upcoming few sprints, and there are features, of course, there are teams, but putting all of that together in a single plan, believe me, that was a big problem. But we also learned our lesson. And here's another exciting chapter of our story and no dependencies. I wonder if you can guess where this came from. Of course, we stepped in another hole, so to say, and we decided, okay, since we are a big remote setup, let's focus on how we are dependent on each other. Because when the complexity of the setup is growing, it really makes sense to think a little bit before about how a team or a feature depend on each other. So in order to do that, we had people discuss it on Nexus meetings. Guess what? We also wanted everybody to speak up. And what happened? Actually, on the timeline, and that was somewhere around autumn 2020, there was the 7th team and the 4th Scrum Master, And this was the very exciting moment when we decided that 7 teams is a little bit too much for one head of development to handle, and that it makes more sense to actually have Marcin Moskwa, who's with us, and his counterpart in the Michał's person. So we wanted to make sure that like all of the people in our setup have access and have the possibility to actually have a relation with their manager and to talk to him or her and to exchange some observations. And also a fantastic new role appeared here, that's the terminators. And probably those of you who have never heard of Elements are wondering what this might be. It has nothing to do with the famous movie, but we just nicknamed the role so that it sounded more funny than serious and maybe was a little bit more acceptable for the audience. So the terminators were actually representatives of the teams who were in each sprint responsible, first of all, for attending this common Nexus meeting, but also for handling different kinds of cross-team issues or maybe some defects or some production environment problems and so on. So we were big enough to actually need a separate role for that because otherwise nobody felt accountable. And speaking of our Agile journey, that's also the time when we focus on learning and learning our lessons well. Because when you are growing, really, you cannot afford to make the same mistakes over and over again. So you've got to learn and you've got to improve. And we were experimenting a lot with that. And one of the successful experiments here was introducing the post-mortem meetings. So whenever something went really wrong in the project, we would have all the people involved meet up and discuss, like, okay, guys, what happened? What's the timeline? Is there anything we have to fix? And how do we make our process more bulletproof in the future? And also the different kinds of feedback loops were very important for us. And speaking of the feedback loops, I don't know if you heard, probably not, but Elements, even though it is such a big project, it actually doesn't have a very direct contact with the customers on our review meetings. So we don't have customer reps, we don't have customers themselves on the review meetings. We have some intermediaries that can then speak to our customers. But this was the first time in the history of Elements that on the review, whenever some team was presenting the outcomes of their work, we were asking a question, okay, so how is that relevant to our customer? How does that impact our clients? Is it important? What are the customers going to do with that functionality? You may think it is obvious, you may think it is stupid, but if you are working in a very technical and modern IT environment, and you don't have your customer present all the time, it is really easy to actually forget that they are there somewhere and that you are building something, not to build like a technically perfect solution, but you are building something that somebody will use in the end. So this is how we were trying to change our focus. But speaking of changes, unfortunately, things were often changing for us very last minute because we didn't have direct contact with our customers. But we improved one thing. So this is a screenshot of our mural for the big planning for teams with a completely new template. And again, you may say, okay, it's a template. That's some silly stuff that we are selling here. But ordering or structuring work on such a big meetings when a lot of people are participating and they are tasked with like similar things to do, it's really better to have a structure. And it's really easier for people not to struggle with, oh, how do I do this? Should we put it in lines? Or maybe should we put it in columns? Or maybe we should do a mind map or whatever. If you provide a structure, it's easier to follow. And just to prove that it's not just a silly idea, we got some feedback after this first time that this template was introduced. And as you can see, like people kind of liked it. I hope they still do. But yeah, we were trying to improve not for ourselves, but for the people and for those who are actually using the solutions.
Okay, the next chapter is dedicated to respect to others. In last year, we signed the next contract with new customer. And guess what? We identified the need to grow up. we decided to hire more people because we are not big enough. And the situation on the market was convinced our managers to hire whole outsourced teams, because the speed of recruitment process was too low, and we needed these people right now. And with this decision, we should face the next level of complexity in our setup and new challenge to integrate people from other company in our setup, with our setup. We had a lot of challenges, and this was the next one, the new one. And a big part of focus our Scrum Masters at this moment was dedicated to integrate these developers, the new teams, and organize their work and way which can handle with the differences in our style of work and our culture of the companies and our vision how the collaboration should look like. It's a long story about involving people in our activities, sharing the knowledge, about building the culture of being thankful, appreciating someone's help. And we started to have the part of review meeting dedicated to say thank you to other people. We started to have a new meeting with our managers to have shorter feedback loop. We started to make the synchronization on every single level as simple as it possible. And we started to use the kudos for this appreciating, and you can see on the slide how many kudos after one sprint, 2 weeks of work in our product we got. It's almost 30. You don't have to calculate. And our product was at this moment so big that we tried to understand all the details. And we started to have some sessions of event stormings, because it was too hard for one person to understand all the things around this product. The size was too big.
Okay, so the bubbles, this is actually the last chapter of the book that we wanted to present to you today. And, well, it's not about champagne and it's not about toasting for success, but it is about how we struggled. And we struggled for a very long time to actually divide a product that was so big, that was like slightly unsustainable on its own, to divide it into domains, sub-products, product areas, you name it. And the first idea that we developed at the very beginning with the management and with the architects and with other people who were like close to the topic is to create some product areas that would encompass like just a few teams and a few business topics that were related to each other. But of course, we did it wrong, and this idea slowly died over the upcoming months because what we tried to do is to divide a product based on its architecture and not really on the business sense of it or the business functionality or even the personas or the customers or however. We focused almost solely on the technical layer of it. And well, the lesson that we learned here, and I guess it's very important, is that if you are developing a product, and it is very small at the beginning, you should, of course, think that, well, success isn't guaranteed and maybe this product will fail. And then I don't have to plan for the future, but you should also plan for the success. And you have to think about, okay, how this product is going to develop, how is it going to grow? And you should actually think about domains, about some possible split at the beginning, and you should, I guess, at least business-wise, try to construct it in a way that some boundaries are already there when it is small. Because when it is like a huge, complex business technical spaghetti, it's really difficult to separate a few single noodles and put them in a separate box.
What we did, we started to switching our architecture from monolith to the microservices, and this change was supporting for our tries to make the work of our teams more independent in this big product. And we started to work in some work groups dedicated to specific topics because it's easier to collect a smaller amount of people on one meeting. We started to have meetings with dedicated to create a roadmap on the teams level, which was a change because in the past we had this big planning meeting for all our teams, and we didn't want to have this meeting longer, so we changed this focus to the teams more locally, make it more locally, and we started to build the roadmaps in our teams. What else? We started to create these bubbles, but from the other perspective, from the perspective of process for our customers, not from the architectural level.
Yeah. And what is really interesting here that we learned that in such a big setup, it's a little bit like becoming a professional sports person. So, of course, it's fun to actually train and do exercise for fun. And then it doesn't really matter so much if you have a little bit of extra fat here and there, or maybe you are not so stretched in some places. But once you become a professional, you really want to get rid of everything that is unnecessary and everything that will basically hamper your progress towards, winning the gold medal and being absolutely the best. So what we had to do here is actually remove or start removing everything that didn't bring enough value for us to consider it effective or possible to stay. So we removed some of the meetings, and the milestone planning was actually the first thing to disappear. So we focused, as Alicia said, on creating roadmaps that they are maintained offline mainly, but each of team has their own sequence of features dedicated for them, and we'll sometimes do workshops around that, but there are no official huge meetings for it. We resigned from any kind of checkup or alignment meetings with management, but we do have and we still maintain a Teams channel with our product owners and with management. So whenever there is some urgent matter, we can just post it there and people read it. And then if there is need for some meeting or some call, we just organize it. And even more importantly, we realized that if there are 11 teams, as you saw, it's absolutely impossible to schedule a meeting in the calendar that would require more than 10 or 15 participants in there, because the calendars overlap and it is impossible. And also it is very inconvenient and uncomfortable for people in both the business and technical roles to actually have meetings scattered all over their calendars and giving them really short periods of uninterrupted technical work. So what we did, we actually rearranged our calendars in a sense that certain business activities or business meetings or team meetings can only happen on certain time slots on certain weekdays. So in this sense, for example, Wednesdays became the no meetings day for most of the teams. Some Fridays are also no meetings day. But what we focus is okay, we are having the meetings. Let's have them either in the morning, just after dailies, or let's have them at the end of the day so that there is more space for creative and technical work in the meantime. And it really works. So apart from removing some of the unnecessary things, we also decided to make what we have as lean as possible. We are still working on it. It's not like it's the end of the journey and we've done everything we could, because every day basically brings up new challenges for us, and we notice new pieces of waste or opportunities for improvement. But the idea is that we are trying to address actual problems, not really trying to fit our setup into some framework that we decided from the beginning, oh, this is great, we're gonna try it, but we are building our own solutions, and we are building solutions to existing problems, not some imaginary ones.
So we are not masters in scaling, but we know something about this topic. If you have questions related to the metrics, because we missed this topic, we are open to answer your questions.
Because one more thing, and I really forgot about to say about it in this area, is that we focus also on making our decisions data-driven. So we are observing a number of metrics, and these metrics are evolving over time. So when we started, we were mainly observing like the sprint contents and velocity, all the basic stuff that you probably heard about. But right now, we are sometimes even comparing some estimations with, I don't know, actual effort or like different kinds of things, or maybe the time that we on average or mainly need to close a bug or to close a user story. So we are looking for different kinds of useful pieces of information.
Time's up, so thank you.
Thanks a lot.
Okay, thank you very much. I can see that you are disappearing already, so questions in the break area. Okay, so we have 3 minutes break right now. We can see each other here at 3 o'clock, and stay tuned because this will be really nice talk coming up. So see you soon. Okay, welcome back. I can see that the people are gathering and gathering. Yeah, okay. So, right now, feel excited because we have one guy who is a developer, DevOps engineer, platform team member, platform product owner, and the architect, and all of that in one person. Please welcome Roman Głogowski.
Hello, it's nice to be here. I prepared such slide, but I believe it's not needed anymore. But maybe it's worth to mention that all that role that Eva said, this is in a single project. It's in KMD elements. DevOps. Over the last few years, DevOps definition and understanding changed, evolved, and I believe there is no single sentence that can describe what actually DevOps is. But for this presentation, let's define DevOps as culture of work with one single and main principle: you build it, you run it. And with that in mind, let's imagine we are not developers, but we are building a car. Our team is responsible for building a car. So as a team, we must build our own engine, we must prepare our own tires, we must put everything together and then deliver to the customer. And as you for sure understand, building cars is quite complex. You need to understand metallurgy, you need to understand how to mix alloys, you need to understand electricity and much, much, much more. And to bring everything together, it needs a lot of knowledge in your head. And in general, it produces some cognitive overload on you. So you have to maintain a lot of knowledge from different disciplines. And actually, it's not directly connected to the way to your responsibilities. It's not connected to your passion and so on. But you still have to keep it in mind. Then maybe in some companies we have more than one teams, and each team is building their own cars. So we have one, and as usual, cooperation between such teams. It's, let's say, not perfect. So each team is working on their own solution, on their own concept, and knowledge is not propagated across organization. And with such situation, we are constantly reinventing the wheel. And because of that, we are losing money, we are losing time, we are losing people because they are not doing the stuff that they are hired, but they have to know, and they have to know a lot about whole setup. They have to constantly repeat yourself, and it's just boring. As Ala and Eva said before, Element started more than 3 years ago. We started with 3 teams, and at the beginning we had monolith with few satellites, let's say around 5 applications. 3 teams, 5 applications, and each deployment of new application took around 10 days. And in that scale, it was acceptable because we had just few applications. But when our setup was growing, when we had 7 teams and around 23 applications, and we started our microservices journey, that cost was not acceptable. Because in the future, for sure, we would like to create more services because our number of the domains was growing. Still spending 10 man days, so it means that one person works for whole sprint on deployment of new service. It's totally unacceptable. It was bad. We had some conversation with management, such conversation. No tears, but still not pleasant one. And we had to do something. First of all, we checked our DevOps approach, if it's correct, if we are doing everything by the book. But it was not fault of the DevOps. It was not fault of our approach. Actually, it was fault of our scale. Because when we started small, then some activities that we done, like this reinventing the wheel or this cognitive overload, it was not visible because we are doing this not too often, quite rarely. with just few services. But when the scale was growing, when the teams, new teams arrived, such issues were more and more serious. So because of that, we are looking for solutions of that issues. We are checking of some extensions of the DevOps approach that can help us and save time, save money, save people, because we like to work with our developers. And we found out that there is quite interesting new movement, which is called internal developer platform, which is kind of extension of the DevOps approach and the way how we can efficiently work in DevOps setup and efficiently work with growing setup. So in general, let's split internal developer platform definition into 3 pieces. So first of all, IDP, internal developer platform, is some of all the tech and tools that platform engineering team binds together to path golden paths for developers. Here we have first highlighted term, which is a kind of building block for the platform engineering. Golden path is set of the templates, set of the scripts. For instance, it can be microservice template, it can be repository template, it can be platform, it can be pipeline template. So all such tool that which allows us to not repeat yourself. Just take it, parameterize it, and use it. One remark: golden path. It's term designed by Spotify. There's also other term like path. I don't remember, but similar term provided also by the Netflix. Okay, let's move on. The second part of the definition, IDP lower cognitive load across the engineering organization and enable developer self-service without abstracting away context from developers or making the underlying tech inaccessible. Yeah, so as I mentioned, cognitive overload is something that is very common in DevOps setup, and this is also something that we would like to avoid because this is a waste of money. So with our platform, we would like to make our developers' life easier so they can focus on the business, not on the DevOps world, not on the infrastructure, because in general, this is something not interesting for them. They are doing this, but in most cases, they don't like it, or maybe they are changing sometimes work because they're forced to do this. And also, other term that is not highlighted, but also is very important, it's self-service. Because we are constantly growing, we as organization, but also other organizations that are using platforms, they're also constantly growing. The self-service part is also very important because it allows developers to do anything on their own. So they can create new application, deploy it, maintain it, monitor, and everything by themselves with the tools provided by the platform. And because of that, their life is easier, they are more efficient, they can spend more time on business activities. And also the third part of the definition, well-designed IDP follow a platform as a product approach, where a platform team builds, maintains, and continuously improves the IDP, following product management principle and best practices. What's important? As I mentioned, we would like to make our developers' life easier. So first of all, we must talk to them. We must understand their point of view. We must understand what are their needs and what issues they are struggling. When we understand their world, we can provide something, some mechanisms that can make their life easier. But of course, after some time, we need feedback for them. And all that parts, when we collect them, it's called exactly product management. So this approach, we have just, we are, with this approach, the way how we are working with our platform is actually established and well-defined. So we don't have to reinvent some stuff that other companies already done. And because we are working with our platform as a product, it's very important to have appropriate person as a product owner. Platform is not regular product, so you can't take just first business product owner and say, from this day you are platform product owner, enjoy it, and this is your team, of course. In general, platform it's very technical stuff, so you have to you need person that understand developers' need. The person that knows how to communicate with developers, he must understand his knowledge, his language. So in general, in most cases, this person is some kind is architect or at least some senior engineer. Like, well, in our case, it's architect. You know. And of course, such product owner also must work as regular product owner, so he's responsible for vision of the product, but this vision must be aligned with the needs of the customer, of the developers, and also he's responsible for prioritizing backlog. And here, fun fact, developers would like to have everything right now. Not tomorrow, no, in 5 minutes, right now. I'm just raising requests, where's my functionality? So this prioritization and cooperation with developers is quite important. Maybe a few words about how we built our internal developer platform and what kind of issues it solves. But before that, I believe once again, a few words about our about elements, but this time from technical point of view. So elements, it's time series based billing engine. There's one sentence. It means that we are collecting overwhelming amount of time series data, processing them, and in the end we are saying how much money should pay that party to another party. Soon we will process, we will store 10 terabytes time series data in many different storages that we have in the platform. And soon we'll have to ingest data for around 10,000 meters per minute. When I'm talking about meters, it's about meters that you have at your home. Those meters are sending data to electricity company, and then electricity company is sending those data to our system. So it's quite challenging. We need significant performance to handle this and so on, but this is not so important. Once again, about our setup. Right now we have 11 teams and we have 69 microservices, and that number is still growing. We are still discovering new domains. We are still delivering new services, new BFFs, new frontends, and so on. Everything in micro approach. So this deployment part is really important for us because if we will spend 10 days for each service, I believe most of our developers just sit and type some pipes. Yeah, we have 25 environments split into 5 stages. So it's into dev test stage and production. On each stage, we have one Kubernetes cluster. And right now we are doing 80 deployments per day for int, dev, and test environment. So as you see, having or maintaining this DevOps part of our project, it's quite important. Yeah, so 1 year ago, all our applications was deployed on PaaS services, on Azure PaaS service. We are using Azure Functions, Azure web applications, and the amount of flexibility that those platforms delivered was not enough. So first decision, we need something that is more flexible, that allows us to easily deploy new application faster with some additional strategies. And then we decided that we'll use Kubernetes. And because we are using Azure Kubernetes services. The biggest benefit of Kubernetes is the way how it manages state. Actually, you are just providing expected state to the Kubernetes, and Kubernetes and all the operators and controllers working there, they are just aligning state of the cluster to your requirements. Then we must somehow build our application and deploy it. So for building and release process management, we are using Azure DevOps. We have dedicated pipes for that. But continuous delivery for continuous delivery, we are using Argo CD. Tool is totally magical. First of all, it's GitOps tool. So we are storing desired state of the application in Git, and we have all the policies applied on our Git repository. So we have pull requests, we have list of the approvals, and so on. Deployment windows for test environment. Everything is based on our Git repository, and then there's Argo CD that is consuming our repository. It's generating all the Helm charts, all the Kubernetes manifests, and applying it on the Kubernetes. The difference between Argo and other solution of this kind, it's wonderful UI. Of course, you can use console application like with other tools, but let's say it's much easier to just click in the web browser, choose appropriate pod, check the state of the pod, check configuration of the pod, and you can do this in just a few clicks. You don't have to remember all the command line. Additionally, on the dev environments, developers can check logs of the application just using UI. They also with just few clicks. If they need to align some configuration and check how this new configuration works on the environment, they can also do this from the UI. Then they can copy this configuration to the repository and follow the regular process. So this is kind of foundation of our platform. And the most important piece that exists in our Kubernetes cluster. Service mesh. As I mentioned, we have microservices. Microservices are very chatty. And there is one requirement that is very common in all the sectors. All communication must be encrypted. And if you ever created some certificates and had to manage it, it's quite a significant issue because you must establish your own certificate authority. Your application must be ready for some certificates renewal. So it's quite challenging. And Istio gives you this out of the box. You're just deploying it, enabling it, and it's working. And it gives you a few additional benefits like wonderful observability. You saw already Zipkin on one of the first presentations, so all the spans can be exported to the Zipkin, but also gives Istio out of the box, give you wonderful metrics that can be checked with Grafana. Also, Istio is deployed together with some basic alerts that can be customized and assigned and aligned with your setup. Monitoring, no-brainer here, just Prometheus as a pack of Kubernetes stack. So it's deployed together with Grafana and Alert Manager, nothing fancy. And data storages, here another funny part starts. We are using Azure SQL Server, no-brainer here, we are using Azure, there is SQL Server, we are using it. But for the Redis, we decided to use to deploy this on Kubernetes cluster. We are using Bitnami Helm charts for this. Well, nothing fancy, but Elasticsearch is something fancy. Yeah. So you know there is a bunch of the Helm charts or a bunch of the YAML definitions that you can just use to deploy Elasticsearch. But Elastic Company delivered a dedicated operator that allows you to easily deploy and maintain Elasticsearch on your Kubernetes cluster. Operator's name is Elastic Cloud on Kubernetes. And it allows you to create your own dedicated objects called Elasticsearch and Kibana. and define all the properties, all the configuration as a part of these objects. You are just sending this object to the Kubernetes, and then Elasticsearch operator, it's creating Elasticsearch, it's creating Kibana, it's creating all the certificates for the communication. Whenever you would like to change version of the Elastic, you are just changing one attribute in the YAML, and then magic happens. Operator just restarts all the nodes in the appropriate order, so the cluster is available all the time to the user. So it's very, very simplifying all the administrative work around Elasticsearch. So our platform engineers have more time on other activities than just watching Elasticsearch. As I said, we have microservice-based architecture, and for sure you know there's no real microservice architecture without message broker. Ha ha ha. But yeah, we need message broker because we are processing overwhelming amount of data, especially those meter readings, and we decided to use Kafka because of the well-known performance, well-known scalability. And of course, there is a lot of way to deploy Kafka on the Kubernetes cluster. We decided to use Streamz operator. Once again, it's operator, and Streamz simplifies the way how our platform team members interacts with Kafka, and it lowers all the maintenance requirements. So for instance, if you need to reconfigure Kafka, then you are just changing Kafka object, and then Streamz operator during reconciliation process, it's changing some configuration in the runtime if it's possible. If it's not possible, then Streamz operator is trying to restart all the nodes of the Kafka in the order that will not break anything. So Kafka will be still operational and available to the user. And this is our abstraction. Yeah, it looks really, really abstract, but in general, we followed all that rule that I mentioned. So we prepared, we have my template for the microservice. We have template for Azure pipelines. So each time developer would like to deploy new microservice, he has set of the templates for that. When he have application, then he has to create pipelines in Azure DevOps using templates. After that, he's cloning our Helm chart repository, and he's registering his microservice there. And of course, he's providing also configuration file. This is part of our values file, the most important part where the services are registered. So we have microservice object. There we have, for each microservice, we have name. For this example, we have central address registry API. For each service, we have owner. So when application is failing, we know which team is responsible for that. We have type of the service. Right now, we are supporting only .NET, but in the future, I believe we will support also other technologies like Python, maybe. Image that must be deployed on the Kubernetes. How many applications, how many instances of the applications should be deployed. There's also option to set max number of such replicas. By default, it's 10. Then let's skip migrations for now. And then we have infrastructure part. And in that part, developer describes what kind of infrastructure is needed to deploy this application. So in this example, we see that SQL Server is required. And also we have here information where connection string should be saved when database is created. We have information that Kafka is required for this service. Also, we see that this application would like to produce some messages on the topic. There's also a section for consuming. Basic on that list, we are creating access control list, so we can easily block some applications for consuming events that should not be consumed by this application. We have also two other sections that are not visible here. Developer can define that Redis is required for this application, also declaratively, and can set up communication with Elasticsearch, also using YAML syntax. And let's go back to the migrations. We have here situation that application requires a database. So in most cases, application would like to have some structure inside database. So developer can define some migrations that must be executed just after the database is created, but before the application is deployed. Yeah, so in such, so our platform delivers set of the tools, set of the templates, set of the abstractions that allows developer to easily deploy application. And comparing to the car, to the scenario that we are building a car, developers still have possibility to log into the Kubernetes cluster, have possibility to log into the Argo, look at the objects that are created on the cluster, and also they have possibility to interact with these objects. Some conclusions. Pure DevOps doesn't work in big scale. So you need something that will help you when you are growing. It can be, you can choose many different solutions. We chosen platform engineering as the one most promising. Yeah, so it also solves our issues like cognitive overload and constantly repeating ourselves. When you decide to build your own platform, just use proper tools. So first of all, you must understand your needs, you must understand your use cases. If you are not sure what will be the best tool, but you see that you need this kind of tool, just follow some easy decisions, check some technology radar, and this will help you make decision. Create proper abstraction, because this is something that must be very carefully prepared, because this is something that it's hardest to change in the future, because it's living organism after we give it to the developers. GitOps and Kubernetes operators really simplifies your need and allows for creation almost every abstraction that you imagine. And actually the most important, start small. So first of all, go to your developers, ask questions, ask what is the biggest pain in their daily work related to application lifecycle. Deliver first part of your future platform, and then take feedback and repeat. So it's iterative approach. You must constantly ask your developers about their feeling and about their needs. Oh, sorry. Not mine. Okay, any questions?
Just one question from me. So I would like to ask about this term, internal developer platform. Is it something you invented in Elements, or is it some industry term you adopted?
No, it's industry term. There is also platform engineering as a stream in computer science. It's still growing. So there's also a lot of materials in the internet. There is a wonderful book about Teams topologies, which also describe some part of this, maybe not platform itself, but platform team, some real valuable member of the setup.
Okay, thank you.
Okay, thank you, Roman. Any other questions? Looking for hands. Do you have hands? Okay, no hands raised. So thank you, Roman, again.
Thank you very much.
And right now we have 4 minutes break before our last speaker in the track. So see you in 4 minutes. Oh, yeah. Hello again. Yeah. This is almost the last time you see me. And right now we will have our last speaker from the track number 1. And this will bring a very important question about the value of testing. Is it just a cost, or does it actually bring something to us other than being a pain in the ass for developers. So right now, before you will present a tester who then became a Scrum Master and then came back to quality assurance. So it feels like he likes his quality. Please welcome Andrzej Mika.
Good evening, everyone. It's so nice to see all of you here. And yeah, as Eva mentioned, value and testing. Is it possible, do you think? Yes? No? We have an no? Yeah, and the voice for the tester for no. Okay, my presentation is done. But, about what we'll be really talking today. So firstly, we'll start with quick introduction, and I will talk about what testing really is and where this value can be found. Then we'll go through 3 different cases that really happened in 3 different companies about how smart thinking and just going out of the box can bring value to the testing. So first will be about Postman as a quick win. Then we'll go to understanding your product and the client. And last but not least, you will hear once again about elements. I know, it's third presentation. I have difficult adversaries before me, so I will try to show elements in even better view. So let's go. Firstly, what does the tester certification, so YesTechUB, says to us about what the testing really is? So it's a validation and verification of a software. Such a boring thing, you know? But it's important. It's important to that extent that there are some companies, some sectors of the market that really use just this approach. We are talking about banking industry, about pharmaceutical industry. It is so important for them that the software is validated and verified because they have a lot of laws that they must adhere to. And if we are talking about pharma, we are talking about human life. So, you know, it must work. But other industries? Not so much, really. But why? Why in other industries it's not so important to test? Or maybe we don't have, let's say, so much of testing? Because it differs on what you are gaining value. In, for example, games, it's important to be quick to market. It's really not matter how good quality is. It matters how fast you are in the market. And in a lot of products, it's the same thing. It depends not on the quality of the product, but the time you are going to the market. Of course, you can hear it all here. It's a thing that should be tested properly, and it was not working, and it was a little bit of pain to the people using roads in Poland for some time. But yeah, so do you guys think, once again, in your life, in your companies, does testing bring any value to you? Or not? For real. You are working with testers? You are not working with testers? You are shy ones. So let's do exercise. Because it's late, you are all tired, so I will go for that. If you think that testing brings value, please stand up. Okay. So most of you think like that. Great to hear that. So I will show you 3 ways on gaining value from testing, and not related only to created test cases and validating functionalities of the software, but how to do it smart, how to do it fast, and how to gain feedback on that. First thing is interesting one, because there was a company and a team in that company that was working on some external APIs. And they didn't want to use existing test set in this company because it was heavy, it was unreliable, and it was just slow. For example, building of this framework was taking around an hour. So it was not convenient to use it at all. And also, the framework was over-engineered. It was made by developers, and testers who were in the company, mostly manual testers, doesn't understand a lot of it. It was really hard to create a test for them, so the framework was not used. And when we are going to a little bit of waterfallish kind of deployments that was there, it was theoretically working automated regressions, which was always done manually. So the framework was not used, or the tests were not fixed. So the situation was really not good. And what was happening in the company in the meantime? The agile transformation happens. And some of the teams use it really well. And we are talking about this example. So we have an API team. Why do they need an UI tests? Why they need this Java, Spring, Serenity, Cucumber framework? There is no need for them for that. But they need something fast. And need something that will also allow testers to work with developers. So they were thinking there is a tool that our testers in the team are using, Postman. Postman has a runner, Newman. We can put it in some microservice, some Docker. We can add Jenkins to that. And what we have? Testing framework that was developed in under the week, that was running really fast, and was the one and only solution for contract testing that I ever seen. And it was so much of a success for a team because this was the only team that were doing their testing during SIT phase fully automated. The solution itself was giving a team possibility to test their every changes because it was cheap and running fast. And other teams started to go to this team and saying, hey, you have this amazing API test set. Could you lend it to us? Could you teach us? So it was a nice, let's say, example of how an big agile transformation in a company can help team to just make their decisions, use their tools that suit their needs best. Of course, let's not say that this solution has only good things in there, because if someone worked with Postman, they will know that there is an issue with storing tests on Git, because Postman has his own, let's say, repository. And if you don't want to use Postman repository, you have a problem. Because storing Postman's tests in Git is not readable at all when it comes to code review. So you have to always drag the tests back to your PC, run them, and check them in Postman. But it was still faster than the old solution. So this is our first example. So we don't have to always use the common tools, always think what is the best for you and for your team. Second one, I think my favorite one, we have the second company. This is a technological company, 100% focus on their own product that they are selling to clients. And it's really strange, but they had problem with gaining feedback from their clients. They had a lot of clients, but most of them were big industry clients. And you don't want to go to the clients like, for example, Citibank, and ask them each week, oh, how are you liking our new release? No, they will not answer that. They will not talk about usability of the product. Even so, they have 20 versions of your product installed already and don't want to see you or hear from you anything. They hate you. But what we have in company? We have a funny thing called bootcamp. This bootcamp is that all new hires in company must learn the product the company is making. So, okay, each month we have a group of people that are using the product, learning how to use it, and doing the same stuff. So we have great control group. Each month, what we can do? We can measure usability. We can go to this education team and say, hello, we are testers, and we can help you if you can help us. We'll give you this small form. You know, there's 5, 6 questions that you will ask at the end of the bootcamp, and it will be valuable for the whole company, for the product, because we'll learn. And you will also learn. You will be closer to the technology people. We'll communicate and work together toward better good of the company. And it helped, really, because when the product was made, the education was really using the newest version always. So we were testing constantly, month by month, on usability of the product with different people, with different points of view, because there were not only developers, they were testers, they were accounting people, there were people from HRs, from the whole company, just using the product. So we learned a lot. We learned how the product is perceived. We learned about also advantages comparing to other products, because our was not that much known by people. And there were a lot of different competitors that people know coming to the company, so we can learn. So what I here would like to say that not only normal testing is important, also is to ask yourself a question, is there anyone in your organization who can help you? That you can go and gain knowledge that you think you don't have access to. So think about your company, what they are doing with the product, and how they are cooperating in between departments. And it corresponds also to third thing, which are called with a little help of my friends, because it's all about that. As you heard, elements on previous talks are now really, really big project. And as you also heard, we are a calculation engine. This is our most crucial functionality. If this functionality not works, our clients are losing money, they are getting fines from their clients, so we are getting fines. So it's not a good situation at all. What we also know, that this calculation engine has an infinite amount of edge cases, so we cannot test it all. So what problem that we have? We had a defect found in a similar application in KMD that caused a fine. And we heard from our management that we must deal with the issues before fines come to us. So, okay, what we have? Calculation engine, critical part of application. Millions of possible edge cases and scenario. Really, testing is pointless. Really low-level testing, really unit testing, integration testing is important here. But testing our business scenarios is really hard. So we have a possibility of huge waste of money and effort. That will create some testing framework that will not work at all, or will just use enormous amount of resources. But, and it's a funny story, because I was really not convinced about doing anything with that. I wanted to just point a sticker and say, hey, we have something new, it's working and covering us, because I was not thinking that it can bring any value. So I was talking with support guys from support of our application, because I was presenting the application to them, they were new to the application, and I was thinking, it's only fair, if they are support, to present our level of quality, because they should know. So I have gone to our wiki page, and I was going through all of the testing possibilities and elements, how we are testing, what we are testing, and what we are doing. And the chief of support said to me, Andrzej, but this comparison test that you have here, I used to solve things like that in previous company. And I was like, wait a minute. You saw it? Yes. And we are working on client data. Really on client data, and from that I think, okay, so if there will be possibility to have a client data, the scenario changed drastically, because now we have a really working scenarios. We are not bubbling into these millions and millions of possible edge cases. No. What we are getting and what we are working on right now. On creation of valuable testing of real-life scenarios that we'll get from selling our solution to the client as part of functionalities of the product. So we'll sell testing, my first in life. I love it. So it will also give us possibility of lowering of costs, because we already have this test set. We have it on artificial data or on data that we find that will be possible to do or maybe good to use from our ETLs, our migration team, and more possibilities of testing in the future, because it's a beautiful word for tester when the client is coming to you, giving you their data, and test on it, and we will pay it. Like dollars here, dollars there, use our data. Because normal word for a tester is that I want the client data. And I really cannot get it because of anonymization, because of no one wants to give your data permanent to you. So it's also always a pain. And right now, if this project succeeds, because right now we have working solution, of course, but we must still sell it. So if this project succeeds, it will be an enormous value to the organization itself, because not of lowering the costs, but because of this data, that the clients will be willing to give us data and pay us for that. So, and why this help from the friends? Because you heard the start of the story with the support guys, but there's also a second side to this story, that this project that we are making right now, it's a cooperation of 4 teams right now. So there's one development team that is creating the calculation engines, so they have a knowledge about how the engine works. We have also migration team, because we need data on our environment, and they knew client data. We have also a QA team that is overseeing the whole project. And right now, platform joined us. You know, they know the costs, they have the tooling, and they can help us. So what I would like to say here is that testing and value are working together if you do this, let's say, step backwards. You look at the whole organization and you ask organization the question, how can I help? Where is the value in quality assurance as a whole? What are we needing? What are we missing? Where we can help our developers develop better product? And on the other side, how we can help business to recognize what is needed to be developed. So to start thinking at the start of the process. And yeah, that's all from my side. If you have any questions, I will be more than happy to answer them. And I saw that there was 2 people at the side of the room that didn't stand up. So did you change your minds? Testing have any value or not? Thank you. So any questions? If not, then thank you.
All right. Thank you, Andrzej, very much. And right now, this is the end of the track number 1. And I can invite you for a break. And soon after the break, we will meet once again, same as at the beginning, in one big room. So you cannot miss this place. And see you here in 15 minutes.
Test. Okay. Welcome back. In the world full of technology, do we expect it to become autonomous and self-governing? Are we heading for Matrix or Star Trek? Our last speaker for the day, partner at research company 4CF Strategic Foresight, and a member of the board for Polish Society for the Study of the Future, advisor on strategic foresight for institutions such as UNDP, NATO, UNESCO, and many others. Let's give a warm welcome to Kacper Nosarzewski.
Hello, good afternoon, everyone. It's often said that it's very unfavorable to stand between people and lunch at events, but I have the privilege of standing between you and not just a meal that is a very mundane, everyday thing, but I'm standing between you and the kickoff for Polish national soccer team at the World Cup in Qatar with Mexico at 5 p.m. So I will absolutely not mind if you leave early. But if you do, you will miss the moment where you get to decide. Maybe. I'm so glad to be with you tonight, and I'm sure that you have your heads full of inspirations, of interesting cases, of things to consider, of things to reflect upon after the whole day of event, after all the presentations. And I'm also addressing this to people who are watching us online. Thanks for being with us, and thanks for you for being with us here, with me here in the room in person. So I was thinking, given my final position in this day, what kind of questions I should answer, what kind of topics I should raise with you. I thought, finally, maybe once you have listened a lot, maybe I should give you a bit of an opportunity to speak. And I'm saying this alike to people in the room as those who are watching us online. Maybe I should give you a bit of voice and let you decide on some of the matters that I will be raising today. Where do we go from here? I want to talk to you and talk with you about the futures of empowerment or the futures of alienation, that the development of technologies, specifically information technologies, ITC, photonics, and other high technologies such as microelectronics, that all together form a nexus, that all blend into what becomes a digital reality to people, what becomes finally what fusions, what merges with the physical reality to become the daily experience of billions of people around the world. So the influence of technologies on how we see our place in the world in political terms, in human rights terms, and in our role in shaping the future and our role in shaping our own destinies. So that's what I want to talk to you about. I just wonder, okay, so I should stand here so I'm not in the way of the slides. Last weekend I was teaching a class at Krakow University of Technology, AGH, and I asked one of the students what was their interest, what they wanted to focus on in his research. And he said he wanted to focus on the on the experience of people with disabilities and how it's mediated by technology. I said, well, that's great, but what do you really mean by technology? Do you mean all kinds of technologies, like the white cane of people with a disability of sight, or are you talking about everyday technologies like a screwdriver that drives the screw? I said, no, I'm talking about technology. Technology. So what he really meant was, of course, the digital technologies, because it seems that for many people in their everyday experience, but in case of this person, in his research agenda, this is the only thing that meets the definition of technology. Everything else, all the technologies of the last 40,000 years that we've developed as humans, have just blended completely into our experience. And this is, of course, nothing new, and we know it we've been knowing it for a long time, that there is technology that is akin to magic. completely don't know how it works, but we are awestruck. We are in a state of wonder when we're watching it happen in front of our eyes. But there's also technology that just becomes part of ourselves. Martin Heidegger said, using the famous example of a hammer, that when you're driving nails with a hammer, once you get a little bit of practice, you don't think about the hammer anymore. It's an extension of you. You're focusing on the nail, and the hammer becomes a part of you. So technology in this way becomes part of ourselves, lets us expand. But also dangerously, perhaps, if it's not a hammer to drive nails, but a hammer to, smash someone on the head, it also enhances our possibilities, and sometimes, before we think about it, we go over, we transcend some limits, some boundaries that we should not. It's a tragedy if it happens to an individual person and they do wrong using technology. But it's statistics when it comes to the fates of nations and when it comes to governing people. Or it's a tragedy, but on an unimaginable scale. So when we're talking today about the futures of empowerment, the futures of alienation, of course, I mean technology in this more familiar sense. Technologies, digital technologies that are around us, digital, electronic and photonic technologies that are around us, but also my own way as a futurist of tackling this is I want to talk about technologies to come. Technologies that are not yet there, but that will, or may, or perhaps will offer new possibilities and new opportunities in governing, speaking up, but also being silent, empowering ourselves, learning how to use our freedom, but also sometimes being repressed, being the victim, not having a way to speak. Why even before we get into the gist of the question of what technology can do to us, let's start to look at it as a way to deal with our problems. Not that technology is dealing with us and we are the problem and it wants to get rid of us. Like in Matrix, reduce us perhaps to human batteries, lying in bathtubs and powering computing power of an artificial intelligence. But what is the state of the challenge? What are we expecting from technology to help us with nowadays? Of course, the main issue, and this has always been the main issue, is productivity. If we're talking about language as a technology, or if we're talking about use of fire, or domestication of animals, or if we're talking about a microchip, or if we're talking about quantum computing, it's all about productivity. Productivity to, of course, improve our standing and our economic situation, but also productivity to overcome things that had not been accessible or had been too difficult to tackle before we've had the technology to deal with it. It seems like over the last 50 years, little changed in terms of the vision of doom that awaits us. Exactly 50 years ago, we've had two major events in terms of the way we see the future and the way we imagine the future. One was the Stockholm Declaration, a foundational piece of policy and ideological statement about our relationship with nature and how the way we interact with ecosystems and how the way we interact with Gaia, yes, with the whole ecosystem of the Earth by using the resources, giving in, giving back, polluting, but also producing, perhaps regenerating. How we should look at this, much prior to when climate change became the main line of our relationship with the planet. But also another major event in 1972 was the publication of Limits to Growth report sponsored by the Club of Rome, and it was a big step for thinking about the future and using the future because it was a first major report that tried to simulate that used computing for a simulation, a holistic simulation of interaction between the mankind and the resources available on the Earth. And researchers from Massachusetts Institute of Technology who worked on Limits to Growth, published 4 scenarios, each one of them presenting the interplay between the rate at which we consume through investment and consume through just maintenance of mankind on a global scale, and on the other hand, of course, the way that we deplete the resources. And the rate at which we deplete the resources, or at rate at which we use the resources, because some of the resources may be more or less renewable, or at least are available if we regenerate at a rate that is manageable. It of course depends on the productivity of our systems. The story wasn't new. It started in the 17th century when Thomas Malthus said that we should perhaps go easy on helping poor people, because if they reproduce, if they just, there's too much of them, they will eat all the food and the civilization will collapse. This is not that kind of oversimplification, but the premonition that we get from Limits to Growth report repeats a similar model. With the assumed rate of productivity growth, we will, around 2050, start, just through the growth of population and through at the rate that we consume, through energy demand and through extraction of minerals and through use of water and atmosphere, we will just reach a tipping point, a peak. And then with the number of population on planet Earth, we'll start going downwards in a downward spiral where we will not only able to grow, but when civilization will collapse. And this was the case for 3 scenarios out of 4. In the 4th scenario, the assumed rate of productivity growth through innovation, technological innovation, was high enough to take us farther and farther and farther. This is the 4th scenario, the lesser known scenario among the set of limits to growth. But then the question I have put on this slide is it a productivity problem or a human nature problem? Is it so that when we're looking at the limits to growth and how technology helps us overcome them, is it an issue of can we innovate ourselves out of trouble again and again and again? Or is it perhaps about the way we think about it, where we just maybe we're just not asking the right questions, and maybe the whole thing is maybe not such a big issue, because even when we didn't have the statistics to deal with it and we didn't have the data available, we still always innovated ourselves out of the problem. So maybe it's just a fear of the unknown and not an actual reason for concern. My colleagues from KPMG, they are in the same building here, yes, but their Canadian counterparts have recently recalculated limits to growth feeding new data. It all turns out the same. So those who tell you that this is not a real issue and the collapse is not going to happen, I don't know. I haven't been there, I haven't been to the future, but as far as the models of limits to growth are concerned, we're still on the path towards doom. This creates this is perhaps also not new, but with the kind of communication protocols and media that we dispose of now, that we have at our disposal now, we learn that this realization, that this knowledge or this premonition creates a very special sentiment, a very negative sentiment. And here I've mixed some of the quotes that are a few months old with some of the quotes that are 50 years old from around the Stockholm Declaration, but they are all generally in the same spirit. The first one is my favorite. It's a quote coming from a couple of months ago in China during social unrest, civic unrest, and political dissent in Shanghai. This was the motto of the people who rebelled against the rule of the Communist Party. We are the last generation, thanks. You cannot promise us a better future according to Maoist capitalist principles that rule the authoritarian China, because we're not interested. Because knowing what comes after us, we are the last generation. We are not going to bring about another generation, we're not going to spawn any babies to live in the world of collapse and in the world of doom. So you cannot blackmail us with, taking the future away. You've already done it. So, and this is why we don't need to listen and we don't need to obey. But this, so I sum up all these sentiments in one sentence, and that's also 50 years ago. Let's say 48, when Pink Floyd published their "How I Wish You Were Here" album with the song "How I Wish You Were Here," that talks about the feeling of being estranged, the feeling of being alienated, the feeling of being far away from the person I love, for the person I care for, but also from myself in a way. That in the whole, in the chaotic, in the dynamic environment, in the humdrum of work and my activities, I drift away, not only from the others, but also from myself. So I think this, I'm replacing the spatial with the temporal, not how I wish you were here, but how I wish you were now. And I think it captures the sentiment of many people who, thinking about the future generations, are asking the question, will they remember us as those who lived in the golden age, who had everything at their hands and spoiled it and failed to grant a better future? Or will they just hate us, don't care for our golden age? They will just think of us as those who were irresponsible and will not romanticize about our lifestyle and our choices and the happiness we had. So I think some people really wish the future generations could taste the prosperity we enjoy now. This prosperity is in danger because of some of the mega trends that influence every organization, every human being on the planet. Some are more aware of it, some are less aware of it, but all of them necessarily in a more direct or indirect way are influenced by them. The first one is, of course, climate change. And you're all aware of the impacts and of the anthropogenic origins of this mega trend. This means to some people that they will stop being self-reliant and they will need to rely on grace or help or assistance from other people, which in itself is alienating. It also means that some of the resources that we could use to upgrade, to give a boost to the quality of life, will need to be spent on saving lives and saving places. Which, again, means that, yes, productivity, even if we assume a growth of productivity that enables innovation, that saves the future, it means that we are not using the resources to thrive. We are using the resources just to stay afloat, and in quite literal sense in some cases. The growing energy demand, another mega trend that of course affects us now in the energy crisis, in particular when we're thinking about energy transformation and energy transition in our country. We're not so much thinking about energy efficiency, radical energy efficiencies to deal with the availability of fuels, but we are thinking more about making it green. Now we hear that in Poland, but also in other places, meeting the energy demand is impossible with whatever fuels you choose to use, even if you're just burning waste in your home, not in an incinerator, but in your home furnace. And then so far, it has been so that even though energy efficiency increased over the time, still every unit of growth, every unit of economic growth required more and more to be produced in nominal terms. The third mega trend that we're facing, the aging societies in developed countries, means again, and I'm going back to this quote, to what this student of mine said last weekend, yes, of course, it's great that we can have technologies that allow, enable, cocoon the experience of people who struggle with everyday tasks because of their disabilities or because of just declining cognitive capacities that they have. But on the other hand, there's this issue that we're facing, and now when we're discussing in Poland, should we have compulsory payments for social security, well, not for social security, but for our allocations on the retirements, or should we make it elective? Should we make it non-obligatory for some people? This is, of course, the issue of how to maintain a certain standard of life and a certain economic status of people who are beyond their peak productivity. They are declining, but they still live and they still want to survive. Pollution and loss of biodiversity, I already mentioned this. And again, here, technology has been the one to blame for most of it, but we see, of course, through, for instance, our efforts to minimize or manage the pollution, waste through creation of circular economy as a way for technology to deal with the outcomes of its growth and of its expansion so far. Food insecurity is the penultimate, next one will be the last one, I guess, is another mega trend where, of course, synthetic biology promises a future where we can have enough for everyone and we can eradicate starvation or malnutrition. But then perhaps we've already reached the point in which our productivity of food systems is high enough to meet this demand. Somehow we still fail to meet it. And it's one of those megatrends like the others, but in this one in particular, we see how the political seems to go above and beyond what we can achieve with technology. The Netherlands are the most the most densely populated country in the world, and they are a net food exporter. If we had this in Africa, that would be great. But we're we're quite far from this, and the growth of population, like for Thomas Malthus in the 17th century, seems to be the factor that increases the food systems risk, especially in Asia and in Africa. So here, we're talking about trying to catch up incessantly using technologies in synthetic biology, but also digital technologies. But somehow, perhaps we're missing the point. Well, let's see. Let's let it load. Yeah, and conflict. What can I say? We're experiencing it indirectly, but some of us directly even. As we speak. So we already have the foretaste, we already have an idea what it's like if the trend has been for more conflicts to happen, and for the last couple of years we believed it's not the good old war in the sense that we knew, but something else. Now we see that it's both the old and the new. So all these megatrends, I wanted to recap them to see what the stakes are and what is given to us, what is presented to us as the challenge that we need to meet with digital technologies, with software and hardware. And we're talking about software, we're talking about systems that improve the productivity just by optimization of tasks, but also systems that improve productivity by infusing a bit of AI ingenuity and lessening the cognitive burden of people through systems that are almost autonomous, semi-autonomous, or fully autonomous. When we're talking about hardware, of course, except for just increasing the computing power and lessening the price of computing power, there's another thing. There's not just the microchip, but there's also the sensors and all the photonic and microelectronic interfaces through which we allow digital systems to learn about the world around us, and we get new kinds of data that we can then process and use. So all these, both the software and the hardware part of digital technologies, are meant to give us a promise of saving the future. I put on the slide the effigy of Stanisław Lem, the famous Polish science fiction writer, because of the path that he went on and the trajectory of his relationship with the future. When he was in his 30s or 40s, he would proudly claim claim a name of futurologist, someone who, through the study of scientific progress, can make valid hypotheses about the development of science and technology, and then further indirect hypotheses about their impact on society, and further down the road, what the world will look like in more general terms. In his later years, when he was in his 70s and 80s, he grew a little disillusioned with this futurologist activity. He said the problem was that future always turned out weird. It never was as predicted. It never happened, it never was just better or worse. It never was, a given variable taking a more favorable or less favorable value. It was always that the variables changed. That it was always something else happening, something emergent growing out of complexity, and then, of course, making all our previous hypotheses about the future invalid. And this is how he came to the absolutely right conclusion, the conclusion that killed the old school futurology, that the future cannot be predicted because it's too complex and too emergent. And this is why we are left to our own resources of dealing with it every day. We cannot plan for a very, very long term. So this has all been pretty pessimistic, right? But at least we know what the stakes are and what the challenges are. And many people, like I said in the slide with How I Wish You Were Now, believe we're losing, but not all of them. You are also aware, maybe even among you, there are people among us, and they are not a cult, not a sect, they are part of our community. Maybe there's a little person like this in every one of us who hopes radically and really believes that with the right kind of technology, we can make it through. The techno-optimism that I quote here, I equal it, and that may be a bit of poetic license, I equal it with techno-progressivism, a special way of looking at reality where technology has consistently, well, I believe that technology in history has consistently increased our quality of life. Of course, it has lengthened our lifespans, that it's lessened infantile mortality, that it's helped us produce more clean and more efficient systems. And this way, of course, techno-progressivism says, somewhere in all of this, and we're going back to the old Heidegger's hammer, it also means that we have grown, that we are not the same people that we used to be 40,000 years ago. 40,000 years ago, but also 120 years ago, the spider's web was absolutely unmatched in how fine it is, how strong it is in its physical properties. Nowadays, we've transcended it. We have yarn that is far better, that is far, and we can program our yarn, we can program our textiles to be superior to spider's web. Spiders have not gotten much better in weaving over the last tens of thousands of years. We have, which proves the point that we are perhaps a very special species, a species that evolves consciously, that is not just left to our own resources in the game of, in the gamble of evolution. That means random genetic mutations that, create more fit individuals that reproduce better, and then, of course, they infuse with these good genes a bigger pool of a bigger section of the population. That we are evolving not in a biological way, but we are evolving as mankind through the use of technology, and we are becoming with every generation, but also over our lifetime, better versions of ourselves. There's a special part of techno-optimism and techno-progressivism that is called transhumanism. I think all of you are familiar with the term, which means that just like we've enhanced ourselves with tools, or we've enhanced ourselves with drugs, with pharmaceutics, with cure diseases, we've always been doing the same thing, trying to live longer and prosper more, and by individual enhancement that scales up to societal enhancement, we can get better. We can perhaps at some point reach immortality. There are many people, and I like especially to think here not about the most crazy of them, but the more serious ones, like Ray Kurzweil who is one of AI heads of AI engineering at Google, but also a famous inventor and a big proponent of transhumanism, who says it's just a question of now for an individual to live long enough to catch the immortality train. So it's just, it's just beyond the bend. It's just a matter of not dying in the next 10 or 20 years, and then you will be able to catch up, and then you will be able to reach immortality. So this is, of course, one of the most striking, one of the strongest ideas of techno-progressivism and techno-optimism. But I see techno-optimism as, unfortunately, a bit of a dangerous proposition, because just as we all know that some people are fascinated by cryonics and cryopreservation of bodies, some people are, microdosing, very popular now in some circles, is also a form of individual enhancement and the use of technology through, I don't know what, mushrooms or whatever you're using to improve your productivity or your focus and to become more relaxed or whatever you want. But then again, the benefits of technology seem to be, unfortunately, limited to a very, very thin couche, very, very thin layer of society, while the majority either cannot reach them in their lifetime and will always miss the immortality train, because they will die out of curable diseases, out of, because they live in poverty or misery, and for them, the claim that immortality or enhancement, transcendence of human condition is beyond the bend has been as far today as it has always been. So this is the sort of this little dark spot on techno-progressivism, that somehow it misses the point that future in this sense is not equally distributed. The second rider of apocalypse, the second optimistic idea about the future is in the techno-utopianism. Techno-utopianism that claims that the technological benefits are not just for individuals, that they scale up very nicely and that they create synergies that, well, here argue against what I just said about techno-progressivists, that, in the final end game, everybody, it trickles down to everyone. Everybody gets a better treatment. Of course, not at the same time, and it grows slower. But just like Karl Marx said 200 years ago, and then others have repeated later, the end productivity growth just defines what the final result will be, that the productivity, that we will be free, we will be liberated from the constraints of our physical selves, from unjust political systems, from unjust economic systems, and we will all become, each one of you, a free roaming operator, an independent agent, that every one of us will be liberated from all the constraints that we've had so far, and whether this is through remote work or contraception or, cars or whatever other technology that you want to use as an example, it just lets us enjoy the individual freedom more. This is how I interpret the tenets of techno-utopianism. So this is not new, like I was quoting Marx, but there are also still other ideas, other doctrines around that claim that, yes, not only we will be able to improve lives of individuals, not only we will be able to meet the challenges defined by the megatrends, but also, further down the road, we will be able to transcend human condition on a whole society scale and get what reach a certain degree of paradise in which we will live. We will all enjoy the benefits of technological progress. one incarnation of this idea is in the universal basic income proposition, which means we can perhaps have a society in which nobody is left behind, because without work, without actually needing to put in any hours, you will be given access through money or through a basket of consumer goods. So you know something where you, well, an amount of goods and services that will allow you to prosper and thrive. And those who want, of course, can reach for more, can get better treatment, but everyone will, will get a universally distributed access to goods and services. Universal basic income may be a valid economic proposition. We'll still to find out. But also, of course, on a doctrine level, on an ideological level, is techno-utopian, because it claims that productivity growth will be enough to sustain people without work through robots, automation, and artificial intelligence. And the third rider of the apocalypse, and here I don't even need to hold my thoughts, is in the techno-populism. So we started off with techno-progressivist, transhumanist vision of liberated individual, progressed through a more general vision, but now we're going to the nitty and gritty of the political practice. Techno-populism being an ideology claiming that technology not only liberates us from the human condition and the predicaments of our existence, but it also liberates us from the dictate of the elite. So it helps us to rebel against those who oppress us, those who own the cars that we're renting to, who own the apartments that we're renting, who own the companies we work for, who own the, through deep state or whatever conspiracy theory you believe in, who own the political systems and who just have for so long been able to reproduce and breed power without sharing it with it. Populism basically is a way of framing social realities where the liberation of the big, silent and the masses is an end in itself, because from this liberation of the majority will come a more equal distribution of benefits, of economic benefits, and so that the elite or those who run the show don't get a portion that is in that they don't get a bigger cut than they deserve or that everyone deserves. But technopopulism claims that it's not through political reform, but it's actually through the use of specific technologies. And I don't want to step on anybody's toes, but as much as I'm a very big enthusiast of open source and open code, I sometimes feel remotely that the tenets behind opening the source code for digital products and services is about, not withholding it, so not profiting from it, letting community improve it and letting it grow, letting it go out there, which is great in terms of collaboration, but also sometimes offers, a very narrowed vision of economic relations and of politics, in which it's through the opening and the abandon of property and the abandon of rights of the elite that seems to be the only way or the best way for the progress to happen. So once again, techno-optimism, techno-utopianism, and techno-populism all have this thing in common, that they promise to meet the challenges and overcome the challenges of megatrends and other issues that we're struggling with. And at the same time, well, maybe they get it right, but somehow, as you sense from the way I'm presenting it, I don't quite believe that they are sincerely rational about this gambit. Now let's go down a step below. Once I've criticized the optimistic views about the future. Now let's look at specific cases of technologies that are meant to help us, liberate ourselves from the human condition. I wanted to start with autonomous systems. You're all familiar with the household name for autonomy is autonomous cars, where we have systems that are let out not in an enclosed areas, not under control, but getting out there in the open, in the world out there, and roaming the streets with little or no human supervision. So systems that deliver physical outcomes, that deliver physical goods and services, like the service of riding someone from home to work or to other places, but do it without the need for cognitive involvement from a human being. And to start with, I wanted to ask you a little question. I encourage you to go on this. You don't need to use the QR code. If you don't trust the QR code, it's perfectly fine. I wouldn't trust the QR code. But you can absolutely use dementi.com and enter the code 39797264 to get access to the first question. To get to know more about what you think about this and what's your way of using the future, I'm using here a few particular points on the scale of autonomy that was developed in the late 70s. And I let you decide how much autonomy in the delivery of objectives. So we're talking about, doing the objective function. A thing, a piece of software, or a system is designed to deliver a specific objective. We're not talking about it, taking over the world. We're not talking, let it roam and do whatever it wants. I just want to know how much autonomy would you give to delivery of objective technologies in the open world? To execute suggestion if the human approves, to execute objectives and only inform the human about what and how if it is asked, or to inform the human only if the computer decides that the human should be informed. Let's wait to have a few more, but I see that it's pretty clear which one you're choosing. I'm not sure. I just wanted to check how many people we have online. Can you give me a hint so that I know when to stop, so that we do not alienate anyone in the presentation about alienation? Exclusive form of exclusion. But it's not growing, so I think we're there. Okay. So most of you choose level 6 on a 1 to 10 scale, execute suggestion if the human approves. Now, this is something you would accept. So in the way I framed this question, in the phrasing of the question, I left open a hypothesis that we're not only talking about technologies that are available right now, but we're talking also about some hypothetical technologies. Now, I think it's quite human to choose 6. But on the other hand, on my way here, when I parked the car and when I was coming this way, I used an app on my smartphone to pay for parking, to pay the parking fee for the city, not because I'm a particularly, not because of my integrity or honesty, but because I'm afraid of an autonomous system that will trace me and that will only inform the human if it decides to. Because, as you know, of course, the roaming camera on top of a car that goes around the city to check if you've paid your parking fee in Warsaw, but also in other cities, works based on this principle. It only informs the human if the computer decides to. It informs me as a user of a car. If I have not paid, so I receive a ticket. But it also informs the operator only if there are forms of irregularities, if there is an issue. Normally, it's automated. Of course, you might say, yes, but for the owner of the code or the operator of the system, they monitor closely the activity of the system. It's not autonomous in a way that, it's free roaming and completely unsupervised. It's true, but in the delivery of the objective, not in security, not in maintenance, not in improvement of the system, that's all. All the decisions are left to, well, most of the decisions are left in the hands of humans. But in terms of paying for, sending out tickets and informing about errors or bugs in the system or errors in the physical world, for instance, because it also with the machine vision, it can also encounter errors and say, okay, is this a car, isn't this a car? Can I read the registration plate or can I not? Still, I know maybe someone disagrees, but this is level 10. And as much as we struggle to imagine level 5 autonomous cars, which means fully autonomous cars, that will be, in fact, on level 9 of this scale on level 10, in other applications, we absolutely allow and even encourage level 10 systems. Isn't this an issue somehow? What other systems are there that have level 10 autonomy, that inform the human only if the computer decides to? We could think of other systems. In the energy sector, I have clients in the energy sector, in district heating companies, but also in electricity companies. 2 weeks ago, I was meeting president of one of the companies in the energy sector, and we were talking about smart district heating solutions in one of the Polish cities. And we were talking about ways to achieve positive energy districts, which means not on a scale of a single system or of a single house or a single building or a factory, but on a scale of whole districts of major cities in Poland, trying to build a roadmap towards having not only fully neutral in terms of carbon emissions, but also in terms of primary energy, positive districts of cities that will produce more energy and also make it available than they would use. And that client told me, you know what I like the most about it is that in smart heating, we don't even need to focus so much on users' habits. We don't need to, of course, I'm all for convincing them that they should be more energy efficient, they should use less heat and electricity, that they should conserve, that it's good for them because they will pay less. And now, especially in the situation in which we are here, 1 degree less means a lot more than 1 degree. It means a lot more than just 5% less, perhaps, on the heating bill in terms of how much energy you use. He said, the future I want is the future where they don't even know. That sounded great. You don't need to care about energy efficiency because the software in a smart district heating system takes care of it, of itself. But then he went on saying, and if I lower the temperature in the low temperature grid, which is different from the kind of grid that we have in Warsaw. In Warsaw, we still have the medium, so the water in pipes is 60, 70 degrees. The network operated, some networks operated under steam, so at 95, 100 degrees, and the network absolutely has the capacity to operate under 95 degrees Celsius. But he said that the great thing about this 45, the low temperature grids, 45, 50 degrees in the district heating, is that I can switch it off for an hour in a day and nobody will notice. And also I don't even need to do this. The algorithm will do it on its own. Because of course the thermal inertia of the buildings that most people, significant majority of people will not even notice if it goes down by 1 degree for some time. So you can switch on and off and you can balance out the power. So what he was telling me is basically that the autonomy is, and the delivery of the objective is best and works best if you don't even need, well, you don't need to consult anyone. And you can somehow, you know, from the behind the scene steer and let the algorithm optimize beyond what you would allow yourself. Because if you've heard that PGNiG Termika or Veolia, the two companies that work together to deliver heat in Warsaw, are experimenting with, you know, at random moments, switching off the supply of the heat. Seems like, you know, even from an engineering perspective, it's strange. But given the possibility to do it through a smart, autonomous system using artificial intelligence algorithms, it becomes permissible. That's a problem. That's a problem in engineering terms, a problem that has been solved. Getting a bigger energy efficiency with a new way of thinking about it. But also, to some people, it may be a problem in a way that, you know, so then why you have these knobs on the radiators? And at some point, maybe it will be just a knob with numbers that you can turn, and you can do it for your own fun, but it doesn't change anything. And at a certain moment of optimization, maybe the 1% of people who need a little bit more heat or have a different perception of heating will not have the opportunity, the liberty to decide on what level of heating is comfortable to them. Which means that with the advent of smarter and more optimized energy system, we go back, we make a step backward to a situation or to a system in which, you know, one very optimal solution or the only available solution has to be accepted by everyone, even those who relished in the possibility to turn it up because they were born like this, they were born this way, that they feel cold more than the others. So that's about autonomy and about the strange trajectory between making suboptimal decisions to making better decisions and then not making any decisions for the optimization. Replication. I have a colleague in the Polish futurist circles who claims in her book that technology has already become an autonomous and self-replicating system. I was, you know, when I read this, I ran outside to check if this is the case because I was very afraid of this. Well, luckily not. That we don't see too many lines of code being replicated by algorithms and new software solutions being created, you know, because outside of controlled situations, even when we're talking about neural networks and AI learning, unsupervised AI learning, it's unsupervised in the meaning that it's unsupervised within an experiment and not in the world out there. And again here, for the replication, I have a question to ask. How much autonomy in self-replication would you accept in open world technologies? Would you only accept it for maintenance based on defined limited resources, which means that a system can only can only be autonomous in self-replication, not in delivery of objective. We've covered this one earlier, but the system can only use resources from a limited defined pool to keep itself going. A robot can find spares and perform maintenance on itself. A system that blends hardware and software can switch between different energy supplies from a defined pool to keep itself going. Or maybe you would allow it for replication based on defined limited resources. So you would not only for maintenance, but you would allow the system to replicate. And I see this is that seems to be appealing to the majority, the replication based on defined limited resources, which means that we have a closed pool, a defined pool of resources that the system can use, but it can replicate. And by managing the supply of resources, we manage the replication. So if you have one robot that can build another robot, you only supply as much resources so that it can build another robot and not a million other robots, or as many as they see fit to perform the objective function. Yes, majority. So I don't even need to read the third one. You read it for yourself. Replication based on undefined resources. Okay, which means that we are pretty conservative here. You wouldn't accept a situation in which replication can happen out there. This is, in my view, the most interesting proposition, because the management of resources is something that is absolutely natural in a scarcity world. But those who claim who take techno-progressivist positions would say that it's technology should liberate us from scarcity and from management of resources, and the end game is about having open access. So also this also means commons, making data commons, making computing power commons, making energy commons if we have enough, so we don't need to deal with scarcity of energy, liberating the resources, liberating them even from the market mechanism of price, of fixing of the establishment of price, the pricing, so that we can use them wherever they are needed in the most optimal way when they are needed the most. But if you don't agree with the replication base of undefined resources, that means that it will be hard. It will be hard to create really self-replicating systems that would use the resources available beyond what is imaginable for humans. This may be bad for you may be, do you understand that you may be the obstacle to actually meeting these challenges? If you limit the technology so much, maybe we'll not be able to innovate enough, to gain enough productivity. But I'm just teasing you. The other alternative, of course, that was often claimed with nanotechnology is the risk of grey goo. You familiar with grey goo? Grey goo is an idea of nanotechnology in which, a vision of nanotechnology in which an experiment gone wrong with self-replicating nanobots could lead to the creation of a roaming rebel, well, not rebel because they don't intend, but a self-replicating swarm of nanobots that will just consume everything, all the resources available. Of course, energy is the easiest because if they use enough energy and we cannot cut them out, we can, of course, cleanse them with fire, but we don't have too many flamethrowers. I don't think you keep a flamethrower in your office for the case of, unlikely event of grey goo invasion. But short of flamethrowers, there are not that many ways of limiting this. Of course, we don't have the nano technologies available at this scale, and we don't have this yet. Still, the threat of letting the self-replicating machines out there and creating this kind of risk of collapse of supply of resources because they will eat everything is an idea to play with. Now, I was, of course, teasing, but maybe I was serious. If meeting the challenges that I outlined there required optimization beyond human imagination, beyond human control, would we do it? Would we take the risk? A very, very small risk of creating grey goo that will eat everything, the whole biosphere, consume all the energy, and thus, of course, then we don't care anymore for the challenges. How big is the risk that we are willing to accept, to let go, to freely and consciously make the decision to let the autonomous systems self-replicate to meet the challenges that we have, to have enough self-replicated systems that will tend to every senior citizen, to have enough of them to tend to everyone who falls in the streets and breaks their legs so that they are treated in the right way, to have enough of them to have sanitation or clean water in some parts of the world. These are not easy gambits. And privacy. the third component and the final one, because I think, yes, we're reaching the end. This is almost the end. And again, let's have another round of vote. The final one. What is the limit of privacy that should not be crossed by corporate operators? Do you think that any invasion of privacy is allowed if the user consents? And this should be the limit? Or maybe we can imagine that beyond user consent, we could have a hard limit on the evaluation of all the user behaviors? Or you think that maybe somewhere down the road, it's inevitable, consent will be virtual, will not be real, and we'll have the evaluation of all the neurological activity of a human being by, and this is the hard limit for privacy, if you can call it a limit, really. User consent. There's some of you who believe it's the evaluation of all user behaviors is the. Maybe you believe in this because you feel that it's already the case, that user consent is virtual, that user consent is not real, that user consent is just a thin varnish on top of what really is already evaluation of all the user behaviors. Maybe you are right in this case. Maybe we are already there. But if we are already there, should it mean that we should abolish consent? Does it mean that there is a portion of society who, through the knowledge and the consciousness of privacy issues and the knowledge of technology, knowledge how these technologies operate, are allowed to regulate, to control the invasion of privacy, and the majority who should be educated, of course, they should be trained to do this, they should be empowered, but in fact they are unable to grasp it, and they are already, left at the discretion of operators, of corporate operators who already evaluate all the user behaviors, and we need to make do with this. It seems like this particular question is pivotal to the future of democracy. When a couple of years ago I presented a vision of so-called passive participation, so instead of participation and decision making in cities and in communities, we could have just more data bought from corporate operators, and based on this better data make better decisions without asking people, or avoid asking them because they really don't know what they want. They pretend to know, but in fact they have no idea. Then everyone told me that I was representing the corporations who want to sell this data. I wasn't. I think this is really a possibility in the coming years. And I think this is something that we are really, in spite of all the efforts through Solid, through personal data repositories, through the fact that protection of personal data has vastly improved over the last couple of years in terms of regulation, I still believe this may be the case in the next couple of years. And the final question. I want to ask you the most, and leave you with the most important one. So it's not about corporate operators anymore. It's not about autonomous cars. It's about the way we use technology to uphold and enforce human rights. What do you consider the biggest threat? Do you think it's too much power on the side of corporations who can invade privacy and control the behaviors of society? Or is it the fact that we can make our best effort to tackle the challenges that I presented at the outset, but we will not be able to do this because the migrations will create a state of constant turmoil and dynamism dynamics that will escape? Or do you believe that it's the authoritarian rules? So do you believe that at the end of the techno-utopianism and techno-populism, there is, in fact, enslavement, and that this techno-utopian views are, in the end, all false, and they are just a lie to, at the end, take control of us and take away the little rights that we are still left? You're choosing corporatization, majority of you. This one I really don't know. For this one, I have no easy answer. This one I wanted to know what you think. And I'll think about it. Think about it on your own as well. Thank you very much for listening tonight.
Thank you very much. Any questions? Because now we won't have a break room and break time. So, yeah.
Question? Yes. Happy to take this one.
Talking about the autonomy, you mentioned an example of a city heating system and stating that giving more autonomy to artificial intelligence would help to make the right choices, resulting in energy savings at the, like a society level or city level.
Yeah.
But at the sake of reducing autonomy for individuals to be able to set the temperature I like personally. Yes. And to me, giving autonomy to somebody else, to other human or to technology, is strictly connected with trust. And I wanted to ask you if what level of trust I have for you to make the right or better decisions for me than I could come up with myself. And I wanted to ask you, in the aspect of technology, do you see any major differences on how humans build trust with other humans versus how humans build trust with technology and this type of solutions, for instance?
Yes, I have actually quite formed view on this, because it's often been said that building trust with algorithms and building trust with autonomous system was limited by, for instance, the uncanny valley. So the moment of the evolution or development of these systems where we're at, where it's very close to interaction and transactions with another human being, but we know something is off. It's uncanny, it's strange, we are confronted with a feeling of disgust, and we cannot build trust. Well, I think that it's a passing predicament, that this will be solved very, very soon. And when I see, for instance, and this is why I mentioned photonics several times, because I believe that machine vision is improving at a rate now where really we are that far away from reaching empathy, quote-unquote empathy, but some level of emotional artificial intelligence, where this will be absolutely overcome. And I believe at this moment, the persuasive capacity of systems, even autonomous systems, will become so big that, say, for a very thin group of people who will be trained to resist manipulation and socio-technique attempts to influence their decisions by algorithms that will have visual representation and acoustic representation and also haptic representation further down the road in virtual reality, that this is well, I wouldn't say unavoidable, because everything that is unavoidable sounds like, Kevin Kelly and Wired and techno-progressivism, but I see high chances of this happening, and then the problem of trust is resolved only maybe not in the optimal way, not in the best interest of the user, but in the best interest of the supplier of the good or service. That's how I look at this. Although, of course, your mileage may vary in terms of how you assess the rate of development of machine vision, artificial emotional intelligence, and things like this. Any other questions? No? Okay, you can reach me anytime through Polish Society for Future Studies or through 4CF. And should you have any questions, just fire away. I answer emails, so thanks.
Thank you again. Thanks very much. And yeah, right now this is the end of our journey today. So thank you all for participation. Thank you for staying this long. I know it was a long day, but I hope you learned a lot and you gained a lot of valuable information. I know I did. So thank you very much. Yet again, thanks for all the people who spoke today, to our speakers, external and internal ones. Big thanks to our organizational crew. Girls over here, Magda, Ola, yeah. Thank you very much. Thanks also to our sound and vision support. And that would be it. So without further ado, thank you very much. Have a nice evening. hopefully see you next year. Bye-bye.